5 minutes. Perfect, guys. So how's audio yet? I don't have audio yet. So for those of you that are waiting, you can download the PowerPoint with the videos, because there's videos, the QR code. I figured everybody takes pictures anyways, so might as well put something useful in the middle of the picture, right? I'm just waiting until they give me the go signal and I get some video, some audio so you guys can hear me. Mid? All right, cool.
It's turned on, it's just not turned up.
I come to save the day again.
Dude, I am apparently.
It's all good.
It's all good?
We can do karaoke later too with this.
This guy is awesome.
Thank you.
All right. So,
I just gotta talk a little bit closer.
I can do that. How- Hey, Chris, pass that around. How's everybody doing? I'm Todd. Welcome to G-Code, how we program CNC mills and 3D printers. If you guys were in here a little bit earlier, someone gave a very eloquent speech about why all this is bad, so I'm kind of here to teach you how to use it. What's getting passed around the room right now is something I 3D printed last week. It's a new shower head I made for my apartment. It's a little bit of a Tyrannosaurus Rex head, so pass that around. That'll be cool. Intro, I'm Todd. I said that already. I'm a mechanical engineer. Oddly, I'm at a hacker conference talking to hackers about how to code. That'll probably never happen again. I like to build stuff. I like machining, and I like computers a lot. It's my website if anybody really cares. There's some videos, and there's a bunch of, everything has slide numbers, so if you have questions, just shoot me a slide number. I can back up to stuff. That's easy. Okay, a couple definitions for everybody's sake who's not familiar with this. First of all, G-code is a numerical programming language for industrial equipment. Make more sense in a little bit. CNC is a 3-letter acronym for computer numerically controlled equipment. Generally, it's industrial equipment. CAM and CAD are 2 types of software packages that we use to interact with those. And then toolpath, G-code, and M-code are things that are kind of specific to how we use, as people who use CNC equipment, how we use the equipment, how we get code onto it, and how it's represented and actioned upon by the machine. So what G-code does, I actually like this slide because it diverges a little bit from the argument that was made by somebody else earlier. G-code communicates how a machine or some sort of computer-controlled equipment acts in geometric space, right? We're taking basically computer code and we're bringing it out of the computer into the real world. And with the real world comes a lot of constraints around geometric space, coordinate systems, things like that. And the G-code provides commands to the machines that use that to make something. Usually they're in the form of like a go-to location or a do an action, turn a motor on, turn a motor off. What G-code is and kind of isn't. The earlier presenter made a comment about G-code is not Turing complete. Well, okay, great. It's from the 1950s. It's old. Realistically, though, G-code isn't really a language. It doesn't have a lot of the features we typically define as part of having a language or a programming language of some form like C. You can't do variables. You can't really do variables. You can't do logical constraints. You can't do logical statements, and you can't really write functions on its own. It's also not really implemented very standard, even though it's actually an international standard. It's a lot more, a better term to use for it is more of an API. It's also very, very explicit, usually. So here's a very, very early CNC machine, or milling machine, computer-controlled milling machine. This is 1955-ish. It's tape-powered, and you can see the guy standing there. You can see the machine. And you can see the computer cabinet. This is obviously pre-microprocessor. This was running on registers and relays, basically. Everything was encoded on the punch tape, and the punch tape would run. And then there was a button that said rewind the loop and run it again, and you press that and it ran. So history. Before there was computer numerical control of industrial equipment, things were generally made by hand. They were made by artisans. A lot of the use of CNC control is to make things that used to take artisan type work a lot more commoditized, as well as to make it faster, more accurate, and you can actually make things that you otherwise can't. If you're trying to individually run, say, a 3-axis milling machine, you have 2 hands. You can only turn those two handles at once. You can only move a piece of equipment in two directions at once. And even doing that's very, very difficult. With a CNC machine, you can move as many motors as your controller supports. There's machines nowadays that would have 9 axes. And you think about, we have an X, Y, Z world, we have a 3-dimensional world. What they mean by 9 axes is, well, it means the machine can move in 9 different directions at once. That allows you to do a lot more complex things than you otherwise might. So early development work was really funded by NIST, and it was funded by the DoD, which mirrors a lot of, I think, computer development. The real first kind of exposure of this was 1955. A vendor displayed one of these tools at a trade show, which in the machine tool industry is a big deal. To give you an idea, my dad was born in 1955, so this is really, really old. I thought that would get a rise. So 1959, there'd been a number of different vendors that had done this different ways. They'd kind of gotten to the point where there were multiple different standards kind of developing as how we're going to encode information and transmit information to these machines. Somebody first said, well, we should probably standardize this. And actually, the G-code standard came out of the sewing machine, the automated sewing machine industry, not the metal manufacturing industry like you would probably expect for something like this. The next big milestone is just to kind of point out is it's cost, right? A lot of these things, whether they're in computing, traditional computing, or whether they're in industrial equipment, is cost-driven. In 1987, a company called Haas, who are now the biggest, I think they're still the biggest, machine tool vendor in the world, brought a CNC mill out that was under $50,000. That sounds ridiculously expensive for computing power in 1987, but this is a very large machine that can cut titanium, aluminum, stainless steel into really, really intricate and complex shapes. Today, the machine I use that I have access to, that's purchased for I think $7 or $8 grand, and it's the same size, has the same features as that mill that was built in 1987. So, interesting to note though, some shops still run on tape. Tape still works. They're not going to change unless there's an absolute reason for them to. Okay, so give you an idea. This is ferrite, yeah, somebody got it. Ferrite core memory. This is, I think, 1978 is the age of this machine. The biggest problem they had when they were bringing CNC machines and basically computers out of a typical computing environment onto a shop or manufacturing floor was, well, if you welded too near, your ferrite core memory would go blank. That's probably not a problem they had in the IBM mainframes. I don't think they did, at least. Here's another picture, right? Same type of age. You can see, again, enormous control cabinet as you would expect. The size and power of these has pretty much kept pace with modern computer developments to some extent, except it tends to trail a little behind. With industrial computing, you're looking for reliability, hardenability, and you don't want to have it break, you don't want to have it shut down. So they'll wait a couple years. They're not so concerned about maximum throughput on the processors, so they delay things, okay? This is where we're at in the modern day. That's a machine from a company they had built for them out in, I think, Washington, called Janicki. It's now 100 feet long, 20 feet wide, and like 8 feet high. So to compare, right? This is where we were in like 1960. Now it looks like that, and that's like their whole staff standing in there. They have a video somewhere of this running that's just kind of one of the coolest things I've ever seen. So, all right. A little more about the language, so that's what we're here to talk about. G-code is based on a very standardized format. You typically have a line of code that will have a G-code or an M-code. G-codes are geometric movements of the tool. So like a G00, if I said G00 and then gave the machine a set of coordinates, that's going to rapidly move from where it is to another point. G01 is another interpolation command. It will linearly, meaning obviously in a straight line, move from where the machine is to where you tell it to go. So we now have straight movements. The world is basically made up of straight lines and curves to some extent. So we also have G02 and G03, which allow us to move from where we are to where we want to go in a circular fashion, and we can define a radius for that curvature. Basically what we're doing is taking the basic commands that are required to break a physical object down into shapes, into lines that we can follow to cut them out with a metal milling machine. M-codes are kind of, if G-codes are a lot like analog, and forgive my metaphors, M-codes are a lot like digital. You're going to see M-codes like M03 and M04, which will turn on or turn off the spindle. I'm going to back up a little bit from that. There we go. You can also do things like change the cutting tool. Obviously, if we're trying to drill 2 different size holes, we need 2 different size cutting tools. And there's a command built in that allows the software to know when it's reached that point, and it performs a set of kind of actions from there. All right? So this is what it looks like in practice. What you're seeing there is going to be a G02 command. It moves in a circle. We saw the cutting bit then moves down. That's a G01. And it cuts back through the metal. We talk about code a lot, and I write JavaScript every day, but this is code that ends up cutting out tool steel. That I think is pretty neat. And you're going to see, it's just the same movements over and over and over again. Obviously, this is incredibly simple. What it's doing here is just cutting a circle, G02. You're going to see that everything that the machine does is made up of just thousands and thousands and thousands of lines of the same geometric movements. Okay? So it's pretty neat, right? So again, here's how it works in terms of a specific line of code. Every line of code is going to nominally look like this. It has a line number, these do help with practical troubleshooting because it's close to real time. You can sit at a controller and watch the code execute. You can watch the lines of code go by as the machine is moving, as the machine is following the path that you've pre-programmed into it. That line number allows me to say, okay, at line 6,438, it did something odd that I want to go back and fix later. I can go ahead and adjust that. Okay? They don't, for some odd reason, the way it's implemented in standard, they don't have to be every integer. They have to be integers and they have to be sequential, but you could number in units of 10, in units of 5, in units of 2, it doesn't matter. That line number is then going to be followed by a G code. G code is going to be a G or an M followed by a 2 or a 3-digit number. That's what we're doing, in effect. That's move this way, turn this on, turn this off. That's then followed by between, 0 and I can imagine a situation where you use 8 different controlled letters. Controlled letters are things like X or Y or Z. They define coordinates that the machine is going to move to. So if I say G00, X15, Y10, what does that say? Well, this whole line of code says, this is the 10th line or line 10 of the program. It's going to move quickly. G00 means rapid. It means I don't expect for the tool to be cutting there. That's just a piece of information I can give to the machine to let it make some decisions on how it implements this action so that it can do so faster. All right? X15, Y10, that says move 15 distance units in the X direction while at the same time moving 10 distance units in the Y direction. That F that follows it is then a feed rate. It says move at 100 distance units per time unit. And you can pick, right? Because 99% of the world nowadays uses metric, but some people still use inches. You can pick feed rates and you can pick locations in inches and in millimeters, and you just call that out to the machine. It toggles the state on the machine. It's able to implement that because the reality is when it implements these different commands, it's taking that code, which again is more like an API, it's bringing that code in the controller and it's processing it down to a physical action on the tool. That physical action on the tool is going to exist in like stepper counts or servo motion. It's counting out how far it's going to move to achieve the distance that you asked it to, and those numbers are going to be very different, and those numbers are going to be machine specific. But one thing to kind of talk about is the G00 versus G01 versus G03, and again, those are rapid, linear, and circular interpolation. They're really the 3 or 4 primary commands, and if you gave all 3 of them the same coordinates, so start from A, move to B, this is what you would probably get in terms of distances. If we use that X10, Y15 movement from the previous page, the G00 might move in what's called a dog leg. It's going to move as quickly as possible to get to the location it's going. And it may be a situation where it moves along a certain angle faster than it could move in a straight line. G01 is strict about moving in that straight line because we expect to be cutting and we want to go ahead and trace that path that we've called out. G03 is still going to get us the same start and end coordinates, but as we can see, right, it's a circular movement from A to B. Okay, so when we have hundreds and thousands of lines of this, it starts to actually look like a thing. So this is just a mill. It's cutting out a part for an injection mold, and you can see, right, some of these start to immediately look familiar. We see it moving in curves, we see it moving in straight lines, and it just does this, right? It goes and goes and goes. This is a very precise, very accurate machine. It's probably working in the 10,000ths of an inch. As you step down, right, it's moving in the X and the Y. Then it's going to go ahead and step down and make another layer in the Z. We make multiple layers in the Z. And I, as the operator, as the person doing the programming, able to select how it does this, what type of cutting tool I'm using, the RPM of the machine, the speed rate of the machine. It's a little difficult to see, but you can also see it spraying coolant. Obviously, this is be a fairly energy-intensive process. It's, I think, a 10 horsepower spindle to cut this metal out. And if we speed it up, we end up with a roughed out shape that looks like that. It's in a part of an injection mold for a just like a $40 off the shelf Toys R Us drone. Once it's done, right, and again, every single line of this code is just G01, G03, G01, that type of work over and over and over again. We can eventually get it fully roughed out. Let's see if it gets to this point here. Switch tools. And now we come back and we do more steps, more lines of code of a different tool to generate different geometry. They used a roughing routine there, what's called a roughing routine, to remove the majority of the material. They took that big solid block of aluminum and turned it into what you see here. And now it's going to come in and it's going to start profiling this in smaller and smaller steps to go ahead and eventually, we're going to speed this up a little bit, start smoothing out those shoulders, right? We can see it's taken those big step overs, those big step downs from the roughing stage, and it's making a nice smooth part out of everything. Eventually, at the very end, we get a fully finished part that looks like this. If we do it right, you can even sometimes avoid having to go in and polish this as you might in a typical injection mold to make sure that your parts release. So that's the surface finish. That's what it looks like when we're done. You can kind of imagine how many lines of code. Every single time it changes direction, that's another line of code. So it's a little different in terms of how coding languages work. All right, there's our finished part. So how do we use this? And this is another critique G-code got earlier that I thought was kind of a good one. The G-code and machining really weren't built by computer science people for computer science people. They were built by kind of computer science engineering type people back in the 50s for machinists. The machinists, well, they don't really work so well in writing lines of code. That tends to not be their specialty. They're very visual people. They're hands-on type of people. They're more the technician side than the engineer side. So the standardized workflow that people use nowadays is what's called CAD, CAM, CNC. The CAD step is where we go into a computer and we create the 3D solid geometry that we're going to make. And this can be made either through a 3D printer or through, again, a 3D mill. And you guys keep seeing me talk about CNC mills. I'm going to get to 3D printers, I promise. We then go into a piece of software called CAM. I said CAM earlier. It's computer aided manufacturing. People call it machining. The terms are used interchangeably. It doesn't matter. Inside of the CAM software, we're going to define all the individual operations that have to go on, all of those steps. And we're not going to do it individually. We're not going to do it manually. We do it in a visual environment that looks like this, that allows us to select the geometry that we're trying to cut out, select the type of machine that we're using, and then select the size of bit and some basic parameters of how we want to do this action. And it generates those things in yellow and blue called toolpaths. Toolpaths are a really great visual representation of what my cutting bit is going to do, and they're the end result of, those toolpaths are then created into G-code. They're turned into G-code at the end. Okay? Once we have the G-code complete, we take it to the CNC machine, and the CNC machine the CNC controller specifically, is going to take that G-code, it's going to interpret it down into, again, movements of the tool and actually create the part for us. So the CAM programs allow us to kind of have a graphical interface so that I don't have to sit there and write all of those individual lines of code by hand. I would comfortably say that almost no one hand writes G-code. It's not efficient to sit there and write all of those different lines of code to create all of those different steps, all of those different movements. You're almost bound to make a mistake because we're not working in variables here. We're working in specific actual numbers, right? So this is what it looks like. These are the toolpaths. Again, it's code in visual form. It's code for machinists because before we had these tools, before we had the CAM tools, before we had CNC, they would actually, manually cut these out. They'd write down what they're going to do. They'd have a printed out piece of paper that had all the dimensions of their part in it, and they're going to go ahead and follow that along step by step by step. The advantage of the CNC machine is, one, it can be more powerful because you've taken the operator and you've moved them away from the tool and they can sit in a chair and watch it on a computer. That means we can put 40 or 50 horsepower into the machine where previously we might have put 2 or 3. It also means that they're more precise. Computers generally don't make mistakes. They make mistakes, but they're less likely to make a mistake than the human error component at the coding side or the human error component of running these things by hand. They also allow us to make more complex parts that, again, that injection mold you saw, that's not realistically something you're going to be able to machine by hand. It's very, very complicated. You're going to rough it out by hand, and then you're going to come in and probably manually finish it with a grinder till you get close to the right shape. With the CNC machine, it doesn't care the geometry we give it. It will break it down into numbers, into locations, and it can then implement that into something that, is not something I could machine by hand or anybody could machine by hand. All right? So, once we have it done in the CAM program, there is one more step. I mentioned that, generally it's sort of a standardized way of coding. We go through, at the end of the CAM step, before we get to the CNC, what's called a post-processor. And the post-processor is this unique invention because despite the language being standardized, nobody implements it the same way. Different CNC tools want different things to be done in different orders. They want instructions to be given in very specific ways. So we basically take if G code is English, and I gotta apologize for using this metaphor, the post-processors tweak our kind of basic dictionary English into, New Yorker or Southern or California or Valley Girl, Australian, British, whatever the equivalent is for that machine. Those, and it's basically a translation file for the specific machine. It's going to do things like, if you see down here, on a circular command, the G02 and G03, you can call out the radius of your circle in 2 different ways. You can call it using an R. R allows us to call it a specific radius, right? Simple radius. You can also call out a center location. That's basically forming an arc that moves about an arbitrary center that you define. Some machines prefer one method over the other. Some machines allow both. And there's certain advantages to using different ones that are going to be specific to your machine and your code and your use. Okay? So here's what it actually ends up looking like. And this is this is like 30 lines of code out of a 6,800 line long program that machines something about 1.5 inches in diameter. So this is simple by the standards of G code. The first part, everything up through, I'd say, about N55 is really a preamble. It's saying turn the machine on, what coordinate system, what axis system am I working in, what unit system, am I working in inches or millimeters? Then we get into, like line N75. Okay, that moves the tool down 3.8 thousandths of an inch. Line 80 then moves it 18 thousandths of an inch in the X, 0.4 inches in the Y, and down 7 thousandths of an inch. You can see why we don't want to write these things by hand, because from N80 down through N170 is the same basic concept, right? We see G1, G2, G1, G3 over and over and over again with just different numbers in there. And because we can't store variables, because we have to feed it numbers, writing this by hand is troublesome. So the other way to do this, everything that we talked about CNC machining is what we call subtractive manufacturing. You can also use this for additive manufacturing. You could, for example, 3D print a house. This is a concrete 3D printer. What you can see here starts to immediately look familiar as we learn about G code, right? That's a G01 command. That's moving in a straight line. That's moving in a straight line. It's just straight line after straight line after straight line. And it keeps going until you've actually built something up. If you guys are still passing the shower head around, right? That's the same idea. This is another little 3D printed set of parts. I use these for when I teach classes. These are printed as a teaching aid, right? They're just the same thing. If you take them apart and break them down, they're just layer by layer. The machine went ahead and traced that path, and traced that path, and traced that path, and stepped up in space each time. So same idea, right? You don't have to make really boring basic shapes either. You get a robot arm, which robot arms run on G code too, and you can print or just have it move in 3D space. So we can see it's kind of printing a freehand arc right here. And what you see when you put it side by side with the CAM software is all it's doing is tracing and replicating that path. It's really an API to communicate between the CAM software that you guys see on the right, I gotta do left and right here, and what you see the machine actually executing now on the top. So that's the advantage of the CAM software, is it's a very, very visual way of coding for something that ends up being real and physically manipulable in kind of the visual phenomena. And so this is a really cool metal 3D, low-cost metal 3D printing. It's basically a welder, and it just goes ahead and prints metal in the path that we tell it to print. Okay, so CNC printing, CNC cutting versus 3D printing. They both use G-code. And the reason when 3D printers started to come about that they used G-code as kind of the default method of interpreting is, one, it's well-founded, and two, it works. It works really well for what it's trying to do. It's not necessarily elegant. There's a lot of features it's missing, but it works for what they're trying to do, which is geometrically move in this case, a print head about. It's also very much standardized in industrial equipment, which means that when they brought 3D printers into kind of the first set of users of 3D printers, which were really big industry again, they know how to code in these environments. They know what the code looks like. And the only difference between what we call a CNC or like a machine tool and a 3D printer is whether they remove or add material. MakerBots, for example, run on G-code. If you were to open up a MakerBot file, it's not going to look like it, but they run on G-code. Okay? So the eventual goal, in my mind, would be we get to a point where we're doing something like this. This is made by a company called Moriseki. It's a combined 3D printer and 3D CNC mill. So it goes ahead, it says, well, this is the rough shape that I want to create. Rather than having to go and cast this out and make a mold and do all that work, you can go ahead and just 3D print it. I think it's 3D printing in titanium right here. It's 3D printing a part for a jet engine. So you print the flange, you print a basic shape, then you can swap out the print head, and it'll go over, and this is just an M06 command. This is one of the standard G-code commands. Picks up a cutting head, and if it switches back to video here, we can then cut out that kind of rough or net 3D printed shape to get exactly the shape, exactly the surface finish we want. We use these technologies as kind of cohabitive technologies to get the best results of each one. You can smooth things out, and then once you're done smoothing things out, you can go ahead and switch back to the 3D print head after you drill these holes, because these holes, if we made that bigger diameter, that bigger hole wider, if we had it kind of move outwards like a cone shape, you can't get to where those holes are cut. So I 3D print a rough shape, I modify it with the cutting head, then I 3D print more, and I 3D print this bevel or cone shape that prevents me from accessing those holes directly, and I just keep switching off back and forth until I get a complete shape. This is going to take forever. I think this is, when they released it, it's like an $850,000 piece of equipment that I will never ever get to touch in my life, but the ability is there, right? We now have the ability to both add material and remove material at will to create a fully custom shape, because we take the advantages of each side and we match them together, and we just use G-code on both sides. Okay. MakerBots, because I'm guessing a few people in here have MakerBots. First thing to know about MakerBots, they do use G-code. What they do, though, is they have a very weak processor on the board. They've decided not to dedicate processor resources to actually interpreting G-code, even though the processor is capable of doing that. Instead, what they do is they compile that code down to almost a serial bit stream. That serial bit stream is easier to interpret, it's faster for it to interpret, and so it's able to print faster and keep up at the processor side, despite the fact that all the commands are the same. MakerBot has also implemented some specific things, and they publish these, how they implement G-code and how they implement all the G and M codes to make it work with something that's kind of not the original intent of G-code. For example, they have an extruder rather than a cutting head. That M03 and M04 that turn on our CNC mill cutting head are useless to the MakerBot. So they implement M101 and M102 and M103, which turn on and turn off their extruder head. Anything that's above 100 are pretty much they're typically used as vendor or machine-specific implementations of the G-code. There's also one on here, and I forget the exact number, but there's a MakerBot-specific M code. It's like, I want to say M316 or something like that, that will play a song, which, you know, I don't think the Muraseki machine is going to have the ability to play a song. It's kind of different use. So, you know, if you actually would export it before it does that compile step, it looks very similar. I use a piece of software, I don't use the MakerBot software, I use a thing called Slicer that is CAM software to, rather than computing machining code to remove material subtractive manufacturing, it computes a shape via additive manufacturing. It slices it into individual layers that it then prints. The really nice thing about Slicer and about the G-code that's generated from MakerBots is it's incredibly verbose with commenting. So if you wanted to learn about this, go make one of their files and you can just read through and it tells you exactly what it's doing. So it says, you know, this G-code was generated using this version of this software. That's actually somewhat rare in CAM software. It says, you know, what the effectively SkyneForge 50 is kind of like a compiler. That's what the compiler was, when it was done, what it was done for, those type of little details. It inserts all that into the code, which I really like because most of the commercial grade packages don't do that. All right, so the end result of all this, and I just like this video, and it really tells the story of kind of what this stuff can do is, well, if we start with about 120 kilogram block of aluminum, what can we do with it in G-code? Well, this is a 6-axis CNC mill, right? It's able to move the table that has our part mounted on it back and forth in 2 directions. It's able to rotate it, and then the head of the machine, you see with the cutter up here, is able to move up and down, left to right. That's 4 and 5, and it's also able to rotate in a 6th direction. That means we can move it in 6 different directions, and by doing that, and by using this code to our advantage, we can develop very precise, very intricate shapes. If we flip it over, remount it, we're able to actually machine on all the different sides. So what they're machining here is basically a motocross helmet. This is a demo video for one of the tool makers. You can see, right, we're using a very heavy tool here. It's generating a lot of material. It's removing a lot of material very quickly. And then we switch over and use a very thin, very long bit so they can reach into intricate areas and you can move different parts and move the cutting head and move the part itself in different directions to get the orientation you want. You can see it's machining inside of the part now. And what you're seeing there in that little inset is that's the code. Those are the tool paths that the machine's actually going to follow. So I know it's a little difficult to see when we project this up, but they're actually able to take it to the level of detail where they can engrave. They can move in different directions and at different speeds to change the surface finish. So you end up with a surface that has no visible, no perceptible difference in depth, but it has a different surface finish, and that different surface finish gives it a different look, and you can actually basically print text on top of it, right? You see these big exaggerated movements to give it the orientation that it needs, and then you just see little tiny movements. Every single one of these to take this from a big block of aluminum down to, I think it was like a 13 kilogram helmet, so we're losing like 90% of the material, is an individual line of G-code. So, questions? That's a little faster than I thought it would go. Yeah, you can do this with G-code too. I don't see, it's really hard for me to see. Question?
So, given that everyone's using the CAD/CAM software, what is the benefit of knowing and understanding G-code? Do people go in and tweak it manually?
Yes. The benefit is a couple things. One, my mindset is I like to know what something's doing. That's why most of my stuff at home doesn't work because I've taken it apart. If I know the code, I can understand what it's trying to do. I can better understand the options inside of those programs to make it do what I want. Additionally, when you actually run the machine, you're able to, I'm going to keep playing this, you're able to watch on the CNC controller screen what different commands are going by. And if you can identify where there's an issue or a glitch, you're able to go back and fix that. One of the common things that can happen is, when people start to learn about this, they're always asked to write a program to drill 2 holes in a piece of material. And if we mine that out, it's go to the location of the first hole, drill the first hole, and then what? Go up. A lot of people forget the go up part. And if you are still down in your hole in a big piece of titanium and you try and tell it to go to another location, The machine's going to go there, but it's going to leave the cutting bit where it was. So that's why you want to know what it's doing so you can understand what it's doing, but you want to try and avoid writing it by hand so that you remember to come out of the hole, because the software doesn't forget to do that. Question?
Has there never been an attempt to do a higher level language, or is there just too much inertia?
There's a lot of inertia. When I said there are companies that still run tape machines, I'm not joking. Back when I was in college, I actually worked at a place that still ran mechanical machines. They'd follow a path that wasn't computerized. It was cut into a steel cam, like a camshaft, and the machine followed that path. Really, the perception is there's no need to change something if it doesn't work, and it does work very well. There, however, has been an attempt to not necessarily do a higher level language, because at some point you have to describe the features and the parts that you're trying to cut in some sort of geometric space. There has been an attempt, though, to do a higher level language that has more features, that allows you to put into place more complex geometry than just straight lines and curves, because if you want to generate a compound curve, the perfect example of this would be like the shape of a wing, the cross-sectional shape of like an airplane wing, right? It gets thicker and then it gets thinner. That's not a continuous curve. So that's very difficult to implement in G-code, because it's not a continuous curve means you can't do it with straight lines, and you can't do it perfectly with curves. So you select the best of both worlds, and you break it down into thousands and thousands of little individual curves. STEP NC is another NIST project that exists for the purpose of trying to kind of get higher level mathematics into the code, because the processing power has come up to the point where they can do that now. Question in the back.
Yeah, just a follow-up to that. I've seen machines where they get driven by a floppy drive, whether you're using floppy drives. But no one has floppy drives anymore. So there are occasionally companies that go with a crazy product where if you put a USB key in place of where the floppy drive was, and it simulates a floppy, so the machine is happy.
That's very true. There are also cutting tool vendors that sell floppies specifically for this purpose, and you'll see them. They offer drill bits, what's called end mills, which are basically metal cutting tools, and then they'll offer floppy disks because they've stockpiled them to keep some of those machines running.
So how do you do that machine where it did both, where it was 3D printing and the CNC machine? How is it printing? Was it like
it's what's called laser sintering. So yeah, in that machine, because they can't have a powdered bed, the way you typically print in metal is you have a laser or a heat source shined at or pointed at a bed of powder, and it prints a layer, then it lowers that down, sweeps new powder on top, and prints a layer. It's a little bit wasteful, but it's the way it's been done traditionally. What that machine kind of does is it actually injects the powder alongside it, so it's spraying the powder into place, crystallizing it, and then it vacuums it back out so that you don't clog up the works of the machine, because you can't have a ton of extra powder sitting in there. Yeah.
What about things like acceleration? So some of the G-code have feed rate, and at what point in your process do you have to understand something like how fast the material can tolerate?
There's a couple different points on that. If you're talking about the material, what the material can tolerate in terms of feed rate before those nice clean surface finishes turn like cherry red and start to glow from heat, that's machinist experience. You can adjust it on the machine, but typically that's something you're going to pre-program to say, well, I have this cutting bit from this vendor, and I know my tool, and I know this material, and I combine all of that knowledge into one cohesive number that says go this fast. From the acceleration component, most of the acceleration is actually handled by the machine. If you try and give it a feed rate, so basically a velocity, if we talk about the three, position, velocity, acceleration, if you give it a velocity that's too high, the post-processor should catch that and it'll reject it. I've had things where if you ask, a post-processor to do something that machine's not capable of, it'll throw a flag, it'll throw an error and say, you just asked it to do something that it can't do, stupid. From the acceleration side, though, they've moved that pretty much downstream because every tool moves differently. Some of them move the cutting head, some of them move the cutting bed. The machines handle the velocity and acceleration on their own to keep effectively a vector speed that matches the speed you gave it while hitting the points as accurately as possible. They'll handle acceleration on their own from the feed rate you give it. Yeah.
Are there commands for homing or calibration?
Yeah.
When you set the machine up?
Yep.
All these things?
And typically, if you, I'm going to go back a slide here. I really like that video. Let's say it's having fun. I need one of those. So if you watch at the very beginning here, it's not cutting anything. What it's doing is a probing routine. Back before probing routines existed, and wow, that sounds horrible, you would manually locate, say, a corner or a measurement point on the machine, and you say to them, and give that machine and say, this is the starting point. This is your zero, your origin of your coordinate system, and all of your coordinate system in the G code is built to work from there. And you can give it specific commands to take care of that. Nowadays, most of the machines have the ability to insert an electronic probe. They know the general box in which your part is, and then they'll go and find the scope and the size and the shape and the orientation of your material within that box, so they know exactly where to start from. And that removes a source of error, because if I'm making, say, 100,000 of these, and there's a couple thousandths of inch of wobble in how I mount that part, I'm going to end up with 100,000 different parts, right? At some level, they're different. And whether that's tolerable or not to me as the machinist, to me as a manufacturer, is why I might go use something like that. Okay. Question?
What prevents against bugs in the generation translation between 3D object and moving the head into a wall and destroying it? Looks like a certification process that you go to run an $80,000 machine or $200,000 machine so you don't destroy the head with bad G code.
There's a couple ways. There's secondary products that do check for that. A lot of the CAM programs nowadays have routines built in where I can say, I can define the scope and the space of my machine, and where there's cutting bit and where there's supporting material and where there's electronics, and it will make sure it avoids those areas. As you run through, you can watch for collisions, and the software will detect when the non-cutting parts of the machine collided with something, and they'll detect, flag, and throw an error. There's also the ability to, and the way it was done before was, you would simulate this. You sit there and you can run it line by line, and you can watch the machine move, and you can watch that all your features create correctly, watch that it does this machine. It basically simulates this as kind of almost like an animated movie on your computer to watch that. And you'll see people in production environments say, they'll sit down and watch every single line of code execute, because if I'm one engineer and they pay me to sit there and edit G code, and I'm making 100 or 200 or 1,000,000 of these parts, if I can spend a day trimming 4 or 5 seconds off the machining time by, yes, making sure it doesn't collide, but also make sure that it doesn't come that extra inch above the surface, that's going to save my company money in the end. So a lot of it's still done pretty manually, actually. In the last 3 to 4 years, you've started to see that change, but a lot of it's done manually still. In the back?
If the lines of G code are advanced one at a time, how does the system maintain sync with physical reality, timing, velocity, something?
They look ahead. They're told look ahead. So while it's executing one line of code, it's going to that physical location that you've called out. It's also looking at the next between 3, 5, and 10 lines of code to say, what am I, to the question about acceleration, what do my acceleration profiles need to be so that I keep this constant velocity and I end up at this same point. And that's really one of the big advantages of this is that, if I'm a machinist, I can move really one direction precisely at one time. If I try and machine a circle by turning the X and the Y handles, I've met people that can do that. They're really good at their jobs. I can't do that because you have to move them. It's like an Etch-a-Sketch.
So this is logic built into the machine.
Logic built into the machine.
And what about off by one errors that accumulate since it's all delta, it's not absolute?
Well, there's actually 2 different ways to run G code, and you can call out either one. Traditionally, nowadays, you run in what's called increment mode, where it's absolute. The other way is you can run in, increment mode that is delta from location to location, A to B to C to D. You can also run in absolute mode. However, the way the machines work nowadays, they're not just blindly moving. It's actually a closed loop. It's not open loop movement. It's closed loop movement. So they see where they're getting to, and they'll start to learn. They have values inside the controllers that allow them to correct for wear over time. Because if I run this table back and forth 50,000, 60,000 times, it's gonna start to wear. Things are gonna start to change. It's a mechanical system. Transistors don't tend to wear out. Mechanical devices do a lot more. and it will compensate, and actually routines built in to say, well, I'm missing by this much, and it'll put in those variables, it use those variables to add up and keep that correction in place.
So within G-code, there's no room for sensor feedback. I can't, on a 3D printer, I can't say, let's take this, for this part of the print, take it up to 240 degrees.
You can.
And then wait, and the G-code will wait until it gets to 240.
Yes, so typically the way that would work is it'll wait until a line of code has completed executing before it begins the next line of code. So if I said change temperature mid-print, it'll get to that line, everything will stop. It'll toggle the set value, the latched value for that inside of the memory of the CNC controller, and then it'll wait until that's accomplished. Once it's accomplished, then it'll continue. That's the default state.
So I could also implement something like move to the edge of the piece, wait for the edge sensor to trigger, or something.
So like a homing routine, yeah. So typically the way that would work is you'd say move in a certain direction at a certain speed, and then the machine's smart enough to know, not in the G-code, but in the machine controller, when I trigger this limit switch, like on your MakerBot, if you home your MakerBot, that homing routine is just a single line of G-code, and that's why I tend to use the API metaphor. You call a homing routine, and the homing routine is not stored in G-code, it's stored inside of the CNC controller. And every CNC controller is going to have that a little differently. If the homing position is, say, up here versus down here, right? They're going to execute it in different ways, but you're going to call the same M code in that case. Good on questions. One more right there, behind you.
H.O.P.E. has announced that they're going to start selling MakerBots.
Yeah.
Are they going to have G-code on Saturday mornings?
I think the idea with MakerBot is to try and get people away from knowing how G-code works. If you use the MakerBot software, you never see G-code, but I don't know.
So in that, I'll be designing more of an object.
Yes. Mm-hmm. And it's much easier to do that for 3D printing because, if I pick my 3D printed parts up here again, right? These are printed with one filament size. That's effectively our tool bit size, right? If I want a 3D print or not 3D print an area, it just prints and prints and prints. You can have 2 or 3 print heads. You can do multiple colors nowadays, but generally that's different from machine tools in that in a machine tool, if I want to drill a 1/4-inch drill bit or a 1/4-inch hole, I have to have a 1/4-inch bit. If I want to drill an 1/8-inch hole, I have to have an 1/8-inch bit. And then controlling the way it implements different features, there's a lot more options and a lot more complexity in doing the machining side of it than there is in doing the 3D printing, just in terms of how the G-code works. If you're to open up a machining file for something like this versus a 3D printing file for something like this, there's going to be a lot more in the machining file that is setup and configuration and information to the machine on what it's doing and how it's doing it, not just movements. The 3D printing world is very, very just movement driven, and it just feeds plastic or PLA at a constant rate. A question?
How is backlash
So it's not handled in the G-code. G-code is very, very explicit. Again, it's do this. I don't care how you do it. I don't want to see that you did it. I trust you as the computer that's running the machine to do it. The machines themselves will compensate. Good machines will compensate for backlash. Backlash is if I change direction, any mechanical system has a little bit of slop in it. So if you change the direction that you're feeding in, well, it has to pick up that slop before it physically starts moving in the other direction. Okay. Is that it for questions? Cool. All right. Thank you, guys. Machine control?
Software worth talking about?
Hold on a second.
Actually, there's this little CNC thing.
What's it?
It's a Dremel on a, a screen.
I can do you one back. That's not what I do it on my. You feel Autodesk? Okay, Autodesk has a free CAM program called HSM Express that'll write G. Additionally, there are some open source ones, like Slicer is open source for 3D printing. I don't know of a open source CAM package, but I'm sure there's one out there. However, Autodesk is really, I use Autodesk stuff, is really good about
loose definition of student. So if you go on their website, just call them a student fellowship. Yeah.
see that actually. Went to petitions the day of yesterday, and 3 people have been in that petitions. They still bumped into everywhere. So I don't know, a lot of people bought them, but then it went to it's like too British for it.
Even here, I was at my official. But I didn't really.
Yeah. Yeah, same. Much about terror. Oh, no. They are prescription. But the ones I wanted to take from the treatment, I wanted them from Paris last week for the early transition. The sort of early translation because so you look at the site and it gives you sort of basic French and then actually the nice thing with it is it seems to start on the Spanish thing. French. Right, okay. So I have to keep swiping to change it over every time. Yeah. Oh, yeah, so to do that. That's fine. It's very much the time. For something in pizza.
Okay. So I just got the magical sign. We're going to start now. Everyone who doesn't want to talk about post-privacy but wants to hear about Burning Man should probably head out of this room right now. So we're going to talk about post-privacy. First, if this thing works. It never does. I can tell you what's on the first slide anyways. My name is Jürgen Goiter or Tante, depends on whether I'm online or offline. Okay. I come from Germany, which is this weird country that brought you Club Mate, which some of you might have enjoyed here. It's probably one of the few good things that Germany has ever produced. The fact that I come from Germany obviously is going to influence some of the examples I'm going to give you, but those should apply to basically every democratic country on this planet. Again, I should excuse my, I want to ask you to excuse my slightly bad English. Obviously I'm a little bit nervous and I don't have as much practice in it as I'd like to have, so bear with me. And if anything is really unclear, ask. Real discussion I want to push back towards the end of the talk. I'm a scientist at a German university, a tiny one nobody's ever heard of, but I'm not talking for my employer here. I study computer science and philosophy and spend a lot of my free time, as limited as it is, thinking about our lives as networked beings. That involves things like how we relate to privacy, digital ethics in general, and all those kinds of things. A quick disclaimer beforehand, we are speaking about democratic societies here. We're talking about countries like the US maybe, or most countries in Europe. We're not talking about Syria. So when we are talking about whether post-privacy is reasonable or not, we're talking about societies where people are free to express opinions and that kind of stuff. So don't apply that to people living in under oppressive governments, because then bad things are going to happen. Also, this isn't a binary switch. I'm not going to talk to you here and blow your mind, and from now on you're just going to laugh at privacy, because it's a social process. It's a process of change, I believe, and so take everything I say here with a grain of salt. It's not this one thing that I tell you and that will change your life forever. some people might have heard the term post-privacy, so before we start to really dive into the topic, I want to attack some of the strawmen that usually go around, because there are some very vocal people who speak about it, even though they obviously are not willing to give it proper thought and proper representation. So this is kind of a reset button for all of you who have ever heard something about post-privacy from the contra standpoint. One of the ideas is that post-privacy people are out there to take away your secrets or your privacy, because it's there and it's awesome, and then people like me, all powerful that I am, come in and take away everything that you love and hold dearly. Those people also say that it's about banning encryption, that it's about the transparent society where everybody is supposed and has to know everything about all of us, which, as everybody who's ever heard a William Shatner album knows, is just too much knowledge. And people think whenever they talk to post-privacy or about post-privacy, they say, look, they don't even give out their passwords, so they have something to hide. Ha-ha, we've got them, which is also a bogus argument, as you will see at a later point. So nobody's really taking away anything from you. That's not what we're about. It's also not a conspiracy by Google, Facebook, the NSA, the German Verfassungsschutz, or whoever you want to think about. It's nobody in the post-privacy fraction is a friend of the NSA or whatever they are doing. And we're also not out here to lure you into giving your data out there into the internet to be victims of whoever corporation or government you can think of. That's all a representation, a misrepresentation of what people are talking about when they mean post-privacy. But before we can really talk about what post-privacy means, maybe we should look at privacy for a second, so we're all on the same level here. Privacy is key to many debates of our times. I don't want to over-exaggerate here, but maybe like half of the talks in this conference deal with privacy in some way, shape, or form. When I talk about privacy, I speak on a very high level. I'm speaking about the level where we are, the people, where people interact with each other. I'm not talking about privacy on a technical level, where people try to build protocols, how computers interact, or encryption technologies. It's cool that it's there, and we all are obviously building upon that, but that's not really the level I'm focusing on here right now. Privacy is considered to be threatened a lot these days, and many people sitting in this room or running around here are defending it at conferences like these or in other situations. It is obviously a human right. It's written down in the Charter of Human Rights that the UN has given out, and, for example, the European Union. Okay. And the European Union as well. Every human being can expect a reasonable amount of privacy, whatever that means, and whoever is supposed to decide what reasonable means in this context. But what is privacy? Apart from obviously a mechanism that we have invented, a tool to protect people from, for example, discrimination or powerful entities that could overwhelm them or could force them to do things they don't want to have done to them. The definition of privacy there isn't one, but I'm going to look at two of the main aspects that define what most people probably understand as privacy. There are always some definitions that are out there or that try to phrase it somewhat differently. Also, there are slightly different representations. I just picked two at random, somewhat random. So let's go through that. The first aspect of privacy has been formulated in 1870, I think, 1890? 1890 by two lawyers, Brandeis and Warren. This is Mr. Brandeis right there, Louis Brandeis, who later became, I think, a judge at some high U.S. court. And that was the time when photographic cameras started popping up, and people started to get worried about others, peeking in and taking photos, and you could never be sure that nobody would take a photo while you were somewhere where you weren't supposed to be. Might remind a few people of the debates around Google Glass that we have been having lately. And Brandeis and Warren defined a right not to be seen. The implication is that you have the right to retract to a space where nobody looks at you, where you can pull back from the public eye, where you can be whatever you want to be, with whoever you want to be, talk about whatever you want to be. That is basically sacred. Obviously, that right is connected to things like the privacy of correspondence, of your mail, and also has been adapted to many electronic ways of communication. So it's basically the right of the individual not to be part of the public life for a certain amount of time, and if he or she wants, for basically ever, if he or she can do that. The second aspect of privacy, and here I'm using a sentence that James H. Moore, who's a professor for intellectual and moral philosophy at Dartmouth College, said, the right to control access to personal information. So there is some sort of personal information, and we all know what that is. It might be your address, your emails, your Facebook relationship status, whatever you can think about. That stuff, that data stuff that is out there about you, that somehow concerns you in some way. And the idea is that if it is about you in some way, you have the right to decide who is allowed to access it and for which purposes. So if you put a photo of yourself out there, you can decide that only half of your friends are allowed to see it, and they may not copy it, and they may not print it, and are not allowed to put like a mustache on you or something. In the legal kind of way. Obviously, we can't really enforce that, because if they don't show it to anyone, we never know that they drew something on our face. What privacy isn't, obviously it's not lupus, but apart from that, privacy is not secrets. Secrets are things that you have with others, things that either you do not share at all, like your passwords, which are your own secret that nobody else has because you use it for authentication or something, or is information that you share with a very selected few under the assumption of non-leakage. It's a thing of trust. You establish, these are my friends, I trust them, I can tell them this without them going all over town and telling everyone else. That is not about privacy, but basically a form of contract based on trust. It's the opposite of privacy, basically, because privacy gives you a right. Nothing you have to bargain for, nothing you have to haggle about. Privacy is your right, no matter what. And privacy is about data explicitly known by others. Privacy allows you to control data that you put out there that you can say not everybody is supposed to use in any way they can think of. Secrets are something you don't actually put out there. So it's a slightly different thing, even though it's obviously in some parts related. The first aspect of privacy allows you to have secrets, obviously, because they also are a way to retract from the public view, because you're not saying everything that comes into your mind most of the time, probably. Also something that we have to realize, even though it doesn't really change a lot, it's not a force of nature. Privacy is a social construct that we came up with. The first legal thing came up in 1870, and mankind hasn't always been focused on this idea. Think of, for example, the Romans. They had slaves and they had sex in front of their slaves. They didn't care. They even had sex in front of each other. They didn't have this idea of privacy that we have. It's a very new, a very recent invention. That doesn't make it any less valuable or worse than anything. Most of the cool things in this life are social constructs. It's just something that we should realize when thinking about how to deal with it. So history has given us many, many examples for the importance of privacy. And you can see them all over the planet. Obviously, I know the German ones best, so I'll probably point at most of the German ones here. When looking at what privacy means today and how we should see it today in this digital age, we should look back at history to see which events or which things formed our idea and our concept of privacy, to understand better what it really means and what we want to achieve with it. So these are two very German examples. I said the only good thing coming from Germany was Club Mate. The left picture from you is the some Nazi thing. The Nazis were, in spite of what Indiana Jones movies tell you, not stupid. They used basically every tool they could find to reach their goals. They professionalized psychology, for example, to an immense amount, where they try to find new ways to influence people, to control people through psychological matters in a way that was more professional than anyone had ever done it before. They did a lot of medical research, and they used every technology they could find. In Germany, they basically rounded up people they didn't like, Jews, gays, basically whoever said Nazis suck, and took them away. When Germany attacked the Netherlands and took over, the Netherlands always had a very strong public register of people. it's useful for a government to know where people live. It's data that you can use to make decisions on. The Netherlands had a flag in there that marked your religion. When the Nazis take over, this flag religion becomes very, very dangerous and deadly, because it made it very easy for all the Netherlands Jews to be rounded up and deported, and most of them, but many of them killed. And so this is, in Germany, you cannot think of anything Germans ever do without thinking about that part of history. This has influenced many of the ideas of how we think about privacy. We always have this data can kill thing in the back of our head, because we might know people that lived then. My grandparents lived at that point, and that influenced the European perception, because the German perception obviously influenced the European perception a lot. The right example is the logo of the Stasi, the Staatssicherheit in the in the German Democratic Republic, East Germany. The Stasi was a very they used technology obviously to spy on people, and they used people to spy on people. They plotted people against each other to inform on each other, and they gotten. If you heard the talk of Thomas Drake earlier, he talked about the huge archive that he saw, where they basically noted down everything, whoever talked to whom, who had an affair with whom, people who didn't matter to anyone, They're just, she's selling stuff and he's repairing cars, and they had an affair, so it's noted down there. These days you can look at your file, and it's grotesque what they noted down. So we obviously have more examples of that kind all over the planet. So we've seen what governments can do when they get data. And so especially in the European tradition, privacy has always been a lot about defending the individual against a government that might overreach its legitimate purpose. When we thought about those privacy rules and how we should write them into law, the only entities that could effectively use data were the government itself, because they had the resources to have people sift through stuff, or they had computers very early on. The military, because they also had the computers, and banks and insurances and a few companies. This picture actually is of Volkswagen, who had computers very early on, even though they didn't really look at the data from people mostly, but they used it to build new cars. In order to protect against these data powerful or data capable, the government and also big corporations, a bank or insurance can really ruin your day if they, don't give you a loan when you need to pay your rent, or when you want to buy a house. We decided to push back and build especially in Europe, very strong privacy laws that allowed the individual to establish control and to get data potentially removed from the public record or from databases, or even to make sure that it's not gathered. So that is an example of how the past influenced how we think about privacy a lot. Privacy is also something that in the past and in philosophers' discussions always has been thought of something that allows us to think freely. Because if we're sitting there alone, like this also monkey, I like monkeys, by the way, so there's going to be a few more monkey pictures coming. If we sit there like that, our first ideas tend to suck, because they're just this spark of an idea, and we have to work on them to make them good. And many people feel threatened if they utter the first ideas, because others will shoot them down because they are not yet fully developed. And the common sense is that we need this room of privacy to draw back, develop our ideas up to a point where we can present them to the world, and then we step out there, we publish them, and we enter a fruitful debate. So privacy is supposed to protect not only our data, but also is a requirement for free thinking in many people's minds. And finally, privacy and the privacy laws and rules, social rules are also have a lot to do with privacy, shape what is possible what you're possible to debate and what not. That's neither good or bad. It just shows how strong these ideas, such as privacy codified in law or social norms, can be. If something is marked as private, that also influences whether you can just talk about it like that. For example, in societies where income is considered private, you don't ask people what they make, because it would be considered overreaching, it would be considered intrusion into their privacy. In societies where nobody cares because it's maybe an open record and everybody can see it, you can talk about income because everybody knows anyways. So privacy was very useful in describing what's possible to talk about and what isn't in our society. It shows what we consider to be okay to just mention. So privacy as an idea is great and important and powerful, as we've seen, and it helps us, it protects us against powerful entities. Is privacy a success? Let's look at a few examples. I mean, the European politicians that I have to deal with a lot always want to tell us privacy is going to be the biggest business opportunity for Europe because strong privacy laws and everybody's going to put their data into European servers because there is privacy. And, well, facts don't really line up with that, but at least it's something they can tell newspapers. So let's look at whether privacy laws and legislation really works. Sometimes it really does. This is the Federal Constitutional Court of Germany, kind of like the highest court in the US. The Supreme Court, exactly. Thank you. Wisdom of the crowd. In 1983, German government wanted to run a census, and instead of just asking, how many people are living in your household, maybe a rough estimate of income, they really started to dive in. It was obscene at that time. It was like maybe a quarter of what Facebook wants to know from you. So it was obscenely much. Nobody could ever think about publishing that much or giving that much information out. And people protested. Some people were just refusing to answer that, and some people went a step further and sued the German government and said no. And they even got a new right. The highest German court said yes, and you have the right of informational self-determination, it's called. And in Germany, the legal system is a little different than here. If the court says that that is a right, you can sue for that. That means it's now, they even strengthened it. So the privacy regulation gave you even more handle to deal with powerful entities. So privacy law worked. But very often it doesn't, sadly. Regardless of privacy law, we share stuff left and right without often looking whether the people that it concerns agreed to us sharing that. We just take a picture somewhere and we upload it because we think it's cool, but someone's face is on there and that person might not like that. Companies can pressure you into giving them data. If you want to get a job with a company, they send you a questionnaire and you either fill it out or you have no job with that company. They have the resources to gather all kinds of data. Just because they're very big, they have a lot of data. For example, if you are IBM or if you're Volkswagen, you know exactly how much an hour of work in Germany is worth at any given place. Just because you have all that data, you pay people who live in Germany. Also, oftentimes corporations have special legal rights. In Germany, the publishers of newspapers they may trade personal data without any restriction because nobody knows, but they have that right. And governments really don't care about privacy laws that much either. They should, but when they start getting in the way, there's always a loophole or a way to circumvent it, or it's just, oops. And this leads us to a short intermission, very quick intermission, because I promised whenever I have a microphone in front of me, I say this. Governments, the way governments use secret services is toxic for our democracies, and we need to get rid of all of them, of the NSA, of the GCHQ, German BND, all of them, because we can't control them democratically. They do whatever the fuck they want. They care about none of our rights, and they are leading a secret war against all human beings on this planet, and we can no longer tolerate this. And this is not something that we fight with technology, just with technology. It is something political, and we have to get people to understand that this is no longer tolerable, and that is not how our democracies work, and we need to dismantle them, all of them. Thank you. So let's get back to the privacy issue, but dismantle all secret services. Back to the privacy issue. So even if privacy has problems, everything has problems. If we build it, it has bugs. Why break things further and start thinking about post-privacy? Maybe we can fix it. Maybe there's technology we can throw in there. Maybe we can encrypt the encryption with encryption and encrypt it even further, and then it works. Or maybe we need to just rephrase the law and then it works for some way. Privacy is a human right after all, so who would even attack that? It's at least something. It gives us at least some protection. So let's look at how it's really broken, apart from a few implementation details or cases where something didn't work out. The awesome Johannes Grenzfurthner of Monochrome, who's talking on Sunday at 1 p.m., and you should be there. That dude is awesome. Listen to him. It's going to be basically insulting the public audience here, and it's going to be splendid. So be there. And they coined the Monochrome, this artist collective from Austria, coined the term privacy as a bourgeois fantasy. And what that means is, think of Brandeis, the right to be let alone, the right to draw back from the public and no longer participate because, you don't have to. That makes sense if you are, for example, independently wealthy and independent of others. If you have, for example, a room that you can draw back to. If you share a room with 3 people because that's all you can afford, no, you have no room to draw back to because there's always 2 people in that room and they might be doing whatever. If you're not independently wealthy and you need to get a job, I said that earlier, people will send you questionnaires. You want to find an apartment, they send you questionnaires. If the government wants to know something of you, they have these dudes with uniforms and the guns. They get you to give them that information. If you need a loan, and most people of us will need a loan if we want to buy a car, an apartment, maybe a house. We basically have to strip down and give the bank whatever they need, because if we don't, they don't give us any money, and we're screwed. So this whole notion of privacy is fine, but you have to be able to afford it, and most people really don't. I don't know how many people here never had to fill out a questionnaire that they don't want to fill out. Very few, I suppose. Then there's something called the privacy paradox. It has been described as the discrepancy between privacy concerns and actual privacy settings. There have been many studies about it and tests how it really informs people's decisions. What it means is that people say that they care about privacy and dangers to their privacy, and whenever you ask people, they will say they care and it's very important to them, but they don't act like it. They don't set up their privacy settings in that way. They don't choose the services they use based on that. And especially in Germany, but probably here as well, Facebook and Google basically have the worst privacy PR that you can ever have. If Google does anything, everybody believes, okay, they are screwing with our privacy. That's what they do all day. Still, in Germany, Google's search engine has a market penetration of 95%, about that. So people say, yes, I feel threatened and endangered, but they still use it. The common wisdom, especially in this kind of crowd, is that people are stupid. And it's complex, yes, and they are not doing all the legwork, and they're not trying to understand it. We have to teach them and beat them with a stick until they do whatever the hell it is that we think they should be doing. The other interpretation is that privacy is learned. When I grew up, I learned that privacy is very important for all the reasons I outlined earlier. And I always repeated that for a very long time, even at points where I had realized that something was fishy about that. It's something that has just been repeated so much. It's a meme that we've learned, and it's for many people no longer that internalized that it's really forming the way we make decisions. The privacy paradox illustrates a point of fundamental change in the way we deal with the world. We have old values such as privacy, and they are still very deeply rooted in our common debates. But within the digital world and the way we do things there, they no longer seem to really apply or work the way they used to before. So something has obviously changed. And also something that is where it really clicked for me. Privacy is DRM. Because that is what the right to control of access means. It means that you put something out there and you decide what other people can do with it. That is what Sony wanted to do for a long time. They wanted to give you, for example, a CD with a video game, and they said, yes, you can play this, but you cannot copy it. That worked out really well, especially for music and movies that nobody ever could copy, even if it wasn't illegal. So if Sony couldn't pay people to make it work, I don't think that it's a reasonable approach that we believe that we can make it work, especially given that we know that people break those laws when it's convenient or useful to them. And even if we find tiny pockets where we can get that done, where we can build strong encryption, where certain people that are able to have these Cthulhu-esque incantations, that is GPG, who can use that, are protected. Is that our goal? That a few people that out-nerd the nerds can really have privacy? I don't think that that is what we consider privacy to be. We want privacy to protect especially those who have maybe less skill or who are more in danger of those things. So just fixing the issue for us and our pals doesn't sound like a reasonable approach to me. Privacy is broken because supporters don't seem to accept trade-offs oftentimes. Now you might say this is a strawman argument by me, but bear with me for a second. There is a very dogmatic view of privacy. Privacy needs to protect it at all costs because it's the key value for everything, you know, of freedom, of whatever stuff. But every human right that we have, and we have quite a lot of them actually, even though most governments seem to have forgotten that, they all compete against each other. We all know that if we want to, for example, find a doctor to do some body modding to us, it's very hard to find one who really does what we want to do, even if we consent, because there are strong laws that protect bodies from, you know, harm. And they start to fire back when we want to express ourselves by having weird things done to us. Well, weird in a good weird way, maybe, but things clash. We have debates around abortion, whether that is a right of the woman or whether it's not. Obviously it is, but there is a debate going on about that. And again, rights are clashing. And the same thing is there with free speech versus privacy. We can always say, yeah, privacy, privacy, über alles, but that does really step on the free speech thing. And we have tilted the debate very much towards the privacy angle, and that can go very horribly wrong. I don't know how many people of you have seen the European Court decision lately, the right to be forgotten, which is basically a whole clusterfuck I could rant about for an hour here. But they did exactly that. They wrote in their description of their decision, yes, privacy is more important than all the other rights. That means the right to be forgotten has to be implemented. And now certain Nazi organizations are getting things deleted from the Google index, so people can no longer find that some guy is basically a Nazi. That is probably not what we want as a society. And finally, there are many definitions in the whole area of privacy, very broken, or at least wonky. We know that they often have a lot to do with personal data or personal information, and you know the right to control that. But what exactly is personal data? We can perceive it as our digital shadow that kind of looks like us, but not really, and doesn't really have all the facets that we have, and that might also be a little, you know, tilted or distorted. But still, it can be used to categorize us. It can predict behavior. But we think about our personal data in the meaning of, you know, our telephone number or our pictures, but what's with connection data? What with the data that me and some other guy are friends? Who does that kind of data belong to? Because it's not just me. And what's if someone says something about that relationship? If we say we are friends and another person says, I don't like that, then suddenly that I don't like that only makes sense in connection with data of other people, and it gets very wobbly. Who really is supposed to have control about that? Am I allowed to delete that, even though other people might have a reasonable expectancy of that to stay there because they are part of that relationship as well? In our focus on privacy and hiding information, we have kind of ignored that every piece of personal information we put out there on the internet and out there in the world is also a way to connect, to be discoverable by others. Because that's really what the beauty of the internet is, to find people no longer, this are the people in my city that I can talk to and the rest don't know. I can find people who are really interesting to me, who maybe share the same beliefs or who are just smarter than the people in the city I live in, or who are just more intense about some topic that I'm intense about than anyone out there that I can meet in the physical space. And all those, we can only connect if we make ourselves connectable in a reasonable way. And we kind of sacrificed that connection part in the past when we really couldn't gain anything from that data. The only people that had the resources to use that kind of data were, you know, the governments, corporations that could use it. But these days, we have this immense processing power in our pocket, and we have all these services that we can use that allow us to connect and find people. So the price for being disconnected, it's getting higher and higher, and obviously some people are no longer willing to pay it as gladly as they used to pay it when it really had no benefit at all to put data out there because you couldn't use it in any way. We lose social benefits for us as individuals, economic benefits, and many other benefits that we could have if we were connectable. So in comes the idea of post-privacy, and yes, that is basically a pun in image form, because I'm setting the post-privacy. You can judge me for including a pun in this presentation. So what is post-privacy? It's sort of an analysis as well as a utopian approach, but most basic, on a pragmatic layer, it means a change of defaults. It means that instead of the default being secret and hidden, the digital world seems to work better when we try to reap the gains of cooperation and only decide to keep selected things hidden. So we publish more of us explicitly, and we just decide, now this is something that I might not want to put out there. That is the very 10,000 feet view of post-privacy. When we look at the analysis part, then it's basically the acknowledgement of a problem. We see that privacy doesn't seem to be working all that well, because we wouldn't have all these discussions if it was really working. States really only care about it when it suits their needs, as I said. Especially when we see right now there's a very strong rhetoric in the European Union and in Germany against the NSA spying, and obviously then the US as well. There's actually supposedly reasonable people are talking about building a parallel European internet, as if that would solve anything with the GCHQ and the German BND that is basically storing all the data as well. But it's sort of, now the government sees, yes, we can use that as a political lever against US companies, and we use it to support our local economy. But they don't care about privacy at all when it comes to we need to collect data for whatever their goal is. Corporations obviously don't care about privacy laws because they have all these resources to gather data from either us because we use their services, because they can connect to publicly available sources and integrate that into the data cloud, and they just have data because they're very big, and just that just creates data for them magically. They know prices of things, they know what people put up with in certain areas of the world, just because they've tried to push them as far as they can, because that's what corporations do. And we, all of us, we break it every day. There are pages like Failbook, for example, where people just screenshot people's Facebook posts that they consider to be stupid. And many of them are stupid, but those people never said, yes, publish this. Even if the name has been anonymized, which tends not to work because they use the standard blur algorithm that can be unblurred quite effectively. And oftentimes we just want to share a photo or something, and we never think about whether Cindy or Carl wanted to be tagged there, and then they complain about it, but somebody else already took a picture or a screenshot of it, and things are very broken in that land. And more fundamental is that even though the term social networks has become synonymous with a certain class of online services and products like Facebooks or whatever, we've always had them and we've always lived in them. And interestingly, offline, we do share all kinds of information that we probably wouldn't share online, or if we thought about it in an online context, we would never do that out of our free will. I grew up in a very tiny village, about 2,000 people, and 1,000 of them were cows. So, tiny village. And everybody there knew basically everything about everyone, because you just knew, okay, that guy's car hasn't driven to work for like 4 weeks now. He doesn't have that much holidays, so probably he lost his job. You knew which people had an affair, because you can't hide that in this tiny space, because people are living together and interacting with each other. We're not an island. Nobody of us is autonomous, really not. And that is not a weakness. The fact that we're connected and that we're working together and that we're sharing this information make us discoverable in whatever we can do or what we like to do is a strength. That is that is what allows us division of labor. That is what allows us to really have freedom. Because if we start thinking of us as these autonomous things, and we learn to bake our own bread, make our own T-shirts, code our own operating system, because who trusts these things anyways, build our own computers, we'll never get anything real done. And actually, I don't want to make my own T-shirts. I want to focus on things that I'm good at and that I like. And I want other people to focus on the things that they're good at and that they like. And that is only possible if we share information about each other, about how we can relate to each other, what we can do for each other. And that is something that in the offline space we've always done automatically. Even sometimes it was just there because we're moving in the same space, in the same physical space where we could see each other. And for example, clothing that we see communicates a lot about us. And we use that information to, decide who to talk to. Oh, that's a cool band shirt. I'm going to talk to that dude and not the guy in the suit, for example, or the girl in the suit. And in the fight for online privacy, we have started to make connecting harder. And that sounds like a very stupid strategy for us, very powerless individuals. I mean, you are probably more powerful than I am, but I'm just this random dude from Germany. If I want to be heard, and if I want to influence the world in any way, if I want to nudge it just a little bit in the right direction, I need to connect to other people, because I can't do it. Really, I can't. And maybe you can, I can't. Privacy is also kind of a Judas. It's not just that, oh, sadly it's not working, but it would be that great of an idea. It's a two-sided sword that can also cut you. It's kind of like there's this ideology that you need to buy your own house. And many people think that has a lot to do with, you need to give people freedom. Buy your own house, so you're independent of everyone. But the ideology basically comes from the British capitalists who thought, okay, if I have all these people working for me, and they go really into debt when they buy their house, they will no longer protest when I do something to them, because they need that job to pay their mortgage. And privacy kind of has the same impetus. And I want to give another example from the Germanish area. Back then there wasn't a Germany, but from that area. This is the family of the painter Karl Begas. This thing was drawn in 1808, and it's one of the early examples of privacy, and it's the so-called Biedermeier area. It had its heytime between 1850 and 1815 and 1850, and it was a reaction to the Carlsbad decrees that where the German monarchy decided that all these reformist, liberal ideas, people thinking about nation states and people having rights and voting and all those crazy ideas, were not so cool. So the Carlsbad decrees made it basically illegal to say your opinion out in public. It censored the press. It banned liberal professors from working at universities. It disbanded all liberal organizations that pushed for some sort of political change. And many of the reformers and local governments that had worked with different groups were pushed out of office by about 1820. By 1820, all significant German reform movement was dead, completely dead by a few of those laws. And that led to the elite that could afford it to pull back to their private lives. Back then it was really called that, into the private lives. It was the time where the bourgeoisie started cultivating their private home life. You decorated your house very nicely. You had paintings over there, and you had this, your living room was important, and you invited your friends to events there. But it was all in this very secluded area. Not every part of your house was something that friends could see, only very selected areas where you could show how awesome your house was. This nice home was the goal. Your private life that you and your family interacted on, that was supposed to be beautiful, and people invested a lot of money and work into that. And that made basically women and children invisible, and political debate also, because political debate happened, in people's homes, but it never left it. You invited 3 friends and you discussed, yes, the king, what an asshat, but nobody talked about it. The women were reduced to basically taking care of the children. The husband of the household would represent the family to the outside whenever that was really necessary. The children didn't really have anything to do with the other children as well. You had maybe someone taking care of them to support the woman of their house, but basically everyone was made invisible, and everybody pulled back who could, just to protect themselves, because whenever you said something out there, you would get screwed. It was basically the idea of don't ask, don't tell times 100. You could think whatever you wanted to, but as soon as you spoke out, off with his head. Not off with his head really, but they had more efficient technologies, but basically that was it. And we have so many examples in history about people being courageous and changing the status quo, but they never happened in the back door, in the back room of some person's house. Maybe they first started there, people started talking about ideas and gathering, but to really change the public perception, you have to move out there, you have to be visible, you have to make a statement. Our democracies need that kind of input. Think of, for example, Rosa Parks. If she just had stayed at home and said, yes, I should be able to sit anywhere, that wouldn't have worked. She needed to make that public statement that people couldn't ignore, that was out there. It was a data point that she generated, the data point that people can sit there, and that was something that people could aggregate around. Today that would have been a hashtag. But hashtags do exactly that. They give you a point that you can relate to, that you can connect with on, for example, an issue. In Germany, yes. In New York, you have this Christopher Street, which is a symbol for gays being visible. It is a symbol for, no, we're no longer invisible and we're no longer happy with doing whatever it is we want to do at home. We're part of society and we want to be visible and we want to speak on our behalf and we want our rights to be respected. So significant reform doesn't happen in private. And it might start like that, but we really need to find ways to allow people to do that in public. And that is where the utopian post-privacy approach comes in. The question is, how should a world work where we use our connectedness as individuals and the way we can decentralize, for example, debates or distribution of power, to fight discrimination and abuse of power by powerful entities. How can we build a world where we make visible what's really out there and not make people invisible and their needs invisible? Because that's a very, very important thing to keep discrimination intact. We see that a lot when we talk about, for example, how movies show the world, where everybody's white. And most of the people acting are also men. That makes people invisible that are not white and not men. And we need to build a world where people are visible, and that means that data of them is out there. So how can we build a world where those people don't run the danger of having trampled on their rights? So we need to rethink the way our rules work, our laws work, our regulations work, and to stop fetishizing privacy as though it was the best thing ever happened and this one solution to everything we ever had. Privacy for its own sake leads to bullshit claims. I don't know if you remember when Street View launched in Germany, people went apeshit because people were taking pictures of houses with blurred faces and blurred ID, whatever, but pictures of houses, and Germans were angry and they protested. And they protested in the form that they went to newspapers and said, we don't want Google to take a picture of our photo. And they lined up, all people from the household lined up in front of their house with their names written underneath the picture in the paper, on the website of the paper, because nobody's supposed to take a picture of our house. That has something to do with the fetishization of privacy, with a bullshit claim that is somehow tied to a feeling of privacy that isn't really there and isn't really reasonable. We can talk about whether it's okay that people just drive through streets and take pictures. We have to discuss if that is the right of everyone, and if it's not, legally it is their right, even in Germany. But fetishizing privacy leads just to bad decisions. How can we build a world that allows us as individuals and every individual to reap the benefits of being networked, of collaborating with people all over the planet? And that has a lot to do with the ideas of participation and giving access. It has to do with people having the right to be connected. It has a lot to do with people having the right to have access to technology and have maybe even access to a computer just as a human right. Can we subvert established class and social structures by giving people more participation? We've heard the term knowledge is power here a few times in different talks already, but knowledge is actually power when you think about it as social capital. Social capital means that you come from a certain social class, and you know how that class acts. If you grow up rich, you know how rich people act, how they interact with each other, how they build networks. You know how to move in a crowd of rich people. If you come, like me, from a household of working people, that is a really hard thing to learn. I still don't know how to dress properly, obviously. And this idea of social capital, of knowing how to dress, is, and dressing is just one part. It's the way how you phrase things. It's really important. And how can we give access to that to more people? Because that can help us to change and break up existing social structures that keep people who have always been down. And that is obviously not the world that we want to live in. How can we, in this world where so much data is out there, how can we protect people from discrimination? Because obviously, if data is out there, it could be used to discriminate against them. How can we make sure that the data is not misused by the powerful? How can we embrace decentralization even more? All those are things that people working on post-privacy have different answers to, because it's not really this one solution. It's not, here, this is the box post-privacy, put it into your society and it works. But it's an ongoing debate that I invite you all to participate in if you want to. Post-privacy is, even if you don't want to adapt it, it's a way to reset your thinking in a way, to step back from whatever it is that we hold dear as dogma or as a fetish and say, okay, what's really there and what can we do with it and what do we want it to do? We need to get out of this dead end of the over-reliance on privacy, that privacy isn't dead. It's really not the point, and I'm not here to declare that it's dead. The question is, if privacy isn't the silver bullet that we thought it was, what can we save from it? What can we change from it to build a new world? And building just this digital life into a libertarian objectivist thing obviously can't be a solution, because that is basically the stupidest thing anyone can ever do. So we need the few following things. We need to have to talk about participation. How can we make sure that every individual that wants to be connected is connected and can benefit? How can we help people contribute, and how can we help people really reap benefits from all that? Just dumping GPG code out there helps no one. That's bullshit. In German, for example, income is deeply private. You don't talk about that, and this leads to young people, and I deal with them every day, with students who are just finishing their degrees. I deal with them, and they don't know how much money they should ask for when they apply for a job after their masters, because nobody talks about money. I didn't know what my father made until I was about 25, because I never asked, because it would have been considered impolite. Other countries have obviously open registers where that is not an issue, but we need to help people get participation and get access to their data in a form that they can use and that they can apply to their lives and to be better. We have to build open and non-commercial platforms for people to collect and aggregate data, because if we don't, nobody will. Facebook wants to have their silo because that's how their business works. We have to build something that works as a replacement or in a connection with Facebook. Maybe people will never leave Facebook, but maybe we should build ways where they can at least have their data mirrored so they can access it in a more meaningful way than what Facebook allows them. We need to fix the way we think about software and build usable alternatives that empower the use of data, and not these diaspora things where you cannot find people and only and nothing works and you can't communicate through it and it's just broken. That doesn't help anyone. We shouldn't focus on hiding information. We should focus on empowering people with information, because that's what the information age is about, if it is about anything. We have to build structures that help us to collectively redistribute power. Right now we're building instead of governments, we're building these huge power structures like Google, Facebook, those companies. How can we find ways to redistribute power? Another thing is, for example, genome data. If you want to do health research, you basically have to be part of a big company, because it's really expensive to get that kind of data, to get access to genomes. Is that how we want the world to work? Because right now we have to rely on a few pharmaceutical companies to do research. And if they don't if they're not interested in something, if it's not worth it because it's in Africa and they don't have the money to pay for anything anyways, they will not work on it. There are opinions. There are options to fight that. For example, some people might know the 23andMe service where you can have your genome analyzed. A friend of mine built OpenSMP, where you can upload your thing and give it access to researchers to study and to check whether the companies that are building our medicine are really doing a good job or whether they are just selling us shit. We have to build platforms that allow us to harness data, and that doesn't mean that you have to link your OpenSMP account to all your other accounts so everybody knows that it's your data, but it's providing that kind of information can help us all because it allows us all to access more information. We have to look at consent and rethink consent, especially on a very individual level. We can obviously just take a picture of this, and I was tempted to just take a picture of this room because for me it's kind of a big deal to stand here. But then I thought, okay, there are probably a bunch of people who don't want their picture taken right now, so don't. And that is a way we have to rethink how we act with the world. Think more about consent. Think more about how we really treat other people and other people's data with the respect they deserve. Ask how they want their data to be treated. So we need to further develop the ethics of sharing, what's okay and what's not okay, rethink that. Lobbying privacy laws, we have basically been missing the point, because what we really want to do is we want to protect people from overreach and discrimination. And what we have been doing is we have focused on this one tool and we've tried patching it and fixing it and patching it and fixing it instead of really looking at the issue and seeing if the tool is the right tool anyways. Maybe it's no longer the right tool. Maybe it was. Maybe it no longer works. So we kind of fucked up because we try to hide a lot of data and we're not focusing on enabling people to do something useful with it. And we ignore people and we make fun of people who use Facebook because it's the only thing they have and they know how to use. And if your privacy is fucked, well, it's your own fault. Use whatever weird command line thing is out there. That is all. We fucked that up. That's our fault. And we can do better. And I'm looking forward to seeing what you guys and you girls come up with. So just to get some nerd cred, the inevitable XKCD comic, privacy is not this binary thing and not this one thing. Many people think very differently about that. And this talk is not supposed to convince you all that I'm right and I've eaten the wisdom with a spoon from childhood on. But I hope to give you just a new way of thinking about things. And maybe you think it's stupid, and that's okay if it helps you rethink your perception of privacy in the digital sphere. Maybe you can come up with something that annihilates everything I said, and that works, and that would be awesome. But that's everything that I can do. One thing very important to me, a very special thanks goes out to these people: Kaspar Clemens Mirau, Katrin Passig, Lorena Jean Palassi, Michael Seemann, Till Neuhaus, and a few others, because without them I couldn't have paid for the flight over here. They are the most awesome people right now, so thanks to them. Round of applause. Thank you for your attention and coming here when you could have listened to this awesome Burning Man talk that I will later look at in the recording. Questions and remarks, we don't have a lot of time, sorry, I had a lot to talk about. But I'm here all weekend, you can just hook me up. I'm the dude with the red star on the shirt. You can also hook me up on Twitter, I'm @Tante. You can email me or xmpp me at tante@tante.cc, and tante.cc is also my website where you can write comments under my post-private blog post telling me how stupid I am. Thank you, and have a nice conference. Thank you.
Es gibt ja diese andere Privacy-Idee, dass bloß viele Daten reintracken, damit die Menschen praktisch jeder einzelne Baum im Wald nicht auffindbar ist.
Das würde man glauben.
In Berlin. Nee, das stimmt. Ja.
Ich weiß
say you planted the seed of post-privacy. I hadn't heard that concept before. I totally feel it. That idea that this is dogma on privacy. And I want to learn more about it because of your talk.
Do you need audio for your laptop or anything?
No.
Cool. Just try to stay as close to the mic as you can.
Okay. It seemed like it was just feeding back when they got farther away.
Yeah, that's why I'm changing it.
Okay.
The further you are from the mic, the more we have to turn it up, and the more we turn it up, the more feedback. So if you can get close to it, then we keep it lower.
Perfect. And it's a directional?
Yeah, it's pretty directional.
I might need some help at all. Yeah, I mean, I don't know. The typing is going to be the hard one. We do have a chair there, but I mean, I guess. Yeah, I'm definitely going to do as two separate ones for sure.
Can you do it standing at the same time?
The head thing? Yeah. Would you mind setting up the?
Do you want that? You do want that?
Yeah, I might as well set it up now so we don't have to screw around later.
Check, 1 2 1 2. Is that better for levels? Check, 1 2 1 2. Check, 1 2 1 2. Can you hear me? Check. Cool. Just try to stay as close to it as you can.
Will do. Yeah, not for the head mouse stuff for sure. Thanks. Let's see, distance here. Anyways, we can get it so we can do this.
Okay, so we have coordinate issues.
Okay, how tight? You can pull that up into the corner maybe?
Do you have any bigger power strip than that?
Yeah, I think okay.
Okay, we're gonna have a situation where if this falls,
You don't have a problem?
well, it's gonna be like an anchor, bringing down everything.
That's usually not what you want to do to talk.
We did, that's what it's a camera.
Is it going to be in the way?
So you're gonna need to aim it. Of course.
Okay. Is it plugged into the hub yet?
No.
Right. It's, okay.
So you're gonna have to give me feedback on it.
Is that yours?
Yeah. Sorry?
That's yours?
Yes.
What is it?
It is a head mouse, human interface hacking. Yeah. Hope so. All right, cool. Okay. Did you plug in the head mouse? Is it a USB? All right, and let's testing 1 2. Is it good? All right, I got the mirror on. Is it okay if I do a test right now? All right. Fair enough. At an angle? No. So it's definitely going to be low right now. I can just see. No, well, you don't have to bring it higher, but you need to tilt it up. If okay, and we're not on the. Hasn't connected. That was not the. That was the wrong camera, I think. So I saw the green. So I'm unplugging. Yeah.
Is this plugged in?
The white one?
The hub.
Yeah. Yes. Yeah, let's try it one more time. I tried to pull your Pi mouse. I don't know if it actually went. It's the old Pi mouse. And we're still on the internal camera. Crap. That's the internal camera. Let me, does that take so long time? Let's go to, just to test it. Oh, no, we're on it now. I think we're good. Yeah.
Is that it?
Yeah. I do this every day. It usually doesn't, just about. No, I think we're good. So, sweet. All right, good evening, everyone. I'm Carl Haken, and tonight I'm going to be talking about ergonomic human interface hacking. So I think a first question to ask is, who am I? And the answer is, I'm a software developer, and I used to suffer from the symptoms of RSI. Now that's repetitive strain injury, and it can be a mixture of things like weakness in the hands or tingling sensation in the hands. Well, I'll go more into that later. People commonly refer to it as carpal tunnel syndrome, but it's actually an array of different issues. So the reason I'm here is because I built some cool ultra ergonomic tech, and I'm going to hopefully demonstrate it a little bit later, and hopefully that goes well. And now I'm symptom-free from RSI, and that's really what I'd like to talk about. It's a more of a personal progress rather than a very scientific approach. So how did I get over the symptoms of RSI? Well, this is my setup today. And hopefully you can see I've got a weird keyboard in my lap, and I'll have some close-ups of that in a second. And I've got a camera, which is actually the one that's right up here now, aimed at my head, and it's tracking my head movements, and I'm using that instead of a mouse. So here's a close-up of the keyboard. Here's a close-up of the head mouse. And these are the pedals that I have under my desk, and I'll go into that in a bit. Now, first I'm going to start by talking about repetitive strain injury. It'll be a primer to tell you about what it is and how it works. And then I'll be talking about ultra ergonomic keyboards. Next, I'm going to talk about head-based cursor control, and I'm going to use the term head mouse a lot, so that's what we've used internally in our development. And then I'm going to do a demonstration that'll hopefully go well, and hopefully I'll have a little time for Q&A after that. So the disclaimer section. I'm not a medical expert. This is all personal research. I probably couldn't even make it onto Wikipedia. If you're experiencing RSI, you should probably see a doctor first, and then maybe do some experimentation like I did. But that's probably the first approach you should take. Now, I've only tested this equipment on myself. A few friends have tried it just for a couple of minutes, but I don't know if it'll work for you. If you're having symptoms right now, maybe it'll work, maybe it won't. You're going to have to try and find out, but probably see a doctor first. So, talking about what RSI is. Well, it's a condition caused by highly repetitive activity. And if you think about the history of humanity, there was a very long period of time when you couldn't just sit down and move your fingers a few inches for 10 or 12 hours a day because you'd get eaten or you wouldn't be able to eat. And it's a relatively modern situation where you're moving your body very little and very repetitive patterns. If you think even up to the 1960s and 70s, using a typewriter, it was a very varied activity. You might have to change the paper. If you didn't have the return, then you have to do it by hand. And it's only in a very recent period of time, probably more like the 80s and 90s, where you start seeing literature and studies on RSI, because it's really the first time we started seeing it in great amounts and having it diagnosed. So something to keep in mind is it's highly variable between individuals. Now, you might have colleagues or friends that use their computer or do other repetitive tasks just as often as you do, and maybe you don't have symptoms and they do, or maybe the opposite. It's a complex type of injury, and you don't necessarily see it the same among all individuals. And another thing to keep in mind, and I've read books and testimonials, is that it's frequently treated with suspicion by employers, and I can actually verify this from my own experiences as well. It kind of just seems like you don't want to work, right? You've done the same job for 6 months or a year, and suddenly you say, I can't, I need to take time off, or I need to rest my arms. I can maybe verbally give you some documentation, but I can't write code for the next 12 hours. And usually whoever's at the other end of that, they just want the work done, and they're not really thinking about it in that way. And given the variable nature between individuals, maybe the other people on your team or however you work aren't having those issues, so it's hard to understand. So there's also difficulties in treatment. It's difficult to localize, and looking at what's actually going on, it's issues with your nerves most of the time. And I like to use the analogy of a clamped garden hose, or crimped garden hose. It doesn't really matter where it's crimped. You're seeing the action at the end of the hose. So if you have a nerve running from your spine or from your brain all the way into your hand, you may experience tingling in your hand. It could be coming from your hand, it could be coming from your wrist, it could be coming from your elbow, it could be coming from your shoulder. And people have difficulty trying to figure this out for themselves. Doctors have trouble too, and you read testimonials where people have gotten carpal tunnel syndrome, as their doctor said they should, and it doesn't fix the problem. In fact, in one case, it turned out to be a condition called thoracic outlet syndrome, where in fact the nerve was getting compressed in their shoulder against their rib. So it's a complex and often misdiagnosed condition. And to talk about more of what's going on, if you think about your arms or your hands, you've got a mixture of systems. You've got your skeletal system, your bones, and you've got muscles and connective tissue like ligaments and tendons. And it turns out that those systems are really good to adapting to repetitive tasks. They might build up scar tissue, they might swell a bit. Unfortunately, that's done without any consideration to your nervous system. And what often happens is the nerves will travel through tunnels in the joints, carpal tunnel, cubic tunnel in your elbow. And if there's swelling from those other systems, it can compress the nerves, and that's usually what the symptoms of RSI are attributed to. And here's a graphic of the the nerves of the arm. You can see that they're going right through the wrist. In my case, one of the things that I was experiencing was numbness in my pinky and in my ring finger, but not in the rest of my hand. And you can see that the ulnar nerve travels directly to those two fingers and not to the other one, so that was probably the source of my problem. So now I'd like to talk about ergonomic keyboards, and this is another graphic of my keyboard. And I'll be talking about what I developed and what the features are and how they are beneficial. So in talking about ergonomic keyboards, this is probably the most common thing you'll see. It's a Microsoft Natural keyboard. It's got the split design. And really what they're trying to achieve with that split is to allow your elbows to be out a bit, but still have your wrist be relatively straight. And when the wrist isn't straight, they refer to that as a lateral deviation or ulnar deviation when it points outwards, away from the body. And based on what I said before, with the nerves traveling through those tunnels, if you've now twisted a joint, you've made the situation that much harder for the nerve to be unobstructed. And here's a graphic of that deviation specifically. And there's a number of different manufacturers that all make keyboards that deal with this, with some type of split and some type of outward twist. So the thing that's often not addressed is the twist of the wrist. And Twisted downwards, as you would be on a normal keyboard, is called pronation. Twisted upwards is called supination. And this is not a thing that causes people trouble, but it's generally not addressed in most designs of keyboards. Now, when I started experiencing issues, the keyboard that I bought was the Comfort keyboard. And it's probably the most adjustable keyboard out there. It's got these wheels that you twist and ball joints, and you can set it to essentially any angle you want. And the angle I'm showing here is what worked best for me. It's almost vertical. And when you think about it, if you just drop your arms, and you can do that along with me if you want, and then you lift them up to 90 degrees where you typically have a keyboard, if you look down, you're probably not twisted flat, completely pronated. You're in more of a handshake position, and this is believed to be, at least by the manufacturer and me, a more ergonomic position to be in. But there's still other aspects of ergonomics. And does anyone recognize this keyboard? All right. This is the Model M, and it's the classic IBM keyboard. And it's in a certain way, it's actually very ergonomic. They designed it to have a pretty heavy key feel and to have a noticeable click when the key goes all the way down because of the buckling spring. And it actually turns out that this has an ergonomic advantage. And it's been studied that if you don't have tactile feedback when the key is fully depressed, people push a lot harder than they have to. You end up having a lot of strain in the muscles because of that, and that can affect the nerves. So with this, you have both tactile feedback in the sense that when the key reaches a certain point, unlike most springs, that the farther you push it, the harder it gets to push, Hooke's law. You actually have a decrease in pressure, and the key falls under your finger, and then you can lift it back up, and you don't apply any more pressure because you know you've depressed the key. In addition, it also has the clicky sound, which I personally like a lot. But if you go to a modern office and you bring one in, you can really annoy people. So another ergonomic feature, and this layout is from Kinesis Advantage, is to move more functionality, and I hope you can see this okay, move more functionality to the thumbs. Typically, your pinky on your right hand is doing the enter key. If you use Linux, you may be using the tilde fairly frequently, and that's your left pinky. Tab is on your left pinky. Sometimes people remap caps lock to do their functionality. And it turns out that this finger is not particularly strong and doesn't have a particularly good range of motion. And people start to experience problems with their pinkies, hitting escape on VI. I think I put that in my description of the talk. And the Kinesis, one of the innovations of the Kinesis was to put many functionalities like enter, space, backspace, delete, all under your thumbs. And in my keyboard, I've actually also mapped escape because I use it a lot when I use VI. Now, it was difficult to demonstrate modal operation, but it's something that I usually want to talk about. And if you look at the rightmost pedal, that's actually connected to my keyboard. And when I depress it, I get a whole second set of functionalities. So typically, if someone wants to copy on their keyboard, they hold down Control and hit C. With mine, I just hold down the pedal, and I actually have it mapped to Y. But essentially, you can significantly decrease the number of keystrokes that you have to do. I have my cursor keys mapped to the home row, just like on VI, and all I have to do is depress that pedal, and I get easy to use terse commands to do the same thing that would generally take multiple key presses. So this is the Kinesis Advantage. That's the keyboard that pedal plugs into. And really, this was almost perfect. It's got clicky keys so that you don't apply too much pressure. It's got a tactile and audible feedback. It's the only keyboard with those additional keys mapped to the thumbs. It's got some other innovations like scooped keys. So your hands aren't traversing a flat plane. It's actually curved so that as the curvature of your hand causes your fingers to kind of go up and out, it actually matches that. But the main thing that it lacks is the attention to that twist, to the pronation and the supination. So to sum it up, the characteristics that in my mind make a very ergonomic keyboard are split design so that you can keep the wrist straight, a neutral twist so there's no pronation or supination, some type of macros or modal behavior, a layout that utilizes the thumbs, and key press feedback, either with tactile or audible feedback. So as far as I'm concerned, this is the best so far. And now I'm going to move on and start talking about head-based cursor control. So when I got a really ergonomic keyboard, I started finding that no longer did both of my hands experience pain and numbness and weakness. It was just the one hand, and it was the one that was operating my mouse. I tried a trackball, I tried an Apple Magic Trackpad, but I really didn't have relief, and it was really the motion going back and forth between the keyboard and the mouse. So when I tell people that I use a head mouse, they ask a series of questions, and I figured I'd go over them now because it's usually the first things people ask. Is it usable? And the answer is yes. I've been using it for almost 2 years now, and it's exclusively at work, and it works pretty well. And the next thing people often say is it must really mess up your neck, because suddenly you've moved this motion from your arm to movements of your head, and that's through your neck. And it's unscientific, but I like to use the analogy of watching a tennis game with really good seats. You're kind of constantly moving your head back and forth, and I've never heard of anybody having injuries from watching a tennis game. You also think about kind of human evolution. We have to move our heads around a lot to see what's going on, to be safe, to be proactive, and it's probably not, these systems are designed to have a pretty high workload. So kind of when you see this in operation, you might think that the cursor just goes wherever you look. And that's absolute positioning. It actually doesn't work like that. It's a relative position. So you're kind of moving your head a bit to the left, and the cursor moves to the left. You move your head to the right, the cursor moves to the right. But it's not an absolute position where you just look at a spot and it just goes to that place. So how does it work? Well, the software that I co-wrote with a phenomenal developer, Christopher Casebeer, works in 2 modes. In one mode, it uses a camera with an infrared emitter that reflects off of glasses. You can see that on the left, and those 2 green spots have been annotated in the software. Those are the brightest spots in the camera, and it guesses where the center of your head is based on those, and you can see there's a white dot right in the middle of the bridge of the glasses, and that's where the computer believes my head is pointed. The other mode doesn't use any special hardware at all. You can use it on any computer that has a webcam. And that's a great advantage. The disadvantage is that it's not quite as accurate. So it's something to try it out with, but ultimately it's going to be hard to get daily work done and do pixel perfect clicks with this method. So head mouse facts. It's great for jugglers, and I'm not talking about people that actually juggle balls. I'm talking about people that switch their mouse day after day from their left to right hand. And I was doing that, and I've actually subsequently met other people that do that too. It's something that when you're really desperate and your hand feels really weak, you might try it. And eventually what happens if your situation is bad enough is that both hands just start to hurt all the time. And that's what happened to me, and that's what led me to search for something better. So the next question is, how long does it take to learn? For me, it took about a month and a half to get proficient enough so that it wasn't slowing me down on the job. And then can you ease into it? Can you just do a little bit? That's actually how I started. I would say, okay, I'm going to do it for an hour in the morning, or I'll do it until it's time to go to lunch. And I started eating lunch earlier and earlier because I didn't really want to have this impediment that was keeping me from doing my work. And in fact, you can't really ease into it. You got to kind of just go cold turkey on the mouse, and then the learning curve is actually pretty decent. So I'll talk for a couple minutes on the technical details of what's in the software that we wrote. We use Python, and we use a library called OpenCV, which is an excellent open source computer vision library. And we essentially structured our software as an event loop. And inside of it, it's got a signal chain. So the first thing that happens, the raw image comes in, and the OpenCV does some of the heavy lifting, or most of the heavy lifting, so that, in fact, we already have a point on in an XY plane that we believe is where the person is looking. So we start by flipping the image. It's a mirror image, and in fact, that's what's intuitive. If you move your head to the right and the cursor move to the left, that would be really weird. And then the second thing we do is we take the XY diff, a delta, and that comes down to the fact that it's not an absolute position, it is a relative position. You move your head a bit to the left, the cursor moves a bit to the left, but it's not a one-to-one. It's not you move your head 20 degrees and the cursor moves 100 pixels. We do smoothing. It turns out if you don't do some kind of smoothing algorithm, that you end up with a cursor that's jumping around and is impossible to click on anything, and you try to click and end up dragging stuff around in weird ways. And we also have to apply acceleration. It turns out that if you don't have acceleration, you could either make big movements or small movements, but you can't really do both at the same time. You try to tune it for moving small distances, and suddenly you're jerking your head as far as you can, and you're still you're only halfway across the screen, and you can't select what you need to. There's also this interesting filter, which is subpixel truncating, and this actually came out of a very interesting paper I read called Mouse Ballistics by Microsoft. And basically the way it works is if you move your mouse a bit, not enough to move a full pixel, but just a bit, on the next pass, it actually applies whatever the amount was that wasn't enough to move it to the next operation. And the idea is if you keep on making little motions, you can move all the way across the screen and you'd never actually move a full pixel. So it's it's taking that information and it's putting it onto the next pass. And then another thing that is unique to our software is a distance metric. When I'm at a distance of 2 feet from my head mouse, and I move my head a bit, I get a range of motion that's whatever I set to. It's expected. If I move my head in closer, what actually happens is that the image is bigger in the camera and will result in a bigger motion. In fact, when most people move their head closer, they actually they'll expect it to either move the same amount or move a smaller amount. So we maintain a constant motion regardless of the distance away you are from the camera. So there actually is a commercial option, and this is what I started on, and that's a side-by-side. You can see it's a bit more polished than our solution. So the disadvantages that I experienced with the commercial solution. First of all, it's expensive. It's $400, and it's Windows only. If you want Mac support, a third party makes the software, it's an additional $100. If you use Linux, you're out of luck. I thought about solutions like having a secondary Windows computer sitting next to my Linux machine and using Synergy or some other type of software to make the commands from the Windows machine to the Linux machine. And ultimately, I didn't want to do that for security reasons. There was a reason I didn't use Windows in the first place, and I didn't want all of my movement data going through there. There were also reliability issues. Mine burned out after a year and a half, so it was a half year out of warranty and the thing burned out and I was out $500. And then the last reason that using the commercial solution might not be desirable is it's closed source and it's not well suited for tweaking or modification. All right, so it might take me a couple seconds to set up, but now I'd like to attempt to do some demos, and we'll see how that goes. And it just takes a couple seconds to start up. We try play. Oh, we're back on that one, okay. My laptop's getting a little faked out today and picking the wrong camera. It's been picking the internal one. All right, just a little bit stuck here. I knew there was a chance this would go horribly wrong, but hadn't really internalized it. All right, let's try this again. All right, it's not cooperating, so I'm actually going to try to use the other mode, the eye tracking mode, which is not as accurate, but should work. Okay, and we're going. So you can see we've got the green inner square there is where the software thinks my eye is. The red outer square is actually a chase cam. We're not processing all the pixels on the screen. We're just processing the ones that are close by to where it found my eye in the previous run. Now if I cover it and then release, it'll actually find my head and then find the eye again, and then again it'll be tracking it pretty well. So you can see I can click on Windows and move my mouse around. And so that's more or less that. I was going to play Duck Hunt, but I don't think it's quite accurate enough on the eye version. So okay, yeah, we can do that. So let's okay. Nope. I do enjoy this. You'll have to tell me when to stop if it gets boring.
How do you scroll with it?
That's a good question. You need to enable the visual scroll bars in like the newer versions of OS 10, and you just have to grab them. It is possible we could implement something, but we haven't yet. I have foot pedals. When I showed the graphic before, I had one that was for the keyboard. The other three are for the mouse, and I've got a left and right click, and actually an unused one as well. So at some point, I might map that to maybe a double click or something else. So a medium score. All right, and now I'm going to do a quick demonstration of the keyboard. This is it in person, same as the pictures, and it's actually, believe it or not, usable. So I'm going to try. Let's see. Move this down, and then we'll do type this. And in general, I'll say that usually if even one person is looking over my shoulder, my accuracy goes down a bit, so I'll do my best here. Thank you. And full disclosure, that's about as well as I ever do. So, all right. So that's actually pretty much everything I've got. So now I'm happy to take questions from anybody who is curious about the setup. And it's quite difficult to see people actually with the. Oh, right here. Yeah, sure. Sorry.
Where do you find the best position is for the keyboard? I noticed you put it on your lap. Is that what you do?
Yeah, in various literature, you'll see people will say that 90 degrees is best for the elbow position. Really, the keyboard position for me is based on how I want to have my elbows, and I think that was actually a bit arbitrary. Anything tighter, more acute than 90 degrees is going to be pretty uncomfortable and not very good. If you can get it a little bit less, I found that to be better. But just for practical reasons, about the best you can do is, or I found is 90 or a little bit more obtuse than that.
How long did it take to become proficient with that keyboard? I think you just answered this, but how do you become as proficient as you were before?
Yeah, I actually started touch. Oh yeah, I apologize. So he asked, how long does it take to get proficient with the keyboard, and am I as proficient now as I was before? I'd say I am about as proficient as I am before. Going with the vertical setup is actually incredibly easy, and I've had people just come to my desk, and with that older keyboard, the Comfort keyboard, which had the exact same layout but just in a vertical position, you can type almost as well as you can normally just right off the bat, and then after a few hours, you're fine. Because of the Kinesis layout with the thumbs doing more of the work, and I should say that my keyboard is actually, many of the parts are from Kinesis. You will, because one thumb is mapped to space and the other is mapped to backspace, you'll finish a word and you'll accidentally delete the last letter that you just typed, and it's incredibly frustrating. The other side of that, and to answer the question, it took, I would say, about a month to get back up to full speed. It turns out it's a really tight feedback loop, and when you think about learning based on conditioning, it's incredibly frustrating when you perform an action and you don't get the result you want. So in that sense, it's actually a pretty good system for learning, especially if you just cut off other options and just do that.
Two questions. What was the name of your software?
The name of my software, what was the name of the software? It's called Headmouse. It's on GitHub. If you just search for my name in GitHub, it'll come up, but I'll actually have a link at the end.
And then so I work at a treadmill desk, and I'm basically unable to use a lot of objects, a monitor, fancy keyboard, whatever, just after a half an hour, everything hurts. And so I'm fine with that, but I'm just wondering if you can comment a little on like more of the social implications of using some of this stuff. Sprints, I can't like work in my coffee shop, like.
Okay, so this gentleman, given the fact that he uses a treadmill desk and has some social stigma or limitations based on that, how does it work with this? Well, I can say that jerking your head around can be pretty distracting to your coworkers. I had a guy who sat diagonally across from me. The guy who sat directly across from me had the monitor blocking him, but he'd always be looking at me, and it turns out that actually pretty quickly people get used to it. They often see the keyboard and say, "Wow, what's that?" And they usually don't notice that there's no mouse and that my head is jerking around. And one guy once commented, "I just thought that you were always really concentrated on whatever you were doing, but in fact, I just had to keep my mouse position just so."
Which pedals would you recommend for Linux machines? Good Linux support.
Well, for the pedals, so what pedals work well with Linux? The pedals I use are the Kinesis brand pedals, and they work perfectly with Linux, except for the fact you can't program them on Linux. So if you want to change the functionality, I wanted to remap the center key, the center pedal to left click instead of middle click, and I had to find a Windows machine and install the software and program it that way. So once you get it programmed, it'll definitely work. On Linux, you may be able to use some customization in Linux to just interpret a middle click as a left click or right click or some other action. But in general, without the programming, it just behaves exactly like a standard human interface device.
I have a follow-up question. Do you know any pedals on which you can, so that you can program to be shift keys or alt keys, control?
Yeah, you actually, there's a 3-pedal version of the 1-pedal version that I have that plugs directly into Kinesis Advantage. So if you want to use the Kinesis keyboard, you can get that functionality. On Linux, you may just be able to use the same pedals I'm using and just map them to the modifier keys. On OS 10, I think generally modifier keys from different keyboards don't apply to each other. So if you do shift on one keyboard, which is in a sense the pedals, they're emulating a keyboard, and another one on a different keyboard, it may not work, so you may need some additional software to make it work.
For your head tracker, was it using like an IR emitter to reflect off of something when you initially wore glasses?
The question is, does the head tracker use an IR emitter? In the mode that I attempted to show, which works fine just about every day, it's just mainly because I'm up here that it completely flopped. It uses an array of IR emitters, and on my glasses are essentially the same kind of microbeads that you would see in a traffic sign or in safety gear for bicycling or for running, where it has that. It actually turns out it's a highly directional reflection. So when a car shines the headlights at you and you're running and you have that reflector on, it only shines back at the car, not at the other cars. And it's the same way with this. I get a very directional reflection back right into the camera. And it turns out the algorithm is incredibly simple because it's by far the brightest thing in the infrared spectrum. So all I have to do is essentially take the points that are bright and take a midpoint, and that's the whole algorithm.
Could you go into a little more of what you did to modify the consistency?
Yeah, sure. So what did I do to modify the kinesis to look like it does here? And I'll just turn it around. It was mainly, it was just a physical construction. There's really no changes to the electronics. It comes apart pretty easily. You just unscrew the outer casing, you pull the parts out. Some of the cables were too short, so I had to splice them. It uses a certain type of ribbon cable, which is kind of expensive, but you can get them on eBay for like $10 a piece. And then the physical construction of what's around it, it's metal and plastic that I just cut to shape. I used a lot of Instamorph, and if you looked at some of the pictures, it looked way prettier than it does now. I'm currently traveling for work, so I had to ruggedize it with this material called Instamorph, which is a moldable plastic. You can basically just heat it up to around 150 degrees and then push it to whatever shape you want. So a little bit of just extending the wires, no rewiring. The front face is laser cut. It's essentially like the buttons you find on a remote control. It's those rubber membrane ones. So I needed an accurate faceplate, so I just laser cut it. Yeah, do I ever use ThinkPads with a track point? That's my fallback if I have to use a computer that's not, if I have the option and I'm using a computer that doesn't have this software installed. The track point's pretty good. I actually tend to get pain sort of between my fingers when I use it a lot, but I'll say that it's far better than most of the other options. And if that works for you, but you have a desktop computer, they do sell keyboards that look just like the ThinkPad, but there's no ThinkPad. It's just the keyboard. It's got the track point. I was going to call it nipple, but there's a more professional term for it. So yeah, I'd say that's a pretty decent option actually. And laptop keyboards in general, you're not moving your body very. You're not putting strain on your elbows, your wrists. It's basically just a thumb motion if it's a trackpad, and that's not too bad either.
Have you considered track balls? You're keen on using your thumbs. Could you put that under the thumb or one in the center for either thumb?
Yeah, so if I consider using trackballs based on the fact that, that could have been a very viable option. Yeah, I mean, the smaller marble ones would definitely fit within the physical size that I have on my current keyboard, so that could be a really viable option.
In your research for helping with RSI, is there anything that you read about different keyboard layouts or the keyboard 480 or maybe one-handed keyboard layout?
Okay, so the question was regarding researching RSI. Did I find information on specific keyboards like Chordal or one-handed keyboards? I didn't. I think it's actually a compelling option. The advantage of a system like this is you still maintain a somewhat standard layout. The letter keys are still in the standard position. The reviews I've read of the Chordal keyboards, the Leapfrog, Pad, generally said that people had trouble learning to use it. And now whether that was just a level of commitment, I don't know.
I have two keyboards. I don't use them now, but one of the 90s. One of the Maltron. Another one is the Data Hand. Do you have any opinions or any?
Yeah, so do I have any opinions on the Maltron keyboard or the Data Hand? I believe the Maltron's the one with like the curved key surfaces. And a different... Yeah, from what I've read, the Kinesis Corporation started by making cheaper, essentially a knockoff of the Maltron. So the Maltron, if I remember correctly, was made for typing professionals who are doing it all day, and it was quite expensive as it was made, I think, by hand in Great Britain. No? Here? Oh, sorry. Okay. Yeah, I'm just asking you, assuming you're the Maltron expert. Yeah, so they're quite expensive. I think when you bought it, was it like in the thousands of dollars or? Oh, 300. Used or new? So $97 was before like George Bush and yeah. Okay, so yeah, so if you can get them for that price, they may be a really good option. I'd understood them to be more expensive, but if you've got a source for them, that might be a really good keyboard to get.
The other thing is a lot of people might know the answers, but I don't. They are old PS2 interfaces. Can you modernize them to look?
Yeah, can you modernize keyboards with PS2 interfaces? Definitely. They have PS2 to USB adapters and. Yeah, especially I found on Mac they can be finicky, but if you just go online and read the reviews and find one that's basically what I found one that people said worked on Mac, and it did. So that was my process.
What's the way?
Yeah, so it's true. Before I used that, I used manufactured solutions. Did they pay for those? No, I mean, at the time I bought the one, I was working for a nonprofit. I probably should have asked, honestly. But I think, I think in general with RSI, if you're suffering from it, the less of a headache you can be for your employer, probably the better, because at some point you're going to have some pretty big asks, like I need to take a couple weeks off because my arms just, I can't type. And I think ultimately if you can give them a reason to say, okay, this person was no trouble at all, no problem. He's got this problem now, and I actually believe him or her because up until now they've been very accommodating. That's sort of the tack that I took, and I'm not necessarily advocating it, but that's just sort of how I've done it. Okay, I'm not seeing any other questions to CL. Oh, there's one back there? That's a really good question. Has the TSA flagged it as a bomb? And I've made it through security each time, and previously I didn't travel, but now I'm traveling to work every week, and I've brought it back and forth a few times, the keyboard, the head mouse, which is just wrapped in electrical tape and has red and black wires. It looks like, it's like right out of the movies. The first time I flew, I went through JFK, and the woman behind me who had a completely innocuous, just like Gucci handbag, they stopped her and they examined it, and I kind of think that maybe they saw the contents of my bag on the x-ray and then misidentified which bag it was in. But that's just my conspiracy theory. I don't actually know. Anybody else? Okay, well, thank you very much. I'll be up here for a few minutes if you have any other questions. Let me just put up the... All right, so here's my email and my and the address for the head mouse software, which is open source. Yeah, definitely. I can let me position the keyboard so you can or the screen rather. So you can It's actually it's a little hard because I managed to step it up. It might make it easier. You want to try it like that? Because, I lost the connection for sure. No, in fact, if I can put instructions up, but I think the ultimate goal should really be to 3D print the parts so that it's really repeatable. You're very welcome. If anybody else wants to try this, please feel free. If anybody has 3D printing experience or modeling and wants to reach out, I'd be really keen. Or if you just want to reach out and ask for instructions, I'd be happy to, for sure. I'll give you a card. Yeah, and you can do whatever you want with it. It turns out if you've used one, the rubber keys, the function keys, are kind of the hardest part. So the first time I made one, I actually just cut around them and left like the stock, and it looked like something on a weird X-wing or something, because it was like down, but then it had these two like ears sticking out or something. That's actually the one that got the boss doing the cross. Oh, the key switches are. Yeah, it's expensive. Well, the way I did the second one, you could potentially put it back together. It would be kind of a pain, but it's a risk. You know, it's for most people, including me, it's a lot of money. Yeah, and the pedals and the whole thing.
Yeah, it's pretty. I actually don't know it's
Yeah. It turns out it's really serviceable. The parts are all separate, and you essentially just, these are all discrete pieces. If you take it apart, the thumb beds are one, and then
yeah.
Okay. Does it work for you? Yeah. All right. I actually sat down for my demo because it is a little hard if the angle is off. You're suddenly really hitting the wrong keys. Oh, no problem at all. Yeah, for sure.
I like a lot.
Yeah, what's your name? I remember you. Wow. How are you doing?
Doing all right.
Okay.
Yeah, I now work in academia. I'm the systems administrator for
Oh, nice. Very cool.
And it's weird because the CS department is in the engineering division of my school.
Okay.
So frequently, like, the computer science students are involved with electrical engineers for robotics projects, where the electrical and mechanical engineers deal with the robot chassis, motor equipment, but then, like, figuring out how to navigate the field is computer science students.
Yeah, it can be quite difficult.
Yeah.
For sure. Yeah.
Oh, that's cool.
Oh, it's good to see you again.
Nervously gonna set up my
Yeah.
Where's the video?
Oh, sorry.
Okay, I have a video.
Apologies. I didn't want to dwell here and keep you from.
Thank you.
When I was when I was finding my seat, I literally could not see anything. It's like,
No, I'm going to look it up.
I never got used to it. It's totally different thing to moving things up from one piece, down for another one. So these things.
No.
This way to get a third one.
I saw that online. They're essentially just wells. So if you're reaching for the, you just push up.
Here, and then down. I may sell these things because I haven't used them in years.
I think they have like a.
They didn't seem to help me, and I just lowered it.
It's tough finding the right one. Like I went through quite a bit of equipment before I found stuff that I felt was really effective. So it's just that's the process. It's just expensive, and it's such a niche thing that you only got certain people that are really even interested in it.
Right. What about pulling out trucks? Well, I got to talk with adapters first.
Oh yeah.
So they're either usable or sellable, whatever it is. Now they know.
For sure, yeah. And I didn't want to plug Amazon specifically, but that's where I find the data to the reviews for people. So that's really effective. This isn't.
Yes. That's Josh. Oh, probably.
I'm not playing any videos. No. I don't need any sound. No. Just a mic, and I think I need to figure out how to do mirror displays on this. But because I have the problem is if I throw the slides over there, I won't necessarily be able to see them. Unless you know Ubuntu. Ubuntu. Oh, I maybe just need to apply to something.
Sorry, do you want to?
Yeah, I know.
I don't. I'd like to set one up. I can just give you a card and send you an email. I'll send you my documents.
Okay. Worst case, I can glance over, and I think I'd be fine. Okay. But I have some time to figure it out, so I think I'm okay. Yes.
Just for our sake,
yeah.
Try to stay as close to the microphone.
Okay. Yeah. Oh. Okay. Let me put it here.
We were having problems with feedback earlier.
Yeah.
We changed the mic stand up.
Okay.
So you're gonna stand.
Yeah. Can we adjust the mic then? Yeah. So this would be good. Okay. Okay. Okay.
There's a couple. There's two control boards inside. One is like a USB adapter. One is just takes the matrix and keys, but they take up almost no space.
This is the power.
Yes. Well, Instamore. Use the finger on the camera actually.
Okay, so thumbs are here.
How's that? Oh, okay. Oh, got it. Okay. You gonna give me thumbs up and I'll. Okay. All right. Test, test. Are we doing? Okay.
Like 10 seconds to cue the video when you're going to start. So
Okay.
how long have you got?
You mean am I ready?
Are you ready?
Oh yeah, I'm ready. Yeah.
Okay, wait. Let me just do that.
Okay, just give me a thumbs up. So while we're getting ready, I have having some display issues. So if you see me look over to my left, it's because I don't see the slides. I've got a copy here, so I don't have a tick or anything. I can't see but we'll get through it. We'll get through it.
The next multi-display is not great.
I know. Yeah, it's Okay, so thanks for coming to the talk. My name is Josh Datko. I'll be talking about crypto for makers, so projects to do with the BeagleBone, Raspberry Pi, AVR, Arduino. We are going to talk about a few things. We're going to kind of motivate the problem, why I care about this, and why I think people should care about kind of doing security with embedded devices. Going to give a quick device overview for those who maybe are unfamiliar with some of these. Give a very quick crypto background, why I'm interested in hardware crypto. I built with SparkFun, made this device called the CryptoCape, so I'm going to kind of talk about what that process was, walk through each of the security ICs, so I've been kind of playing with some embedded crypto chips that I think are interesting. And then lastly, I have this project where I run a Tor relay on a BeagleBone, and so I'm going to talk about how to do that. So Bruce Schneier has this article back in January called "The Internet of Things is Wildly Insecure and Often Unpatchable." And mainly he's talking about routers, and the embedded systems community typically has been pretty bad with security, and he's, among other people, are concerned about upgrading the Internet of Things. And he offers 3 points that are kind of call to actions. The first is that we should have open source drivers, right? So no binary blobs. And so the maker community is actually pretty good about this, right? Almost too good, right? So I joke you can tell a hardware engineer if they use forums as their source control, right? So if they are posting things to forums and they're like, oh, I made a change, and they post their Arduino sketch and they post it again. Oh, here's Rev 2. It's like, oh, guys, learn Git, So that's how you can tell hardware engineers and software engineers on forums. So makers are generally pretty good about releasing open source drivers, and I think we're pretty good about this. The next thing is having an automatic software update mechanism. And so, again, talking about routers, the problem here is that you have a binary blob router. It needs to update because of the heart bleed, and there's no way to update it because it's binary, so you can't even fix it if you wanted to, and two, there's just no way to update this router, so you're stuck with this router that is contributing to this botnet, and then everybody's kind of stuck. And so the third thing is we need to design secure systems. So this is kind of like, okay, thanks, Bruce. Thanks for the tip. Got it. But what I wanted to do in this area is I wanted to make I wanted to make a tool that would help with this. And so I think that makers are driving the Internet of Things, not companies. So the projects that we're doing, we're connecting things to the Internet. I think that's really driving the conversation. And so I wanted to make this tool that would help people secure that. And then so this talk is basically about the story of me getting into that and trying to build this tool that hopefully helps people secure their projects a little better. So this is an Arduino Uno. It's a 8-bit AVR. Arduino obviously, Arduino also makes 32-bit versions. This is the 8-bit version. Uses Atmega's 328P. It has 2K SRAM, 1K EEPROM, 16 megahertz at the 5-volt version. If you lower the voltage to 3.3 volts, it'll run at 8 megahertz. Lots of different I/O, right? So you can do a lot of fun stuff with this. The nice thing about Arduino Uno is it has no operating system, right? So you can get very real-time control. So you can do very kind of fixed timing things. The bad thing about Arduino Uno is it has no operating system. So if you're trying to do any kind of sophisticated projects that need some sort of software library, you're kind of stuck because it doesn't run an OS. And so for this talk, if I say Arduino, I'm generally referring to the AVR versions. I know there's other ones there, but if I say Arduino, I mean an AVR version. So this is the Raspberry Pi. This is actually the B+. It just was announced. And I always think it's funny when hardware guys use letters to indicate it because it always gets a worse grade, right? It came out the A, now it's the B, not B+. So this is the B+. A 700 megahertz processor. It can be overclocked. 512 megabyte RAM, has the composite video. So that was one of the changes with the B+, is it has that nice 4-pin, or everything's in that one connector. Lots of different GPIO, SPI, I2C, UART. It has a hardware random number generator, so I think that's interesting from the crypto point of view. It runs Raspbian, which isn't quite Debian ARM HF, so there's some issues trying to get some software there, but they do their best trying to make this Raspbian distribution that'll work on the Raspberry Pi. And so this is actually my platform of choice, the BeagleBone Black. I like it because it's got the 1 gigahertz ARM processor, the 512 megabytes RAM, so that's the same. It has 2 independent programmable real-time units, so this hasn't really gotten a lot of attention, mainly because the C compiler wasn't released, I think about 2 months ago, but this gives you nanosecond guaranteed execution, right? They're both independent. They have a shared memory interface to the main processor, and so you can kind of combine microcontroller stuff with PRUs and do some neat stuff with that, and like I said, the C compiler is out now, so that should help, and I've seen on the beagleboard.org groups a lot more interest in this now. It has crypto accelerators for AES, SHA, and MD5, right? So these also haven't gotten a lot of attention, mainly because the OMAP driver is in 3.13, and the Beagle ships with a 3A kernel. But if you upgrade to 3.13, which is actually easy to do with the scripts, you will have those drivers. I'll talk about it a little bit later. They're still a little bit hard to use, but the hardware is there to do acceleration of these algorithms. Plenty of I/O, as you can see. It also has a generally purpose memory controller, analog digital converters, has a CAN bus, right? So if you want to hook it up to your car, that could be kind of neat. It's also fully open source hardware, so you can go build this yourself. All the design files are published. You can also build a product around it, right? So the one from CircuitCo is not really recommended because most of the distributors have kind of limited to 1 purchase per person, but MBIST makes a clone, and there's some other clones that are out there that, if you want to buy like 100 of them, you can do so. Okay, so now just a kind of a quick background of why, if you're making something and why you would need crypto. And this is really, if you're kind of new to this and trying to look up information, these are kind of like the terms you should Google because you'll find better results, right? So if you run into a problem, if you have 2 devices and you want to verify the identity of these 2 devices, the word you're looking for is authentication. That's a feature of cryptography which will do that. The other problem is if you have, you want to keep some data secret, right? So this is a confidentiality feature of cryptography. The next one is, right, to verify your data didn't change, right? So this is like if you see something on the internet and you download it and it has this kind of 20 byte value after it, and that's something you totally should verify but probably don't. That is an integrity feature of cryptography. And then lastly is, how do you prove a device performs some action? And so this is a non-repudiation feature. And so if you haven't heard that term before, basically to repudiate something is to deny something, non-repudiate to make sure that you can't deny it. Okay, so why am I interested in hardware crypto? Well, I think hardware crypto provides 3 features. So the first feature is kind of a little bit obvious. If you have an AVR, right, and you need a random number generator or you need a certain algorithm, the hardware crypto acts basically as a library, right? So you put the hardware chip on there, right? Then you gain that feature, right? So if you are limited because you are only working with an 8-bit AVR, then you may just certainly need a hardware embedded chip to provide the feature you're going to use. Otherwise, you're going to have to use your memory, and that you may or not have that because of whatever the application that you're trying to do. The second thing, which I think is a feature of hardware crypto, is to do algorithm acceleration, right? So you can offload some of the crypto to a special coprocessor, and that will accelerate that algorithm, leaving your CPU to handle whatever the task was that the CPU was supposed to handle. And the third feature, which I think hardware crypto provides, is key protection. So these are mainly for asymmetric algorithms, so public-private key pairs, right? But hardware crypto that generates the private key in the hardware and doesn't release it is of special interest to me, and we'll be talking mostly about this third feature. Okay, so to touch briefly on crypto acceleration. So crypto acceleration is very useful when you have a higher priority CPU-bound task, right? So if you're doing network traffic, a lot of times you'll see this in the web server world with hardware security modules. And so they'll have something like a PCIe hardware crypto accelerator attached, and they'll offload all their SSL to these hardware security modules. These things cost like tens of thousands of dollars, and they're FIPS 140-2 certified, right? And so that's a little bit more expensive than a BeagleBone. But the BeagleBone has those crypto accelerators. So if you're using it as like a VPN server or something like this, it'd be really nice to offload that AES traffic to lower the CPU usage. Also, a lot of people use BeagleBone Blacks for robotics and robotic vision, right? So it's doing some sort of machine learning algorithm. That's taking a lot of CPU. It's also communicating over network. You really want that robotic device to have also that real-time capability. Crypto acceleration would be nice. So I tried to do this, right? So I've got some blog posts that you can go look on how to, basically what I tried to do with this. It's a little bit complicated because you have to kind of statically compile everything and have to upgrade the kernel. But if you're kind of looking to jump off of what I've done, you can go to that link and see how far I got. Okay, so now I'm going to talk about in context of this CryptoCape, which you may not know yet, but basically I wanted to have this device, and I wanted back in the end of last year, wanted this device that would provide key protection for some of these asymmetric algorithms. I wanted a battery-backed RTC, so that's important for security systems to have kind of accurate time. I wanted this idea of having this trusted controller, right? So I wanted an ability to upload some sort of software to another microprocessor or microcontroller, and then know that a software vulnerability couldn't change the software running on that piece of hardware. And I wanted it to be hackable and fun. So this is kind of important, right? So I wanted to make a device that I think other people would pick up and be like, whoa, I can make this project, or I can do this. And so trying to introduce some fun into this kind of otherwise very serious business here. So November 2013, I kind of made this diagram. And I was like, well, I found these chips. They all look pretty cool. They're all on an I2C bus, so I think I can do something like this. And as you can see there, or maybe you can't read, but they're basically all Atmel chips. And so I went shopping around for chips that would do this. And basically, I looked at a whole bunch of different vendors, tried to do the research. And really, Atmel was kind of like the clear chip provider here. So first of all, I knew of Atmel from the Arduino community. So I was like, okay, so I know these guys. Their chips are available on DigiKey and Mouser, so that's a big win, right? Typically, some of these vendors will have NDA chips, and you can't buy them through the normal distributors, so that's kind of like, you first have to do this NDA dance, and some vendors are not really willing to give it to individuals, so, okay, so I've got this company, right, so I can probably get the NDA thing, but then it's like, well, then I can't really distribute it because they don't, everything's NDA'd, so it's kind of like, well, I mean, your chip looks nice, but it's not really gonna work, so that was another thing. So this is kind of a big distinguisher for me because a lot of the documentation is freely available. So they do have some NDA chips, but for a lot of their chips in the crypto line, the whole spec is published, right? So if you don't have an NDA spec, it's really hard to write a driver for it, but Atmel does release the full specs for them. And so even their NDA chips, they produce a code library. So the document's under NDA, but they have a library that you can go download and then basically see the features you want to use in that library. So I don't know of any other vendor that just has code out there. So that's kind of a big win. And I'm on the wrong screen, sorry. Okay, so and then they have some dev kits, right, that you can get again from DigiKey and Mouser. They have demo software that do all that stuff. So basically, I found Atmel to be very maker-friendly, right? So if people are working with Arduino, they may have already known that, but
Even for their security ICs, which I don't think got a lot of attention, I've found them to be great to work with. And so if you look at their dev kits, right, so these are some of the dev kits. The one on your left, right, has this nice socket interface. And if you're doing anything with like SOIC 8s, oh man, like a socket is really nice because you just pop it in there. And these crypto chips have these features where they have one locking mechanisms, right? So you burn the one-way fuses. So basically the idea is you set up the chip, you tell it, hey, this is how I want to use the keys. This is like how I'm going to set up my management team. You burn the fuse, right, and then you can't go back. So if you have this already soldered to a board and then you're trying to write this driver and then it's like, well, crap, what do I do, right? So if it's in the socket, it's like really nice to just pop it in and, so that's kind of a cool thing. But even if you're doing anything without SOIC 8, like you should look into getting a socket if you do any kind of stuff like this. And then the one on your right is one of their TPM breakouts, right? So if you're doing things, we'll talk about the TPM later, but it has this nice breakaway header so you can kind of set it up, break the board, and then kind of plug it into whatever you're doing. So they have some nice, nice stuff. And so I was like, okay, I want to build this thing. It's like, wow, this is kind of like a little bit complicated. There's a lot of chips there. So maybe I should start a little smaller. And I discovered Tindy. And so who here has heard of Tindy? Okay, you guys have not heard it. We'll drop like $100 when you go check it out, right? It's like the Etsy for electronics. I mean, people are putting, from things they make one of to things they make 10 of up on Tindy. And it's just like anything you can think of electronics that guys are making with themselves. They're using like H.O.P.E to produce the boards, hand soldering things, putting it on Tindy, and people are shipping all over the world. So like I had something shipped to the Ukraine and Kiev like right after the whole thing, and I was like, oh, hopefully it gets there. I had to go to the post office and explain like why I was shipping something to Ukraine. I was like, oh, this guy wants this crypto thing. I don't know, hopefully maybe he's trying to protect himself. So someone bought it in Kiev, and as far as I know, he got there. I mean, he didn't complain about not getting it. So I built basically. So I was like, okay, I should probably start small. It's very easy to set everything up on Tindy. So I took the AT SHA-204. I was one of the chips, right? I took like 3 to 4 weeks. Started with their spec, wrote a whole GPL driver for it, to make it Linux compatible, did it AVR compatible. Called it the hashlet, so it does hashing, it's small. I kind of suck at names. And then I put it up on Tindy. And then, I made these like breakout boards, right? So it's I2C, so it works on the Raspberry Pi or BeagleBone. And, people were like, oh, this is cool, this is kind of thing. It's like, oh, okay, so maybe there's, some interest in doing something like this, right? And so then I found these guys, which you may have heard of. So I did a Hacker in Residence program at SparkFun, and I just want to tell you about this program because it is very, very cool. So you apply to this Hacker in Residence. Right now it's like a 2-week thing. And you tell them about your project, and then there's a little application thing. And you basically have to do a tutorial for them, write some sort of blog post. You do a lunch and learn, and then you kind of have to like share your project. But in return for all that, you get the following. So you get to stay in downtown Boulder, Colorado. So Colorado's nice. And there are certain things you can only do in Colorado, like hiking. And yeah, I can't. There's some other things that recently came to, but maybe that's attraction for you. But so you get to stay in downtown Boulder, Colorado. You get to work among SparkFun engineering department, so they give you like a seat. They're like, here's your soldering iron, here's your hot air station. Here you go. And you're like, oh, okay, that's cool, thank you. Obviously, you get access to the SparkFun engineers if you have questions, right? And so generally, there's at least like 1 or 2 people who are kind of interested in whatever niche area you're doing, and then you just talk about some cool stuff, and then dogs come by, and you're like, oh, is that a dog? And they're like, yeah, oh yeah, right. So very cool, like just to be in that kind of environment. I've worked for like big companies and everything before, so this was kind of a different place. It's like, are you guys getting paid or just? And then this is the best part, right? You get a hardware budget and really fast shipping, right? So it's like I'm kind of there, right? And I'm working on this thing, and I get some like SOIC, breakout boards and some TSOP breakout boards, and like, oh, I burned one of these chips. And then I go to the point of contact, so I'll try not to embarrass her. But I was like, hey, can I get some more? And I'm like, oh, okay, yeah, but why don't you put a one big wish list together, and then that way I don't have to make one trip. And I was like, okay. Right, so I started like looking through, right, and I'm like, I really could use some like digital calipers because, this IC's got to be in the spec of the data sheet. And so I guess I could use some of those. And I probably should make sure it works on a Raspberry Pi. And so it's pretty cool. Then it kind of just magically shows up. So that's kind of fun. The chips were in the data sheet, right? They were within the spec, so I did measure them. But digital calipers are nice for all sorts of things. So yeah, so while I was there, I basically built this, and so this is the prototype CryptoCape, right? Got it all into a breadboard, cooked everything together, kind of make sure it was working, and then we were able, so working with some SparkFun guys, we were able to kind of turn that into this, right? So this is the CryptoCape, and so what this has on there is 2 different authentication chips, right? It's got the ECC 108, which is an elliptical curve authentication chip where the private key stays in the chip. It has a SHA-256 based authentication device. It has an encrypted EEPROM that does AES 128 in an authenticated mode. It's got a battery backed up real-time clock, a trusted platform module, and it has an Atmega 328P with the Arduino Pro Mini bootloader. And so that's useful for all sorts of things. And so basically, there's a couple ways to think of this board, right? You can think of it as a cape for a BeagleBone. You can also think of it as a Arduino Pro Mini without a power supply, right? So this thing is an Arduino Pro Mini that has these ICs connected to it. If you supply 3.3 volts to it, that's also what it is. So basically, what I'm going to do now is walk through these chips, right? So first of all, this board's completely open source hardware, right? So you can go look at the schematics. Each of these chips are available on DigiKey and Mouser. So you can, go get those. You can use any of these chips for either the Arduino, BeagleBone, or Raspberry Pi. So will work with all these platforms. They're just I2C. So that everything here I'm talking about should be applicable, even if you don't buy a CryptoCape, which would be nice, but you certainly can go get the chips individually. So the first thing I want to talk about is the EEPROM, which is not necessarily a crypto thing, but there's some very cool things that the BeagleBone does with the EEPROM, which I'd like to emphasize, right? So an EEPROM is basically the thing that makes a BeagleBone cape a cape. And what happens is on boot, the BeagleBone will go out. It'll try to look for these 4 I2C addresses where there's an EEPROM. It'll go look at the EEPROM, look for a fixed value, and then it'll try to load a device tree blob that corresponds with your cape. And so basically what that means is on boot, the Beagle will go probe the hardware and then load all the kernel drivers and mux all the pins automatically. And so this is actually really cool, right? So you don't have to do this. You don't have to do this in your program, right? This will all happen automatically for you on boot. And so that's kind of like the closest thing I know to like plug and play hardware on a embedded device. So it's kind of a neat feature. And so if you're making something and it's somewhat complicated and you have to do a lot of pin muxing to get the pins in the right order, just consider making a cape, right? And like I said, all the cape really needs to be is have an EEPROM on it that fits in this address. And then you can put that device tree blob into the lib firmware, and then it'll boot up and everything will be configured for you. So it's very easy to work with. So my GPG fingerprint's also in every EEPROM. So that way, if you want to get a hold of me, hopefully, you now have my GPG fingerprint. So if you cat, the EEPROM, you'll see my fingerprint. So the next thing is the real-time clock. So again, not necessarily crypto IC, but it is important for security, right? So embedded systems typically have, a real-time clock may be a luxury for some embedded systems, but if you start doing SSL, right, there's times in the SSL certs, or there's a not before and not after field. Right, so you're supposed to check that cert, right? And so most embedded systems think it's 1970, and so they're just kind of skipping that time check, right? Well, that cert's not supposed to be used yet, so you really want to have a real-time clock. And so the BeagleBone does have a real-time clock, right? But the problem is, in order to power that real-time clock, you also have to power the board. So the Beagle has this nice feature. It's got test points on the bottom. You can put like a single-cell LiPo on it and power the whole board without having to go through the 5-volt power jack. And so that will power the real-time clock, but I wanted something that would just power the clock itself. And also, if you think about the CryptoCape, I wanted it to kind of be like a 2-factor thing, right? So if you remove the cape that has this hardware in it, right, that time is going to go with the cape. So I wanted that feature as well. And so another thing is NTP, may or may not, you may not want to use NTP, right? So there have been some security problems with NTP. If you're kind of interested in that, you can check out Jacob Applebaum's TLS date, which will basically slurp the time from the TLS handshake. So that's kind of an interesting way, I think, to get time. Okay, so the next chip is the AT SHA-204. This is an authentication IC, and so it does authentication in a very, a basic way. It's a challenge response kind of system. It uses this thing called a MAC, which is a message authentication code. So MAC is typically a tag that accompanies some data. One of the ways to implement a MAC is with a hash function. So the hash function that this chip uses is SHA-256, and it also does HMAC-256. The one caveat is that it actually doesn't do straight SHA-256. It actually combines internal data. So unfortunately, like it's not like a straight HMAC. It's kind of like Atmel's HMAC. But it does apply the algorithm, but it won't quite like be compatible with straight up HMAC. Because it would be nice to do like a time-based, the H.O.P.E, Google authentication protocol, and with this. But unfortunately, that's it's not compatible. So the real thing that this chip helps with is the like you have a medical, so I think it was designed for the case where you have a medical device and I'm the OEM of that device, and I want to make sure that my cables are my OEM cables. And so what will happen is if I'm the manufacturer, right, I can provision these chips so they all have the same key. So MAC is a shared key system, right? So I provision all these chips, and then when they plug in the cable, we do this kind of challenge response, and I should know the MAC in the cable because I'm the OEM and I'm the device, and I say, hey, is this the right cable? If it's not, because it's a counterfeit, right, then I don't allow data to go through the cable, or I don't power it, or something like this. So this, I think, is the like industrial application of the AT SHA-204. The kind of like maker project application is kind of like module to module kind of authentication, or like if you have like a garage door opener, right, you could do something where you have something like 2 devices, and we'll talk a little more examples, but that's kind of that application. It does have a unique serial number and a random number generator as well. So it's a very cheap way to get a random number generator on an Arduino, right? Atmel has an AVR library. You just plug it in and you can get random numbers. You have to kind of configure it. It also draws like no power, right? So it's like a 1 milliamp active supply, like when it's using for that like short period of time, and then it draws 30 nanoamps when it's sleeping. So to even measure that, you need something like David Jones, microcurrent gold, right, to use your multimeter to hook up to get that nanoamp resolution, right? Because otherwise, burden voltage, right? Any EV blog fans, maybe? All right, microcurrent gold, you should check it out. Okay, so use of the AT SHA-204. So the electric imp uses the AT SHA-204, and I don't think they're using any of the crypto features, but what they're doing is, so the electric imp is this device, you hook it up, you can kind of get your device on the web and do all that cloud stuff, right? So basically you get that module and you need this breakout board, and that breakout board has a unique serial number because it's using the AT SHA-204. And so what happens is when you plug your imp into a different breakout board, it'll go back to the cloud and it'll know a different serial number, and it'll run different code. So I think that's kind of like a cool feature, right? So if you plug in this thing into different devices, it knows it's on a different device because of the AT SHA-204's serial number, and then it'll do different things. So that's the one project I know using the AT SHA-204. So the ECC 108. So this one's an interesting chip, right? It does ECC, so it does the NIST curves for ECDSA is basically the feature of this guy. So the ECDSA is elliptic curve digital signature algorithm. It's an asymmetric algorithm, and the nice thing about this chip is it will generate the ECC private key in the hardware, and that private key, once generated, does not leave the chip, right? So you also have the option of importing a private key, right? So if you want to like clone a bunch of devices, but once you import that key, the private key can never be read. So that's a really, really nice feature. So it also has this. It also has the serial number and random number generator. So like where you would use one of these is if you probably have heard of like firmware signing, a software signing, right? So you can set up these chips so that your server can sign the firmware, push that update, and then these devices can store that public key, right, and verify that, yep, it came from the server. And so I'd like to mention that, if you're making a system, you can have a secure update mechanism and also make it hackable. And so what I mean by that is, right, so you can build this system, you can sign your firmware, you can push it to devices, right? But then if the user wants, because they bought this device and they own it, right? I believe that they should be able to run their own code, right? So you can have that mechanism if they want to have the secure update, right? And you should do that because that way they know it's secure and they know they're getting the right firmware. But users should be able to run code on devices that they own, and so if they want to turn that off, they should be able to do that. So I don't think these, having these chips is necessarily in conflict with kind of keeping like an open system. But yeah, for this chip is an NDA'd spec, but Atmel does release an AVR library that will show you basically how to use the signing features, which is what the kind of purpose of this chip is. And then I've written a Linux compatible command line application for this guy as well. So the next one on there is the AS132. So this is an encrypted EEPROM. It's AES 128, so that's kind of like, But then you have a CCM mode, which is an authenticated mode, so that's kind of like, right? So it'll basically store data on the chip, and then it uses a MAC, right? So you could have, the idea is you can use this chip in two ways, right? You can either store the data encrypted, right? And then you present a MAC, and then that'll let you read the data back. Or you can use it as kind of an encryptor, right? So you can set up chips to basically give it a 32-byte packet. It'll encrypt that packet and return it to the host, right? So then you can send it to another device with a paired AES-132, and then that can potentially decrypt it. So Atmel does have AVR code. I haven't yet been able to write the Linux driver for this, and it. Yeah, so if you're looking for this one right now, you can look at the Atmel's code. So the 328P, right? So it's got, so like I said, it's got the Arduino 3.3 volt bootloader, and this ended up being one of the more fun devices on there, right? So it's got the Arduino, right? So yay, Arduino. But the thing is, you can upload sketches from the Beagle to the Atmega, right? So I tied the UART lines from the BeagleBone to the serial UARTs at the Atmega. So you can program, basically you can program your Arduino from a BeagleBone. But see, I wanted this, so if you could do that in software, the problem was, well, if there was a software vulnerability, I didn't want anyone to be able to do this, right? So I put jumpers on there, and you can only do this if you have the jumpers attached, right? So if you pull, so the board comes without the jumpers, so that means you can't do it by default, but if you soldered 0.1-inch headers on there, put jumpers on, you can flash your Arduino sketches into the Atmega, pull the jumpers off, and then software can't change this, right? You can also use the ISP programming header, so you see the little 6 guys next to there. You can use something like a Pocket Programmer. The board technically is not 5-volt friendly because of this oscillator, which I'll talk about a little later. So if you do, make sure to switch it to no power mode, but you can also program the Atmega right from ISP, and Arduino ID and everything is fine. So the really nice thing about that, which may not be obvious, is there's just so much code out there for Arduino devices, right? So I've taken like the fingerprint sensor and made like a 2-factor thing in like minutes because I took someone's code library on someone's forum, right, under some beerware license, and it's like, fine. And loaded it, flashed that into that Atmega, right, and everything works. And then I'm able to interface to that from the Beagle because the I2C lines are the same. So you put a little I2C handler on there, and now you can communicate from the BeagleBone to the Atmega very easily. So my original idea was to put the crypto library NaCl on there. So for those who haven't heard about NaCl or SALT, it's kind of like there's a lot of interest in the academic community about this library. It has some of the primitives are available for AVR, but like the whole CryptoBox API isn't there. Also, because the chip is running at 8 megahertz, it'd be a little slow. There's also some interesting glitch attacks you can do on an Atmega. So for a whole bunch of reasons, it's maybe not the best to run a crypto library, but that was the original idea. And so I wrote this article, Linux Journal, if you guys read that, in May 2014, to kind of show the whole Arduino concept, right? So, and I explained a lot about this device tree. So if you're kind of interested in kind of have a Linux background of that, you should check out that article. And this is the schematic, right? So basically, this is like the Arduino on a breadboard schematic, right? So it's just got the ISP, it's got the LED on the normal spot that Arduino Uno has got it. The only thing that's really new about this is, so I'm tying it to the BeagleBone's UART4, right? And tying that reset line to a GPIO. So that's also a nice feature because then I can software reset the Atmega from the BeagleBone. So if I just want to reset it, right, I can have a script or something or make a cron. You can use all this Linux features, right, to control this Atmega, which is kind of, I don't know, I've had a lot more fun with it than I originally anticipated. So the TPM is an interesting chip. So the TPM has been around for a while. It got a lot of, there was like a big kind of outrage to the TPM when it first came out because of the DRM capabilities, and it's probably in each of your laptops, and it's not on by default, so you may not even know it as a low pin count version. But so the things against the TPM is that it can kind of know the state of your system, right? So privacy advocates are appropriately concerned about the TPM knowing exactly what's on your, how your system is configured. But if you think about it, right, if you're building an embedded system, that's like exactly what you want, right? So you build this embedded appliance, you want it to do this one thing, right? You're going to if you put a TPM on it, you really want to know that thing's doing exactly what you think it's doing, right? So I think TPMs make a lot of sense in an embedded environment, probably much more so than they do in a consumer laptop environment. So cryptographically, the TPM is actually kind of limited, right? It only does RSA 2048. It has SHA-1. But it has some it has these little features there that really make a lot of different functionality, right? So it's got this concept called platform control registers. So platform control register is a 20-byte register that you can only write to with this extend operation. And so the extend operation is defined there. Basically, you have to take the SHA-1 of the current value of the platform control register plus some input, right? So what that means is you can only kind of progress the PCR in one direction, right? So you can only keep adding input to that. And so based on that one feature, you can do things like secure boot and remote attestation. And so this is kind of, which we'll talk about a little bit later. But that's kind of an interesting feature that's kind of specific to a TPM. So the TPM also has this key hierarchy concept. It can, has different keys in there that'll wrap other keys, starting with an endorsement key and a storage root key or a shark. So yeah, so I have the TPM I have on there, is fine. Like I've been able to use it for different things. There are some other ones that's like, oh man, I want to pick that, right? So they have, so Atmel has a version of the TPM without this external oscillator. So it's like, because that oscillator is preventing the board from being 5-volt friendly. I was like, oh man. Then they actually have versions that are FIPS 142 certified. So if you're kind of into the whole certification thing, right, this certification costs a lot of money, and the whole module is FIPS 142 certified. So that's kind of a neat thing. And then the other thing is for people who have, maybe have used this, right? So the TPM version I picked ships in compliance mode. And so what the compliance mode means is that it has an endorsement key on the TPM, right? So you get it has an endorsement key, things will work. The problem is everybody has the same key. So that's like a test vector, right? And so, so I didn't actually learn about this until afterwards because I was like, hey, everything's working. And then I was like, oh, why is this key the same on this board? And then so I was like, oh, I picked the compliance mode version. So there is a way you can clear that, right? So I haven't yet put that up on like my website, but you basically have to clear the TPM. You can generate a new endorsement key, which is probably good anyway because, again, there was privacy concerns about the endorsement key. So you'll generate your own endorsement key. It can't be tracked to a TPM. But yeah, so that was kind of like, oh man. All right, so the other thing that would be nice is, so there's this new, I don't know how new, but there's this industrial version of the BeagleBone called Blue Steel. And so what they did is they removed the HDMI framer and they removed the EMMC, right? And then it can be supported for industrial applications. So this is, again, one of those things where the BeagleBone, you can use it in the product. And if you're doing something, either crazy, some cold environment or something really hot, you can actually get an industrial BeagleBone, which I think is pretty cool. And so there's a TPM version that will do support industrial ranges. So yeah, so the issue with the TPM is so it's covered by a spec, right? And specs are covered by committees. And so then you end up having very large specs. And so with the TPM, there's a lot of software, if you're using with Linux, that you have to get through before you actually talk to the actual hardware, right? You have to go through a device driver, and then there's this whole trusted computing software stack that you have to go through, and that has all these different layers, and then you finally get to your application. In Linux, there's this package called Trousers, which essentially will implement this. So you really kind of don't have to worry about it, but it's like this kind of a lot of bloat you have to kind of bring in just to use the TPM. If you're trying to do this on an AVR, so it is possible, right? You can talk to the chip just at the device driver level. So Atmel has code in their dev kits that will use the AVR code. So you can use TPMs on AVRs. Typically, you've probably only seen them in laptops or these kind of things, but I haven't yet tried that, but I have seen the code for the AVR. So what can you do with a TPM? Well, so so there's some TPM specific features. The first one is called secure boot, and that's a more like a stronger version of trusted boot. And essentially what this is when the computer boots, it'll use that PCR extend function, right? So your computer will boot, that bootloader, before it is executed, will go out and take a measurement of it. So the measurement is essentially that extend operation. It hashes the input, puts that into a PCR, and then your second stage bootloader your first stage bootloader will verify your second stage bootloader, your second stage bootloader will verify your kernel, and then your kernel will verify your initfs, right, and keep going and load everything into the PCRs. And so when you finally get into user space, all your PCRs are populated. Now, if none of that changed, right, you would expect to see the same PCRs every time you booted. And so that's kind of, with secure boot, one thing you could do is to kind of like lock down those PCR values and say, okay, I only want to do things if things are at this certain PCR state. So that's known as sealing data. So you can actually encrypt data to PCR values, right? So that means if anything in your boot chain has changed, you will not be able to decrypt something on your device. right? So that may either be good or bad, depending what you're doing, but if you were concerned about some sort of kernel vulnerability or someone changing that, right, that data would be essentially inaccessible because the PCR values changed. Now, so an embedded system, this is a little bit tricky because on a laptop you have right, the luxury of having a BIOS and that, you have Grub, right, and so there's a lot of support for this because TPMs are made by vendors such as, like Microsoft likes TPMs, right? And so they want things to work for them. So the embedded system, we're kind of a little bit out of luck, right? The BeagleBone uses U-boot, and then, right, there's no BIOS. And so this guy, Teddy Reed, wrote this libsboot basically to hook in the TPM into U-boot. So you have to kind of install that and then use the Linux integrity subsystem, which is called IMA, to get all the different measurements of basically once you pass the bootloader stage. Then the TPM supports this feature called attestation. Attestation is the ability to take that PCR value and then kind of prove that to a remote entity. Right, so this is again where privacy people kind of freak out, right? Again, appropriately, because if you have a laptop and it boots and the PCR values are one thing, remote attestation means I can, if I'm a content provider, I go ask your laptop, hey, what are the PCR values? And you tell me, and I go, that doesn't match. So I'm not going to show you this movie, right? And so that's kind of concerning, right? But again, in an embedded system, you kind of actually, want that feature if you're designing an embedded system, right? Because you want your device to kind of boot in a certain mode. And so, so TPMs support this attestation feature, which I think, makes actually sense in an embedded world. And so the nice thing about TPMs is there's actually a little more software support than some of the other chips. So through a software interface called the PKCS11, which essentially is a library that will kind of allow, it's a smart card library, and a TPM can look like a smart card, you can store RSA keys in the TPM. So for like SSH, right, I have my SSH keys stored in the TPM on my BeagleBone, right? So the SSH key never touches the BeagleBone. And so the developer of this library, I think, is at H.O.P.E. He may be in the audience, I don't know, but he is essentially allows you to configure SSH to generate and store your SSH key right in the TPM. It never touches the software. And so the same could be done with SSL, and it also could possibly be done with GPG, although I don't know if anyone's done that yet. And so this, to me, is a very attractive feature, right? So the H.O.P.E. lead situation, right? It would have been less bad with a hardware security module because you would have still leaked, the initial session key and whatever secrets were there, but that private key would never have gone into the software, and so it never had been an opportunity to been read by a software vulnerability. So TPMs called things measurings. This is my obligatory meme picture, right? So measure all the things, right? And so if you have a Raspberry Pi, I don't want you to feel left out, right? So you can use all those chips, right? It's just the I2C interface. And I'll be putting something up on Tindy that is a little Frankenstein adapter, right? So so the form factor is not the great, but hey, if you really want to use the CryptoCape on a Raspberry Pi, so I got this little board. So again, on the Raspberry Pi, if you want to use the CryptoCape, basically you just got to tie the UARTs, tie GPIO to reset the app mega, and then you have the I2C. The problem is the TPM driver isn't available until 3.13. So we backported it for BeagleBone, but I don't think Raspberry Pi runs a 3.13 yet. So the TPM might be a little bit lacking there. So when would you want to use HIC for whatever project? So the AT-SHA-204 is really good for basic authentication and small scale systems, right? Because it's a shared key system, it's really hard to kind of manage if you were doing like a large deployment. But if you just have a couple devices and you want to make sure that those devices are only talking to your own devices, or if you have a module, right? So if you make a module and you plug it into your Raspberry Pi, you want to make sure it's that your module. The AT-SHA-204, you just put them on each end, you configure them, and that would be, I think, a good use of the AT-SHA-204. The ECC 108 does provide stronger authentication, right? Because it has asymmetric cryptography, which has that non-repudiation feature. So you would want to use these if you needed some sort of PKI support. And if you were doing like the server firmware model, the ECC 108 would be good because you can have the server generate a key, right? Distribute that public key to all your devices, and then the devices can authenticate that public key and then accept the firmware. So the 132, right? This is the encrypted EEPROM. The nice thing, right? It has the confidentiality and the authentication mode, right? So you could have like your Arduino, you could load everything in this AES 132, and then because it needs this authentication mode, you can still require some sort of input. So if you have some sort of password thing that's the MAC, right, you kind of expose that, and then you can make sure that if the device is sitting around somewhere, that people can't access that information on the chip. It could also probably store keys, right? It's only a 32 kilobyte EEPROM, so there's not a whole lot of room. And the TPM would be the chip to use if you needed, like more sophisticated software support or anything dealing with RSA. And so just as, the caveat, right, none of these chips will automatically secure your project, right? So you still have to, just like you pick out some sort of component, passive component, you can't just like plop that on and expect it to work, right? You actually have to kind of like design with it, right? So the same thing with these. So there's that. Okay, so I want to kind of talk about a project that I think is a good use for some of these devices. So running Tor on a BeagleBone Black. And so I ran Tor on a BeagleBone Black for about 9 months. So I had a Tor relay. And I just want to talk basically what Tor is, kind of the experiences of running that on a home network, and some things I think are nice with the BeagleBone that you can do with a Tor relay. So for those that don't know, Tor is an anonymity overlay network. So it's a network that runs on other networks. Provides anonymity in the fact that it protects your IP address. And so if you should probably follow this Twitter account, right? So this is a hilarious Twitter account. What it is it will tweet anytime in the US, somebody in the US Congress or Senate makes an anonymous Wikipedia edit, right? So it knows, because your IP address is geolocatable, right? It knows the subnet that is reserved for .govs, and it knows, hey, this is the US Congress. And anytime one of those staffers or anyone gets on there and changes Wikipedia, it tweets. And it's kind of hilarious, and it kind of really makes you, I don't know, it doesn't make you trust Wikipedia as much. So that's why you should always go to the talk page, right, and see the background. But I think the one, like the other day, was one of the Russian Today journalists, right? It said someone in the Congress made a change that, like, this Russian Today is a journalist, and he changed it, or he or she changed it to, this person is a Russian propagandist. If you're, a government staffer, you probably should use Tor, because you won't show up on this Twitter thing. I don't know if any of you are here in the audience, but you don't have to tell me. So yeah, it also has strong censorship resistance. So there's this concept of Tor bridges, right? They were basically designed to block the access to Tor. So censors decided or realized that, hey, we can block Tor very easily if we block people's access to Tor, and Tor responded with the concept of bridges. Tor is often used when governments try to shut down the internet. So some governments are better than others at doing this. The last example, I think, was Turkey, right? And Turkey tried to block access to Twitter, I think, and then people were using Orbot on their phones to access Tor. So and Tor, what's nice about the Tor project, it has these very nice metrics, right? So you can go see and look up, people connecting to Tor from Turkey in this time period, and you'll see this nice spike that corresponds to when this whole thing was happening. And so, yeah, so there's a little, what's ironic about this, I find, is, the allegations that the government is now snooping on anyone that's, running Tor. So you have this nice patriotic poster saying run a Tor relay, and, well, yeah, maybe it's not the best message. So for those that don't know, just a very quick primer how Tor works and where your BeagleBone fits in. So the way Tor works is you have a bunch of nodes, right? And so you have some of the nodes are special nodes and that do different things, and then you have your client. So your client in this case is Alice. Alice is always trying to talk to Bob, who's on the other end of the network. So Alice wants to use Tor. So the problem that Alice initially finds is that how does she discover the first entry into the Tor network? Well, there's these servers called directory servers, called, in this case, Dave, and Alice goes to the directory server and says, hey, give me the list of all the Tor relays, and Dave responds, here's the Tor relays, and then Alice can build a circuit through the network, and so, and so the green arrows represent encrypted communication, the red arrow is unencrypted. Tor does not encrypt the internet, so if you request something unencrypted in Tor, right, it'll output from the exit relays unencrypted, right? It doesn't automatically encrypt that. So that's why you should always use like HTTPS when you're using Tor, or use Tails so that you'll get, kind of all this set up. But if you ask for something unencrypted, the key point is that it comes out unencrypted at the end of Tor. And so if you run a BeagleBone Black relay, your relay will participate in this network. This is unlike that Onion Pi project. So the Onion Pi project is a kind of like a transparent proxy. And the only issue that I have kind of with the Onion Pie project is that in order to really use Tor effectively, you really should be using the Tor browser or Tails. And so if you're using like IE with the Onion Pie, the Internet Explorer can potentially leak the DNS information, right? So Tor spent a lot of effort trying to make this browser. And if you first go to a DNS request and say, this is the IP that I want to go to, right? And everyone sees that IP, and then you go through Tor, then that doesn't really help you. So you should use the Tor browser or Tails. And then, of course, you can change your identity through the Tor network. So why do this on BeagleBone? And so I think there's a couple advantages to running this on a BeagleBone, especially on a home network. So one, you have the advantage that it's dedicated hardware. So you may, I particularly didn't want to run Tor on my main computer, right? I kind of wanted that separate into a whole different system. So that's a nice feature of running this on a BeagleBone, right? So it's also very low power, right? The BeagleBone doesn't, draw that much power, right? Tor is green, right? Green is good for everybody. Right, it has a small physical footprint, right? So this is not going to be a server that's going to take up a lot of space on your counter, and maybe someone will complain, like, why you have this computer over here, right? So it's a very nice little small thing you kind of put in the corner. It's right. You basically think of it as a low maintenance appliance, right? So I only had to, my relay only reset twice in 9 months. So the one time that it went offline was Heartbleed, right? So everyone was supposed to upgrade their relay, so I did that. And then I was going to a conference and I had a bunch of BeagleBones plugged in and I unplugged the wrong one. So that was the second time that my BeagleBone essentially went. But otherwise it ran for basically 9 months without any problem. You can tune it, right, for lower bandwidth consumption, right? So Tor, there's this kind of conflict between how much bandwidth you give to Tor and how, what you can use for a home network. So you can kind of tweak that bandwidth. And so this was a graph. It's not I had limited the bandwidth on my Tor relay, so this is not necessarily very fast bandwidth, and I think that's like 400K. This is after 30 months of running. But what I think is really a nice kind of like the driving thing is you can make custom hardware for the Tor relay, right? And so typically you have a Tor relay, and in order to manipulate it, you have to log in over SSH, right? So what I did in this one is I was having problems with the bandwidth, and I would keep adjusting the bandwidth rate, right? And so if you put a rotary potentiometer on the ADC pins of the BeagleBone, you can use the Python stem library, and now I can adjust the bandwidth of my relay with a knob, right? So I think it's kind of a neat way to kind of combine hardware with the server, right? So I think so I'm interested in kind of keeping going with this project. I'm trying to run one now and see how fast it can go. But when you can kind of physically interact with something, I think that kind of the response to that is a lot more than just running the relay and, oh, it's running on some server somewhere. And then I added a little front panel interface. It would tell me how much bandwidth it was using relative to my max bandwidth in my home network. And then, you always have to have a blinking LED. So I added one of those. So, what to expect when you're running a Tor relay on a home network with a BeagleBone. So there's a couple things that kind of ran in there, right? So there's this balance you kind of have to play, right? So Tor would really like it if you just gave a lot of bandwidth to them, and because then you're participating, you're growing the Tor network, it has a lot of bandwidth. But the problem is, like, you also want to use your bandwidth, right? So there's kind of a tweaking that you have to do, and so that's eventually why I ended up making that knob, so I can kind of adjust things. So all Tor relays are public IPs, and what some providers do, I've noticed, is they'll just go grab all the Tor relays and just blacklist them, right? So typically they'll do this for exits, because exits, when you pop out of the Tor network, if there's abuse in Tor, right, that'll be the ones they'll come out from an exit. But so there was like a period of time where I couldn't get to Hulu, and Hulu was like, you're running this anonymizer network, and I responded to them, and I was like, no, okay, I'm running this Tor middle relay, this is why people should run Tor, this is why it's important, and by the way, I'm in the United States, and they go, oh, okay, you're in the US, all right, we'll let you have Tor again, or we'll let you have Hulu again. So some other weird ones, like I couldn't get to Navy.mil, and Tor was originally funded by the US Navy, so that was kind of ironic. And then I was looking up PKCS 11 standards, and that RSA site was blocked from Tor, and I was like, you guys are not, I don't know. So if you do run one at home, you may experience some of this stuff. If you value kind of helping people access the internet, and you'll have to kind of make a judgment call of whether you want to do that. The other thing is you have to carefully manage the memory, right? So the BeagleBone is kind of memory restricted. And that's where I found, because Tor will open up a lot of connections and won't necessarily use them all at once. So that's where I think you'll hit the limiting, the limiting component. I'm trying to run one now, so we'll see. Also, you're going to want to do some basic hardening, to kind of get everything ready. So so I'm writing this book. So I'm trying to show some other cool things to do with the CryptoCape and the BeagleBone. So we talked about Tor in this book here that's come out in September. I'm showing how to do a Tor bridge with an OBS3 proxy. You'll see how to do like two-factor authentication with a fingerprint sensor, loading that to the CryptoCape. I use the TPM to wrap GPG keys. And then the last thing is I run an IRC network, and I have Bitlb and CNC, and then show how to use all that with OTR. So that's all running on the BeagleBone. And lastly, I'm giving a talk. You'll see me again at DEF CON if you're going to DEF CON. I'm giving a talk on the NSA playset with Michael Osman and some other people. And if you want a cool project to do with a BeagleBone or CryptoCape, I recommend you go to that talk, because I'll be showing how to make a hardware implant that attaches to I2C and then can exfiltrate data out GSM. And there's resources, and I think we have some time for questions. Thank you. Okay, yes. Mm-hmm. Yeah, so so the question is, how do I control the system reset line for that mega, right? So I just use the GPIO. I think I got a resistor in there that's tied to the, like the high voltage there, so I can pull up, and then I default that GPIO to high, right? And then so if I want to reset it in software, I just tell the Beagle to pull that GPIO low, and that'll short out that line and allow the Mega to reset. Yes, yes. And yeah, so I should say it's also using AVR dude. So AVR dude is the thing pushing, just like you would do for the Arduino ID. That's yes. Any other questions? Yeah. So the question was about the source of entropy. So that's a very good question. The one I don't have the answer to. So the hardware manufacturers, even Atmel, who's very good about pushing out a lot of specs, how they do random number generators is very proprietary. So short answer is I don't know. I think the speculation is probably like they're using some sort of thermal noise to generate that. But unfortunately, they don't release those details. So yeah. Okay. Yeah, so everything's open source hardware. So, yeah. Yeah, I mean, I think that's cool. I made it so people would learn about this and try to integrate it. So that's fine. I don't necessarily, there's nothing against that. And I think it's cool if people are using more hardware crypto. I don't know, does that answer your question? Okay. Yeah, so I occasionally get a lot of Bitcoin interest, right? So the problem, it's not really, so the hashing chip on there, like I can't really work with Bitcoin because it adds this other like custom data to that. And then the other problem is the elliptical curve chip is NIST, right? So it's not the Bitcoin curve. So it'd be kind of cool. I think one of the things I was intending to make like a Bitcoin wallet maybe, but unfortunately it's not the same. It's not the right EC curve. Okay, so any other questions? I guess shout them out because maybe that's it. Okay, any last rounds? All right, thank you very much for coming to the talk. I'll also be around. I have the BeagleBone and the CryptoCape. I'll set it up here and then I'll head out if you guys want to see it. Oh, thank you. Oh, yeah, thank you. Oh, thank you. Yeah, thanks a lot. Oh, okay. Oh, okay. Okay, cool. Do you want my card? Yeah, okay. Okay, yeah. Yeah. Hey. Yes, yep. I'll hang out right in that area. Okay, cool. Yep. Hey. Oh, I'm glad to see you. Yeah, hey, thanks for doing that. That's an awesome library. Thanks for coming to the talk. Yeah. Oh, cool. Oh, yeah, let me get this out. Oh, cool, yeah. So I want to talk about the GPG and OpenSSH server stuff. Because, yeah, I think that would be really cool to get that working. But I'll meet you out there. I'll be hanging out there. Okay, thank you for... Yeah. They are for sale on SparkFun. There's only like 14 left right now, but if you back, they are making more. So you should be able to pick them up on SparkFun. Yes? Oh, okay. Yeah.
So when how long does it take, like, when you actually, send them, send, hey, give them the performance today, I want to do this, so they got back to you?
It was, I think it was about like a month, before they were like, gave me the yes.
Yeah. And then did they say, like, well, can you come out, like, on these dates or these dates?
So, so the thing is I live in Colorado, close there, so that made that a lot easier.
That made it a lot easier.
Yeah.
Okay, I don't live too far away. I live in California, so it's
okay.
like, 2-hour flight.
Yeah.
Did you, when you applied, did you say, I really want to do this crypto cape thing?
Yeah.
Or here's like a bunch of things I could do? And
no, I was very like, this is what, when I make this
thing
video going, yeah.
If you don't want me to do that, I just...
Right.
Okay. So did you think that helped? Like,
Oh, yeah.
have, like,
Yeah.
your project?
Yeah, definitely. Sorry, yeah.
In a previous job,
Yeah.
I used Certicom's library.
Okay.
He's the guy who invented ECC.
Okay, yeah.
A Canadian fellow. Just curious if you've read any of that stuff they've gotten into how did you learn ECC at all?
So I used to work at a job that I was doing embedded security stuff that I kind of got my feet wet.
Okay, it's just that I used it only as pure software.
So
I don't know if their curves would work because their curves may have been pre-net.
Oh, right. Yeah, so that's the problem. It's like the P256, the K, I can't remember the two other curves, but yeah. Unfortunately, it's only the NIST curve. I kind of would like the self-serve, 22519. I think that'd be really cool, but yeah.
And as for hardware crypto, I have some of the older NICs that were probably
Oh, yeah.
And ask Rainbow for the info and say, who are you?
Yes. Oh, okay.
Do you have a label or someplace you'll just be searching around?
Oh, okay, cool. Yeah.
Where can I find you?
Okay, awesome. So I'll be here all weekend. I'll be running around on my website with my email. I hang out in IRC.
Okay.
Let me slip out.
Oh, yeah, those things. Excuse me while this is not ours, right? I'm going to stand, and then maybe I will pass out from all the multi.
How do you drink this shit?
So you drink one really fast, and then you drink the other one really slowly throughout the day. And it has a surprisingly long-lasting effect. I think they were hoping we turned it into a drinking game, but.
Oh, hey. Oh, hey. And you two, next. Question? Oh, sorry. I thought you were asking. Yes, we can. Hello. Got a power pose. Power pose. Being so.
Otherwise, it's just a really convenient.
Should I be?
I don't know if you'll be able to.
Yeah, I could probably get it to you. Yeah. That's the 2-minute warning light. Right. We have 2 minutes. They're putting the DVDs in. Hey, you guys came a little ill prepared. Did you bring welding goggles?
Let's roll.
It's really bright. Okay, cool, thanks. Hello, everybody. Hi. My name is Jeff, and I'm a Club Mate addict. Oh, wait. I don't know if this is the right meeting. All right, so welcome, and I'd like to thank you all, first of all, for choosing us over the bar, especially our panelists. So we're here tonight to talk about something not very new. Actually, it's kind of getting very old. It's been 20 years since the first H.O.P.E, where people addressed and talked about, discussed technology security challenges. 10 years ago, I stood on a soapbox in front of the media and other people and said, what the fuck, rallied for change, similar problems. Now, we are 10 years past that. We see a lot of the same problems. If you would have asked me 10 years ago if I would have thought these problems would be fixed, at least somewhat, I would have said yes, 100%. They have not. In fact, they are arguably getting worse. Like the lights. I don't know if it's the trip glasses or what, but may cause seizures. This is changing, right? Okay. So, how do we prevent going another 10 and being in the same position, standing up here in front of these lights, asking the same question? So tonight we have with us, all too sober, 3 great minds from 3 very different backgrounds, and pause. Go. Okay, cool. Thank you. And they will share their 3 very different and strong views on what the fuck is the problem, how the fuck can we fix it, and what the fuck y'all can do to fix it. So that was the SoCal, yeah. So I'm going to start off introductions of who you are and why you are here.
Okay. Can you guys hear me in the back, or do we need to try and bring this mic? All right. Do we have a mic we can use? All right. We'll do that.
You have the whole.
Thank you. So hello, my name is Bo Woods. I've been around the security and technology industry for a while. About a year ago, I saw a couple of folks out of DEF CON and B-Sides Las Vegas give a talk called The Cavalry Isn't Coming, We Have to Save Ourselves. And that idea really resonated with me. The idea that right now our dependence on technology is growing faster than our ability to secure that technology. When you start talking about putting computers into medical devices, into cars, into airplanes, public transportation systems, lights, as we've seen tonight, there are some that have computers in them, right? So as we move a new technology into an old product, we should probably not make the same mistakes we've made that make our desktops crash all day long. It's one thing if Windows goes down once a week. It's another thing entirely if your car suddenly turns off or loses power going down the highway once a week. It's a whole different set of impacts. And I think that this new technology that we're putting into those old technologies can have tremendous potential for safety. Talking about medical devices, using computers and connectivity can bring a whole new world of safety abilities to doctors who can save more lives, improve more lives, replace limbs with actuators that are controlled by computers that really restore a person to being themselves. But as we're making these great leaps forward in safety, we should not make leaps backwards in security that cause an attrition of that safety. So that's the position of I am the cavalry, and that's what I've been working on for about the last year, as I said. And we've done various different things. We called this session Fuzzing the Chain of Influence. The idea being there are many different ways, many different value levers that you can use to affect the change that you need to see, so that we are safeguarding ourselves, that we are protecting the technologies and doing so in a way that preserves safety and doesn't erode safety. So tonight we'll have some Q&A on how we've done that as the cavalry, as well as the 2 panelists to my left and right who have been doing different things, but still in the idea of let's fix the technology problems that we have. Andrew?
No, really, after you. I'm Jen Ellis. I am the head of community and public affairs at a security software and services company, Rapid7. I work very closely with security researchers who find a lot of bad shit. And during the course of doing that, I have seen firsthand how much the deck is kind of stacked against the research community and in favor of vendors who don't face liability and in most instances are not necessarily particularly keen to jump on the security bandwagon when it comes to what they're selling. And so more recently, I've been working with the cavalry and I've also been working on trying to help educate those in Washington on why security matters and why this is a really big problem that's only going to get worse and why we need to change the way we're doing things and how we can change them.
Hi, I'm Andrea Matwishins. I'm sort of the outsider on the panel. I'm a law professor and a developmental psychologist. And apart from that, I'm currently serving as the Federal Trade Commission's Senior Policy Advisor on Privacy and Security. So the first thing that I will announce in that capacity is that the Federal Trade Commission will be at DEF CON running a contest that is focused on building the next generation honeypot dealing with robocallers. And so I encourage all of you to please participate in that contest and join us at DEF CON. And the official rules are now available on the Federal Trade Commission website. And it is one way that this community can truly fruitfully engage with the other relevant constituencies, such as the Federal Trade Commission and government agencies that are interested in this stuff, by participating in this kind of a venture to build bridges where people meet and cooperate and we build a more secure environment for all of us. So that said, that is the end of my piece as a Federal Trade Commission employee. And now everything that I say from this point forward constitutes solely my opinions as an academic and should not be attributable in any way, shape, or form to the Federal Trade Commission. So these are my ideas and mine alone. So it's a strong disclaimer for everything else that follows. So to that vein, I've been observing this community and the workings of government around the issues of information security for over a decade now, and being a fly on the wall at DEF CON and Black Hat and conferences like this. And so the evolution of both this business community and the informal hacker community, it's been fascinating to watch as an academic for me, but also the way that the public has engaged with these issues. And so there definitely is a groundswell around these issues and helping to bridge the conversations, the very high-end conversations that happen in spaces like this with the conversations happening in the mainstream, in the media and the press. It's a formidable challenge, but it's something that you guys really can do and help to build those bridges. In particular, one of the themes that I see recurring in the media, in government circles, and in our circles here is the question of what it means to be innovative. What are we building? What is this society that we're building for the next generation of the technologies that are going to engage with us, our bodies, our devices, our social systems? And one of the fundamental questions that I see pervading all of these circles relates to the question of whether more innovation is better just for the sake of more innovation, or whether responsible innovation should be the hallmark of the next generation of innovation policy. And so I'm definitely squarely in the responsible innovation camp. Just because we can build something doesn't necessarily mean that we should. There are some systems that are better, for example, not connected to the internet because there are negative externalities that can happen to our society as a consequence, right? So we need to make this calculus in a reasoned way and not simply build for the sake of building. And that's the main contribution that communities such as this and the public discourse that we trigger here can value add to this conversation. And every person that you educate in these questions, it's one more person that can engage intelligently and teach other people. And so it's the responsibility of each of us as informed citizens to try to fix the challenges that we face as a society in building the next generation of technology engagement in our social systems.
Thank you very much for those wonderful introductions. So, I mean, I think it was you, Jen, last night who said, well, we were brainstorming and bitching about the problem. So if we all know the problem, so what is the problem? What are some of the challenges, the top challenges you would say, that you see facing our world as it relates to security?
Go first?
Nope, you.
All right, I'll go first. I'll say one of the biggest challenges is leadership and going first. We didn't plan that, but I think that one of the things that we recognized with the I Am the Cavalry movement is when we look around and ask, who is taking it upon themselves to make sure that security and safety issues in the next generation of technology products, the next generation of life-critical systems is safe, you kind of draw a blank. There's some vague hand-waving, oh, it's over there, those people are taking care of it. Well, how do you know? Well, I'm sure they are, right? And that's not really good enough when you're dealing with impacts as severe as this. We have to know, not just believe, that somebody is addressing the issues, that somebody is considering them, that somebody is thinking about it and making informed, technically literate decisions. Whatever your feelings are, I think we all can agree that making an informed decision is better than making an uninformed decision. And no matter what the cards may fall out on privacy and security and the Internet of Things, if the decision is made in a way that's informed, that's has input from all the stakeholders in the system, and there are many, many stakeholders in these systems, that it's going to be a better decision with more people in agreement. Otherwise, you just kind of have to get lucky. So taking some kind of a leadership role, standing up and going and taking on those issues and initiating those kinds of debates, those kinds of thoughts, and doing so in a way that is inclusive rather than just a bunch of people sitting at a conference yelling.
So I think one of the biggest challenges is the complexity. I think that the people who really, really understand what's at stake here are typically people who either work in security or have like a deep passion for it in some regard, and have the sort of technical nous to kind of get it, or have invested enough time to really get it. And that's great that those people have. The challenge is that the security industry is still relatively young, and in the past sort of 30 years or so that it's developed, we haven't, and I say we as in like I'm part of the security industry, we haven't really done a great job of making this simple for other people. In two ways. One, on a technical level, like we haven't solved a lot of the sort of complexities that befuddle people like my mum on a technical level, like encryption and passwords and that kind of stuff. But the other side is we haven't dealt with the communication issue. We haven't found ways of talking about this problem in really, really simple, meaningful ways. And now we're at a point where like we're starting to a little bit more because it's a little bit more tangible to people. But we haven't really got to a point where we can tell the story in a way that is super compelling and stops people from walking out. I'll go now. And so I think that's one of the big challenges, and definitely like that was something I encountered the first time that I went to DC. Is I was kind of there saying like, oh, we really need security research. It's really important, and the CFAA is bad, and it stops people from being able to research. And people were kind of looking at me blankly, going, well, Obamacare blew up. What are you talking about? And I was basically telling them that we need to build a rocket ship and go to the moon, and they didn't know what the moon was. And we haven't told them yet what the moon is.
So following up on that point, I think the education gap that Jen just highlighted is definitely one of the formidable obstacles that exists in this space. So on one level, we have uneven knowledge among government actors, be they policymakers in Congress, regulatory agencies, or judges. On the next level, we have corporate decision makers who have dramatically different understandings of what good information security is and what duties of care are owed to customers and business partners. And then consumers are yet another level of an educational challenge and knowledge deficit that needs to be remedied. And so with these three different levels of individuals, different strategies will best work in terms of educating them, but each is a formidable obstacle. The second point of deficiency that currently exists, we're at a point where, and this is a very legalistic, nerdy point for those of you who are law interested in the audience. There's a fundamental conflict between the traditional paradigms of responsibility and liability for products, physical space products, and the liability regime, or really lack thereof, that has traditionally applied to software products. So these EULAs that we all click on that essentially disclaim all liability for the creators of the code, once that code starts being embedded in things like cars that can kill people, there will inevitably, and we're already seeing the first harbingers of these cases, inevitably be cases dealing with code malfunctioning in potentially deadly items, such as a car, and public interest will immediately be sparked, and legislative interest will then consequently be sparked. And so trying to come up with the optimal way to reconcile the liability regimes with a bigger picture plan for innovating well. It's a tension that we haven't quite figured out yet, and it's important that we do that because on the one hand, we need to have responsible code in the system, but on the other hand, we also need to be conscious of the space that creative people need to build new products, to innovate, and to offer us the next generation of technology. And so it's that fundamental tension that we have not figured out yet in society that is an obstacle.
Add a story that, so to highlight this, so there's a huge amount of innovation that's coming out with the Internet of Things. There's lots of Kickstarters and some really, really cool startups. And I was at an Internet of Things event recently, and I was chatting to one of the panelists after the event. His company, they make a post-operative care bracelet. It's a pretty neat idea. The idea is that by wearing this bracelet, you can be discharged faster, but you can also find issues faster and get the care you need, which is great. It makes sense to me, probably most people in the room. So I was chatting with him, and I was saying, like, you know, how do you go about building security into your software development? And he said, oh, no, we don't develop any software. And I was like, oh, how does the bracelet work? I mean, how do people access the information? And he said, oh, there's an app. And I did a kind of Stewie Griffin. I was like, you know, right, that the app is software. And he kind of looked at me and was like, and then he kind of shrugged and went, okay, and walked off. And I was like, oh God, he's not the exception, he's the norm. And that's the problem right there. You don't want to curb that innovation. That innovation is really, really important. But and organizations like his, they don't know how to build security in. They don't even think of themselves as developers.
Yeah, I think that like shrug it off is kind of goes hand in hand as well with the issue in American culture specifically, where you show someone vulnerabilities, and I'm sure everyone knows this all too well, and you might not get hired again, and they might hire someone else, and it's just, oh well, okay, that's there, and we'll do something the next time. Kind of let it go. Oh, not an app, not software. Okay, so what do you think that, or before that, why do you think it hasn't changed? What, if you could cite a specific reason why this hasn't changed throughout, on top of what you've already kind of discussed as what the problem is, what would you say? Anyone?
So one of the functional reasons is the lack of software liability, because at present, the way that these kinds of problems evolve in a space where the law is just beginning to demand conduct of for example, companies that experience data breaches or that act unreasonably in their security processes. When the liability is just starting to evolve around those things, it's easy for companies to choose to simply build that cost into their business models or to ignore the important broader economy stability concerns and shareholder interests. And until a robust liability regime exists, at the point that something like that would exist, until such time, it is easy to ignore the impact in terms of data loss for some companies who look very short-sightedly quarter to quarter at their business modeling rather than the long-term real impact on customer loyalty, the economy at large, business partners who are subsequently harmed because of lost shared data, et cetera. So that ability to look only short-term rather than big picture in terms of protection of data, that's one of the reasons that to date, we haven't necessarily, in my mind, seen as aggressive an evolution in internal standards of care of data maintenance, at least in the private sector.
Yeah, and I agree with that. I also think that this is a big problem space. There are a lot of problems to potentially solve. I don't know how to solve all of them. Maybe nobody does, but one of the things that I've come to recognize is that it's not my job to solve all the problems, right? I'm standing here, I'm seeing the problems out there. I'm seeing that somebody else is directly in the line of those problems. Essentially, they have the incentives to solve them. They have the capabilities to solve them. If I try and go, walking over there and point at the problem and say, I'm going to solve this problem, I'm always going to fail because I'm going to be running into somebody else. But I think part of the way that we go about fixing that, the problems over there, is we have to understand that the people over there are our friends. They, in general, want the same things that we do. Sometimes it's literally just as simple as getting 3 or 4 stakeholders in a room, people from representing different groups, and talking to them. They may not realize that they're doing application development. And so maybe they think, oh, I didn't know I was doing application development. All right, now help me, right? So instead of trying to shout at them or preach to them or, the worst case is tell them they're stupid and ignorant and that they aren't possibly as smart as we are, you get them to invite you into that conversation. And I think that it has to start with education. It has to start with outreach. And it has to start with a fundamental understanding of their perspective, their point of view. Otherwise, you're always just going to be butting heads with each other, and that clearly isn't effective.
I think this is frighteningly simple. Why we are where we are. Why did GM not recall the cars with the ignition issue? They didn't do it because, really, really simply, the cost of a recall is higher than the cost of life. Simple as that. And that's the same calculation that's being made, but to Andrea's point, with less information and understanding on what the real costs are on either side of the equation at the moment. And the bottom line is, going back to that piece about how complex this stuff is, we aren't at a point at the moment where the majority of consumers are voting with their feet based on security choices. And so it doesn't apply pressure to vendors at this point. For them to build security in. There are relatively few vendors that are really selling on the USP of security at the moment.
Okay, so good reflection. I agree with that, and I think we've talked a lot about the problem. Now let's talk about how we can fix it. And things didn't get this way overnight. They got this way slowly, and I think one of the other things that people experience in this industry, there's been some studies recently about this, is obviously getting burnt out and going really hard and trying to solve all the problems really fast, or even just 1 or 2 of the problems. I think there's a lot to speak about around that, but do you think there is some small quick fixes we can do, or do you think that to set our expectations properly for a slower recovery back to a place where we want to be, or to a place where we want to be. I don't know if we were ever there. And what are some things we can recommend that people do or people together can do to kind of alleviate these problems?
So I'm taking this first so that I can make the joke, I have hope. Thanks. I'll be here all week. I think that we may be slightly different on our outlooks on this. I am the hopeful one. I think that we're in a situation right now where technology development is moving faster than society is able to keep up with it, and certainly faster than legislators are able to keep up with it. But the good news is that I think people are becoming more aware of that. They're waking up to that. And there is lots of conversation going on around how we respond to that. Now, granted, the conversation may not be going in exactly the right direction all the time. And there is definitely work for us to do in influencing that conversation. But here's the good news. You guys are the good news. Because there's a room full of people sitting here at 10:30 at night when you should be in the bar. And you're all powerful. Every single one of you is powerful. We're powerful. And Andrea's particularly very powerful. And we actually can influence. We can have influence. We can help educate. We can make the people around us care more. We can make it something that they can attach to and understand. You probably all have played, being the tech admin for all of your friends. You've been help desk at some point for your family. And it's really annoying to do it, but you can help save the world by, actually not just doing the role of that, but actually educating people on, what good security looks like and why it's important. Helping people understand that physical and virtual, there isn't really a good line between those things anymore. And actually, security equals safety now, and it does matter. And you can all help with that. You can help to show that that you care about this in the choices you make with your vendors, and you can do it in your online profiles, and you can go onto Amazon and write reviews, and you can write to your local, I was going to say member of parliament, that is not the right expression. I spend time on Capitol Hill, don't you know? Congress. Critter. You can do all of that stuff, and as somebody who is in DC on a regular basis, having conversations about the problem, there are actually a lot of people who really care and who really want to do something about this. It's not a simple problem to fix, but the fact that they care and that they want to have the conversation and that they want to learn more is a really good starting point.
Yeah, I absolutely agree. We were talking last night and we said it's the adopt a derp, right? Find somebody who's a derp and turn them into not a derp. It's a tractable problem. It's solvable. All it takes is just go to talk to somebody, right? So maybe in your own organization, you find someone who's they're interested or they're in a role where they can influence a change for the better, and just go talk to them. Sit down. Hey, what are your concerns? What do you care about? What are the things in security that you want to know, and how can I answer the questions that you've asked, not throw a bunch of answers at you and you haven't even asked a question, right? I also think that we have to keep in mind that this is a long game, right? Like Jen said, car manufacturers might not recall a car tomorrow because of a security problem that we found that affects safety. But you know what they can do? They can build the fix into the car that's coming out in 5 years. That's something that they can very definitely do. You know why? Because that prevents the recall discussion from even coming up in 5 years. That's a great long-term cost-saving measure. Understanding that there are more ways than one to win, I think, is something that we have in our day jobs when we're out, trying to hack firewalls, right? Oh, I hit that port and it wasn't open. I guess I just quit and go home. No, we don't say that. We hit something that's closed, we hit a wall, and we work around it. We figure out a way to succeed in the face of every opportunity to give up. I think we have to do that in this game too, right? We have to do that when we're pushing for things that are good, is not give up at the first or the second or the third hurdle that we hit. Just change our technique, change our tactic, and be persistent.
I recently had the pleasure of keynoting at Source Boston, and the advice that I gave there, many of you don't work in security consultancies. Many of you work in traditional industry as the expert in your domain. And in those organizations, someone who is intuitively aligned with you is the general counsel. Go befriend a lawyer in the general counsel's office. Have conversations with that lawyer about these issues and about what it means for society to have vulnerabilities in key social systems and products that we are all using on a regular basis. Have a human-to-human conversation with that lawyer, and that lawyer will become an ally, and lawyers are used to thinking about risks in a not yet fully actuated way, to anticipate risk and to avoid the risks rather than mitigate exclusively. So the kind of training that a lawyer has is intuitively allied with the type of enterprise that you all as security professionals or security and privacy interested individuals have. And having a powerful ally in the general counsel's office in a company, you basically have those people fight the battle for you. And you become a resource to them, and then you have a stronger unified front inside your organizations. Because security isn't just about technology companies, right? It's about traditional industries also getting up to speed with their incorporation of technology into their less technology-driven enterprises, right?
And I think you just said something that made me think of something, which is talking to people like a human and actually sitting there instead of making people feel dumb, which not intentionally most of the time. Sometimes I think security can be really intimidating to people, and obviously for good reason. And a lot of people over the last 10 years have used fear as a motivator, digital Pearl Harbor, oh my God, everything's going down. And while there's good reason to have the fear, or to know that, I don't think fear is a good long-term motivator. And when connecting with people on a one-on-one basis and helping them understand why their password shouldn't be their street name across all of their 20 accounts, doesn't have to make them feel dumb, though they may once they notice how silly it is. Connecting with them on a one-on-one level helps a lot. So are there any more, do you guys want to open up for questions now? All right, yeah. And anyone want to ask a question? Come on up, I'll hand you this wonderful microphone. If you have sunglasses, I suggest you wear them. The lights are still kind of bright. We have candy. Come on down.
You had me at espresso bean. No, really. I've taken the candy. It's that easy. So, yeah, vulnerabilities, bugs, fixing things, GM, valuation of how long it's, monetary loss. Just, I totally get that. The one thing that concerns me now is like in light of the, revelations about NSA practicing tradecraft, leaning in VP's ears, leaning over standards bodies and going, hey, it would really help us out to, if you would just choose that spec instead of that spec, how much of you, I get the feeling, yeah, okay, it costs money, but I also think that now we have to think about this possibly more pernicious thing about, it would really help us if you just didn't fix that, or it would really help the company because we've got this other product coming out that's going to address that. If you just wouldn't fix that, or if you just kind of maybe kick that down 2 versions down on the roadmap, what do you say to something like that? How do we fight that?
This is a new form of yoga we're doing with the microphone over here. So Jeff's pioneering tonight. You're in the presence of genius. Thanks for the question. I think that's something that I tend to be really focused on safety rather than the privacy issues, though those certainly exist. From a safety angle, I'm not as worried about someone leaving defective code or inserting defective code. I think it's certainly a possibility, but the first hurdle that we have to get over is just not doing the things that we know are dumb, right? So if we can just do those things that are fairly easy, fairly straightforward, I think that's the first priority. Right now, I'm more afraid of accidents than adversaries, to be honest.
Wow.
I don't know if you want to answer or not.
Bean?
Sweet.
All right. This is working well.
So I loved that you said that fear is not a good long-term motivator. So what I wonder are what are some sort of positive visions of what better secure software can give us, other than all these scary things? They won't happen to you, or they'll be less likely, because it seems like perhaps the reason that fear is not a good long-term motivator is people are very good at just pushing fears out of their mind.
Or making quick knee-jerk reactions to something temporary fixing, but not something that'll actually fix it long-term. What do you guys want to?
So some of the conversations that I have on a regular basis are with people who are sophisticated consumers, but yet not necessarily technologically as sophisticated as you guys are. And I find that perspective very informative to me to understand kind of the reality of the upper end of the consumer knowledge base. So when H.O.P.E happened, I started having conversations with some of my law professor friends who are not technology focused, because I wanted to kind of see the world through their eyes. And what came through to me is that they all knew that H.O.P.E happened, and they knew that they needed to take action because that's what a responsible person would do. And they understood that that meant changing their passwords, and they understood the dynamic of, I may need to wait a while so that companies have a chance to patch things, update. But the minutia of the tech, of how exactly H.O.P.E was a risk or how it functioned, that wasn't of interest to them necessarily. They knew that something bad happened, question mark in the middle. They needed to take an action because that's what is responsible. And so this idea of being responsible in your technology conduct, the same way that you're responsible with your finances, the same way you're responsible with your work product, there's an innate competency, interest that people have. And if we can appeal to that broader sense by not making them feel stupid, but just this is one other dimension of this generalized responsible conduct that we all engage in. These people that I spoke with, they were all on top of it to the extent they could be, but none of them really understood the middle piece. It's like with my students, I sometimes use the South Park underpants gnomes example. Some of you are familiar with that episode. So these creatures hoard all the underwear, and they have a meeting. And there's a business plan. It says, step 1, hoard all the underwear. Step 2, question mark, question mark, question mark. Step 3, profit. Okay? So it's okay with some of this stuff for there to be a big set of question marks for consumers. But step 1 and step 3 need to be clear. And the reason that H.O.P.E was a fascinating case study for me of a security communication is that step 1 and step 3 were clear to many consumers. And that's a win. And it's probably okay if we have that step 2 question mark, question mark, question mark in there. So that's something for us to ponder as a community.
Yeah, I think that's a great question, and a good answer as well is that I think saying that we don't have all the answers and we don't know versus saying this is what we need to do and let's drive for them, kind of leaving it open to figure it out. Coffee Bean?
At risk of sounding simple, I know something that's dumb. Signing away all of my liability every time I click a EULA. I mean, like, what if we put some of that responsibility back on the developers? Hey, you develop an app, that's software, you're responsible. in a little bit more capacity than you are now.
That sounds great. Write a letter.
What's that?
Write a letter. Do it.
Do you want to answer that? Simple stuff.
No, I agree. I think we all think that there is a woeful lack of liability. It's interesting to me that software engineering is and I'm not an expert on engineering, but I think it's the only area of engineering where you can build shit and there's no safety code you have to meet. And that was fine when there was this like big gap between physical and virtual, but when it's the brakes in my car, it's not okay. So I think like we're getting to a point now where there needs to be some liability on vendors, and yeah, I definitely agree. I think there's too much power in the EULA, so you guys should make that heard.
I think it was the Usenix magazine a month or two ago did a really good write-up on like basically liability for hackers, right? Like what you need to know about the legal liability system. So if you're really interested in that, go read the paper. It's like 3 pages. It's really short and it gives you a great primer.
Yes.
Sorry if this is going to seem like a simple question, but could you just give us a quick overview of what I Am the Cavalry is as an organization?
Yes.
Cool.
Bo?
Thank you. Yeah, so I Am the Cavalry. Our mission is to ensure that the devices that have the ability to affect and impact human life and public safety are worthy of the trust we place in them, right? So the basic idea behind that and kind of an unofficial slogan is like security of consequence, saving lives through security research. So what we try and do is do education, outreach, and promote research. The idea being education is the people who don't already know about the security and safety link, they should know that there is a link there, and we should invite them to the conversation. Outreach is going and finding them, not just staying in our echo chamber and throwing rocks at them from back here. And then promoting security research is we want to take people who are doing good things and make sure that they have the support that they can have, right? Whether it's media support, whether it's knowing how public policy functions, whether it's knowing the other researchers in their field that are doing similar things so that they don't have to repeat the wheel. The idea is that we want to amplify and magnify the impact and the ability that we have in this community. We already have a lot of great motivation. We need to turn that motivation up a notch with other things in terms of its effectiveness. And I think getting the word out, making those connections, collecting past work and current researchers, and catalyzing good works faster maybe than they would have had happened before. That's our goal. That said, we don't have it all figured out. There's plenty of room for other people to do things if you want to. One of the most important things, I'll go back to it again, is leadership. Just take whatever you're passionate about. Take it and go do it. Let us know you're doing it. We'll help you any way we can.
I have a very literal answer. So I Am the Cavalry is a grassroots initiative that originally started with security researchers saying, oh shit, scary stuff's happening and we should try and do something about that. But I kind of have this asshole view of what I Am the Cavalry is, in that whenever someone asks me, I say, it's you. It's like the game. You're already in the game, whether you want to be in the game or not. And by the way, we all just lost the game. So that's what I Am the Cavalry is. Every single one of you has the potential to make a difference. It's a question of whether or not you will.
Yeah, and we talked a little bit about that last night when we were pitching and brainstorming about a lot of people that were talking about wanting to fix the problems, and long-term, 20 years ago, 10 years ago, got caught up making ungodly amounts of money in the security industry and forgot about fixing the problem. So I would hope that now some of those people are set financially, would like to come back and spend some time on the problems. But I think for me, what I like most about the Cavalry is the piece about getting people together, like you were saying before in the beginning, Bo, getting different groups together in a room and playing facilitator and communicator between, whether it be a government organization, a vendor, a trade organization, different people that aren't normally speaking the same language. And when they do try to speak together in the same language, it ends up they repel each other and it doesn't create good things. So I think that is a really cool piece. Next question, sir. We've got 2 beans now if you want. You can have 2 whole ones. Yep.
Thanks. Oh, right here? Yeah, okay. So I have like a kind of multi-part question, but not really. That's all kind of working together. Sure, let's do that. So how do you think the interaction that power and political economy have in this? Because there was a lot of touching on like profit and the costs of things, but I'd suggest that the power manifests generally in the inability to move from any platforms or make choices, as people were mentioning. Like there's a lot of lock-in, and I mean, if your car is one thing, you can't just swap out the car's operating system. And just how those intersections can actually be used going forward instead of maybe relying on the existing power dynamics that already exist is just my question. How does that affect your analysis?
You have 2. Thank you.
Yeah, I think you definitely deserve multiple coffee beans for that, because it's a really, really hard question. I think you could ask it about anything that you're trying to achieve that is a complex problem, where you have multiple stakeholders involved. But I think that's also kind of the power, is you have multiple opportunities to get in there, right? You don't just have to worry about, well, this power broker over here is talking to this policymaker here, and that's the only way anything moves. You also have standards bodies. Love them or hate them, they have some power. You have the purchasing public, whether that's a healthcare organization that's buying medical devices, whether that's your parents who are buying cars, whether that's the people who are flying in planes, right? We have different power levers, each of us, who are stakeholders in this dynamic. So it's not quite as simple as you might think it is in your mind with the fat cats cuddling up to the whoever else, like in these backroom deals. It's a wide open system. I think that's part of the power of it. It's just a matter of trying different things, right? Fuzzing the chain of influence, seeing what works, what doesn't, repeat the things that work, and drop the things that don't. So that's maybe not a perfect answer, and it's not a prescription, but I think it's the best one we've got so far.
I think one of the important points that your question raises, and I don't know where you went. You went somewhere. Yeah. Hi. Is that as consumers start to purchase progressively more expensive items that are inherently reliant on code, it's not just about building the product correctly, safely, in the first instance, but it's also very important to think about the updating of that product, the constant maintenance of that product, particularly in a world where deployment of new code is not a once in a blue moon thing, but we have constant deployment of new updates to things. Not only building in the first instance in a reasonably secure way, but figuring out a way to have that update chain demonstrate a similarly solid process demonstrating integrity and reasonable security. So the inability of consumers to move away from some of these products that are big ticket items where there's lock-in, as you pointed out, highlights even more fiercely the need for resolving some of these deficits in building and update chain security challenges.
Yeah, so basically to your point, right now the situation's bad and you get locked in. The option is kind of binary right now. You can choose to opt in and get locked in. Oh, sorry. It's because I'm short. Or you can just completely opt out. And there's no kind of middle ground. But the good thing is, to Bo's point, we can create a kind of groundswell. And we can do that by like everybody in this room like posting like negative reviews on something that's not secure, and then like I'm talking to people in DC, and there's a bunch of other people talking to people in DC, and then you guys are doing what Andrea said, and you're influencing the people who manage risk in your organization, be that the lawyers, the CFOs, whatever. Basically, like as much noise as we make, as much noise as we can make in every different realm, as Bo said, there's not just one avenue. We create a groundswell. And so it won't be tomorrow. You won't get up suddenly in the morning and be like, oh my, hallelujah, suddenly there's another option. But eventually we'll get there. Eventually, like if we vote with our feet and we make enough noise, then the vendors will pay attention because, bottom line, they got mouths to feed, they need to make money.
Yeah, I think that those are all really good and practical things if, and again, it's not going to happen overnight. It is going to take time. This didn't happen overnight. And little things, I mean, it may seem silly right now, but, a lot of little Amazon reviews on some really shitty router, printer, whatever it may be, those things do affect change. If you want to, try to restructure EULA agreements, that's a piece. There's tons of other people talking about other solutions in different ways, and there are solutions happening. It isn't all, problem. The fact that what you guys are doing with the cavalry is the beginning of that groundswell. It's exciting. It's, personally what got me excited about, okay, then, there still is a problem, which was kind of a big bummer to see going forward, but really, really inspiring to see that, that groundswell starting. So I'm really hopeful, and I think that if everyone sticks together and, it doesn't just mean one giant group of everyone doing everything, but many small groups doing projects over the next 10 years, hopefully we will not be in this situation, and we'll be up here talking about how it worked and how we can make it even better. So thank you all for coming. I appreciate it. Go to the bar. Thank you, guys. Oh, yeah, and there's more talks. Don't go to the bar, sorry. You can go to the bar after the other talks. Oh, and there's still a lot of coffee beans if anyone wants some.
So basically a dirt catch and release program.
And prevent-a-derp as well. So.
Here's the thing about H.O.P.E that makes me mad is like every company in the world uses OpenSSL and none of them give back to the project. And so it's still about vendors. It's just about a different, like it's a one stage removed, right? Let me just make sure that he doesn't leave the sunglasses. It's like financial organizations and other officers. It's all that, right? Because the banks, they can't afford to support the
Well, I'm just thinking it's like particularly as someone who writes code, it's like, I don't want to like put something on GitHub and then 20 years from now it's like get super.
No, I completely agree. And the challenge with open source is that there's this myth that open source aspect of what is secure because it's
Zimmer. I know. I didn't recognize you. How's it going? I don't know. As I'm wigging out. Hi.
Earlier in the Mac, we had a problem when we just drive the top part of it. Now, where's your monitor control panel?
I'm not sure.
Is there preferences somewhere?
Perhaps. Should I switch to a Windows computer? This is all on Google Drive. I can switch.
Yeah, but let's see what that is. System settings.
All right.
Or try it again. Oh, yeah. Maybe you should try Windows.
All right. Do you have one, or do I need to ask around?
Does anyone have a Windows machine we could use?
H.O.P.E does not support Ubuntu.
Yeah.
You do?
Because it's on
Thank
Google
you.
Drive.
Fantastic.
Keep his password safe. And yeah, that way.
All right. Perfect.
What's the connector in there?
think you got it.
Thank you, sir. I appreciate it. They'll come right back. Hi.
Trying to get you on the screen?
Google is being interesting. All right. I should have it up. Should have it all right. I should be all set in a, well, wait. I know everyone's anxious for me to get going here.
When you're ready, you just tell us, and then we'll start the machine, and then we'll tell you, okay?
All right, give me one moment. All right, I should be ready to go. All right. I'm good to go. Hello, everyone. Everyone hear me? My name is Zimmer Barnes, and I'm here to talk to you all about the end of the world as we know it. So this is Congressman Larry McDonald, and he is a congressman, or was a congressman, from the great state of Georgia. The last 12 minutes of his life was an absolute nightmare. In 1983, he was flying to South Korea to celebrate the 30th anniversary of the United States-South Korean Mutual Defense Treaty. So in those days, in 1983, the plane had both a digital compass and a mechanical one. And this mechanical one could deviate by up to 15 degrees. In this instance, almost immediately upon takeoff, the compass began to deviate as they were using the mechanical compass. This took it hundreds of miles off course and into Soviet airspace, near very important military installations of the Soviet Union. Lieutenant Colonel Ozapovich was dispatched in a fighter plane, and he was ordered to fire on the commercial jet, thinking that it was a spy plane, and he did so. Missile fragments hit the tail end of the plane. It miraculously stayed in the air, but only for another 12 minutes. There were 269 passengers on board KAL Flight 007, and all 269 passengers perished in the crash. This included 61 Americans, 23 children under the age of 12, and Congressman Larry McDonald from the great state of Georgia. The international and domestic outcry is, as you would imagine, Ronald Reagan himself denounced it in his words, "This crime against humanity must never be forgotten, here or throughout the world. Press accounts reflect an explosion of condemnation by people everywhere. Now, what Ronald Reagan didn't mention is this. This is a report on a NATO exercise called Able Archer 83. Able Archer 83 simulated nuclear launches via radio, and it moved 40,000 physical NATO troops across Europe. Here's some troops of NATO that were participating in the Able Archer 83 exercise. Now, the Soviet Union was paranoid enough to shoot a passenger plane out of the air, thinking that it was a spy plane. So they saw this Able Archer 83 exercise not as a simple exercise, but as a prelude to invasion. So this continued around the clock for 3 weeks until we come to Serpukhov 15. Serpukhov 15 is a Soviet military base, and their job is to monitor for nuclear detonations. So for some reference, this is a Pershing II missile. These were installed in Germany in 1983. These could be launched from Germany and reach Moscow within 10 minutes, and everyone at Serpukhov 15 knew that. So it's very crucial that they report these nuclear launches if they were detected. Now, this is Lieutenant Colonel Stanislav Petrov, and he was commander of Serpukhov 15 during the KAL-007 crash and the next 3 weeks after. This is a time of strayed nerves. Everyone's very, very anxious and stressed around the clock. They think that an invasion of the Soviet Union is imminent. And it was 3 weeks after that, after the Lieutenant Colonel Azapovich shot down KAL Flight 007, that the installation and equipment at Serpukhov 15 detected a nuclear launch. Following military protocol, Lieutenant Colonel Stanislav Petrov phoned into his superiors and reported it. However, he stressed that it was his professional opinion that it was an equipment malfunction, that the United States had not fired a nuclear weapon at the Soviet Union, and there should be no retaliation. In his own recollection of this, the instant he set down his phone with his superiors, the equipment went off again and detected a further 4 nuclear launches. At this point, his military protocol is very clear. He is supposed to phone this into his superiors and have no more control over what happens after that. Now, the nuclear weapons that the Soviet Union had were not at Serpukhov 15. So once he made that phone call, he would have no control over whether the Soviet Union would launch a full nuclear strike against the United States. He decided not to follow his military protocol. He took over Serpukhov 15 and took it out of the Soviet chain of command and decided to wait this out on a hunch. And of course, he was correct. There were no nuclear strikes. And it may well be thanks to Lieutenant Colonel Stanislav Petrov that we are all here today. This talk is called Vigilante Justice, Masks, Guns, and Networks. And I chose those 3 words specifically. When I talk about masks, I'm going to be talking about how vigilantes stay anonymous or whether they choose to be anonymous at all. When I talk about guns, I'm not only talking about the weapons they use, but also the tools they use. Many of the world's most successful vigilantes don't use any violence at all. And finally, networks. How they network, how they recruit, and how they collaborate with other vigilantes. So my name is Zimmer Barnes, and I got to grow up in the world that Stanislav Petrov preserved. This is my mom, and you may be able to tell by the picture that this is a mugshot. She was an attorney, and she was first arrested in front of me when I was 9 years old. Throughout her career, she continued to fight for clients that were either poor, women, or people of color, and she frequently had conflicts with police. She frequently taught me to have a very healthy disrespect for authority, and I took this in a somewhat extreme direction. This is me. I'm in the lower right-hand side in the gray shirt with the binary code. And these people are real-life superheroes. Specifically, this is the group Super Anonymous, which was active in New Orleans post-Katrina. We aided the city by rebuilding houses with Habitat for Humanity, aiding the Guardian Angels on patrol, and donating to the homeless. Now, the real-life superhero community has a lot of diversity. So on one end, you have this guy. This is Phoenix Jones, and he's highly controversial within the community. He fights violent crime and often uses violence in self-defense of himself and others. On the other end of the spectrum is this guy, Thanatos. Thanatos dresses in a mockery of death and tries to save homeless and drug addicts in his city from an early death. Provides care packages and counseling for people that are in horrible situations. He's a real-life superhero that never uses violence during his missions and represents the other end of the real-life superhero spectrum. So if you trace a superhero legend back in time, you get to a little bit of a kernel of truth. And that's this guy. This is James F. Phillips. And he began doing missions in 1969. His method of choice was environmental sabotage. There was a local company in Chicago that was pumping toxic waste into a local river, and he would block up the pipes or sometimes take samples of the toxic sludge and splash it about corporate headquarters so the company could no longer pretend that it was harmless. He went by the name the Fox after the Fox River that he was trying to protect. There's quite a bit of evidence that the police knew his secret identity, but never pursued him. And he was the first person to be called a real-life superhero. Now, there's previous instances prior to 1969 where we can look at people and perhaps call them a real-life superhero. All these men, if you're a history buff, you know that these are the Sons of Liberty, and we all know the story of the Boston Tea Party. Activists put on costumes to conceal their identity and appear as a monotonous group and engaged in civic protest. Not very different from our modern-day Anonymous. We all know that story, so I won't dwell on them. Instead, I want to tell you about this guy. This is Nat Kinney, and he founded a group which has a terrible name. They're the Bald Knobbers. And he founded, it's an awful name, and he founded them in 1883. And they look like this. They're actually kind of terrifying. This isn't actually the Bald Knobbers. This is from a 1919 silent film about them, but it's very accurate in terms of their appearance. They're active throughout Missouri, and this time in American history was very volatile. There wasn't a lot of police in a lot of the rural areas, and this organization was unique because they didn't have an overt white supremacist agenda as many vigilante operations at the time did. When you talk about vigilante justice, particularly in the United States, it's really hard not to talk about white supremacy. This is the KKK. They're perhaps the most recognizable of these vigilante operations. And what many people don't know about the KKK is that they've been successfully infiltrated several times. So this obviously is Superman, and he fought Nazis and Hitler in the 1940s radio program. But after the end of World War II, the writers struggled to find new villains for Superman to face. It was very important that they find villains for him to face because they were sponsored by Kellogg's Pep cereal, and if no children were listening to the radio program, no one would be buying any cereal. So they were very desperate for Superman to find some new villains, and they turned to this guy. This is Stetson Kennedy, white gentleman, obviously, and he infiltrated the KKK on purpose. He disapproved of them, and he talked with other members who had become disillusioned with the Ku Klux Klan, and really it was all a big scam. They would drum up a lot of fear of these members, and these members had to pay dues, and it would all go to the higher-ups in the KKK. So really they didn't care about taking over the world or white supremacy per se. It was just kind of a Ponzi scheme. So they turned to Stetson Kennedy, and Stetson Kennedy had infiltrated. He acquired all of this secret information on what was a secret society at the time. This is the 1940s. This is 20 years before the Civil Rights Movement. The KKK is like a country club. But he compiles all this secret information, and he gives it over to the Superman radio program. Instead of going to write a book or go to a journalism, he goes to the Superman radio show program, and they love it because they're looking for new villains because we've ended World War II. They ran away with it. It was called Clan of the Fiery Cross. It was enormously successful at the time. It's available for free online, and I highly recommend it, especially if you are a Superman fanboy or girl. So while we're on the subject of white supremacy, we may as well talk about these guys. These are the Black Panthers, very recognizable group. They were really trailblazers that influenced the missions and activities of vigilantes to this day and borrowed a lot of tactics from the earlier Bald Knobbers. Again, a horrible name. This is the Black Panthers during an armed protest in the late 1960s. One of the things many people don't know about the Black Panthers is that they ran a free breakfast program for kids. The rationale was that kids could not succeed in school if they were going hungry. The federal government was so ashamed at the attention that this gave the Black Panthers that the federal government started funding their own free breakfast and lunch programs in schools, which we have today. You can thank the Black Panthers for your free breakfast or free lunch programs in school. So the Black Panthers were immediately influential. They were active all over. This is a guy named Reverend Ray Broshears. And he was an openly gay reverend in San Francisco in 1973, in case you thought you had a bad day. He would get attacked and harassed by gay bashers. He would call the police. The police would tell the gay bashers that he ratted to the police, and he got the crap beat out of him, and he thought it was terrible. He thought if Black people can form the Black Panthers, he should be able to form his own group, and he formed a group called the Lavender Panthers. And instead of going Instead of arming themselves with firearms, they armed themselves with pool cues and went around in a white van and beat the crap out of anybody that was doing something they weren't supposed to in 1973 in San Francisco. So all of these groups were kind of leading up to these guys as the Guardian Angels. They're also very recognizable. This is the group that patrolled in New Orleans post-Katrina. They're all absolutely badass. And they were founded in the late 70s and followed in the footsteps of the Black Panthers and the Lavender Panthers. So I tried to get as much good citation as possible for this, and I do not have good citation for the story. This is just Guardian Angels legend. But according to legend, there was an NYPD strike. The police officers that were patrolling the city in New York City were getting paid better than police officers that were patrolling the subway. And all the NYPD officers in the subways went on strike. So there's absolutely no presence in the New York City subways in the late 1970s. So it was an absolute disaster. And this guy, this is an aggressively 70s poster. The guy in the middle is Curtis Sliwa. According to legend, he and 12 others McDonald's employees, he was working at McDonald's at the time, went down into the subways and they called themselves the Magnificent 13. They patrolled, they beat the crap out of anybody that was doing something they weren't supposed to and did citizens arrest. And they eventually went on to form the Guardian Angels. They're active all over the world today. Speaking of all over the world, vigilantes and vigilantism is not strictly an American phenomenon. This is the Banda region of India, and it's one of the poorest in the nation. In 2008, a very corrupt power plant cut off electricity to the region and demanded ransom. Essentially, they kept billing people for electricity they had not received. This is India. It was extraordinarily hot here today in New York. In the Banda region of India, it's frequently over 100 degrees, so it's a very big deal to not have any electricity for even a day. And this corrupt power plant cut off electricity for a month. There was no higher agency that was stepping in to help. No larger government was going to stop this. All was lost. Until these ladies showed up. This is the Gulabi gang, and they were started by a woman named Sampat Baldevi. They were able to recruit 400 women to storm the power plant. They broke in, they physically removed the employees working there and locked the facility, refusing to return the keys until power was restored, which it was within 60 minutes. So I love this picture because not only is she in the Gulabi gang pink, Gulabi translates to pink, they're literally the pink gang, but she has her stick pink and she has her nails pink. She's very in the spirit. Like the Lavender Panthers, they carry sticks for self-defense, and here's them training on that. And they very much use these. Their targets not only include government corruption, but also they try to stop child marriages if a girl is being married off at the age of 12, or any kind of domestic violence. You'll just have several dozen or hundreds of these show up in your lawn and tell you very nicely to not beat your wife anymore. And they're very effective in India. So obviously, as a vigilante, when I was a kid, I had a lot of big shoes to fill. And so I joined an organization called the Heroes Network. This was a message board online. And we wanted to see what we could do in one city if we concentrated our efforts, instead of just doing stuff online, individual, all across the world. So Superheroes Anonymous was the organization I was a part of before, but they were very focused on charity, doing stuff with Habitat for Humanity. They didn't focus on violent crime. So our focus was going to be violent crime. And we picked Kansas City, Missouri to do that. It's a very high crime, it was then and it is now a very high crime organization. And I worked with this lady, Nix. You can tell both of us are out in the sun all the time. And Nix was located in Kansas City and knew the area. And she'd been patrolling there since she was 16 years old. This is her in her superhero uniform. And we did a little bit of recon and looked at a lot of gang graffiti in Kansas City. So to me, at the time especially, this seemed absolutely chaotic. I didn't get any information about this. If any of you have been in a street gang, this is going to be a lot more descriptive to you, and you'll understand how these tags can communicate a very vast amount of information to those in the know. So fortunately, our group was blessed by this guy. This is 10. And he came from such a background, and he was able to decipher a lot of these gang tags for us. This helped us focus on what areas of the city we should focus on as being high crime. This is a photo with faces blacked out accordingly of the last day of the Kansas City mission. Great weather, then, but the weekend we were going to go out on our biggest missions turned out absolutely horrible. There was heavy rain and a tornado warning. So no one was going to be out. No one was going to be committing crimes. We'd all traveled all this way for this big experiment for nothing. And I felt like a failure until I thought more about these gang tags and talked with one of our members, Sir Steampunk, who had a really good suggestion. Turns out if you go to a hardware store, you can get spray-on paint remover. You spray it on, it's horribly caustic, it foams up, and you leave it foamed up on paint for about 10 minutes, and then it loosens it enough where you can rub it off with steel wool. So we grabbed several dozens of these cans and split up into teams, one to watch for other people so that we wouldn't be seeing another person to spray and remove. And we were able to remove several hundred gang tags out of the Kansas City warehouse district. Now, if you know anything about gangs, you know that they make most of their money off of drugs. And if you know anything about drugs, particularly marijuana, cocaine, and heroin, you know that it's produced outside of the United States, not grown domestically. So this is Culiacan, Sinaloa, and it's home to the world's most powerful organized crime syndicate. It's named after the Sinaloa region of Mexico. Here it is on the western coast. And they didn't become the largest criminal organization in the world by accident. They had a little bit of help from the DEA. This is David Gaddis, and in 2000 through 2009, he was the regional director of the DEA in Sinaloa, Mexico. And he authorized a deal with the Sinaloa cartel in 2000. The deal was that the Sinaloa cartel could import drugs into the United States without DEA interference if they provided intelligence on other cartels. Pretty sweet deal if you're the Sinaloa cartel. So this deal continued throughout 3 presidential administrations, starting in 2000 and only ending in 2012. Gaddis served no jail time and actually received the Distinguished Presidential Rank Award from President Obama in 2009. So he now heads a private security company and will never see jail time. So the Sinaloa cartel could import drugs as much as they wanted from 2000 to 2012. So they were very wash in cash. They were really bold. They could just drum up as much business as they wanted with no worry of the DEA interfering, and they became enormously wealthy, and they needed to launder the money at a really unprecedented rate. They had an enormous amount of money. I don't know if any of you are fans of the show Orange is the New Black, but it's based on a true story of Piper Kerman, and she was involved in money laundering and received 15 months in prison. And that's very important because I want to talk to you about Wachovia. Wachovia laundered a bit more than Piper Kerman did. Wachovia laundered $378.4 billion with a B for the Sinaloa cartel. So to put this in perspective, this is an amount equal to 1/3 of Mexico's entire GDP that went through Wachovia, little money laundering program for the Sinaloa cartel. The bank was fined less than 2% of their total annual profit for this activity. No criminal convictions were made, no one went to jail. Gets better. Not only did Wachovia get in on this, but also HSBC. They ended up being fined $1.9 billion in 2012 for laundering money for the Sinaloa cartel throughout 2007 and 2008. A leaked internal email from HSBC indicated that the bank was making $2.6 billion in profit just that year from the Sinaloa cartels. Again, no criminal convictions were made, no one was arrested. Now, I don't know how many of you are good on math, but you may not have caught this. They made $2.6 billion. They were fined $1.9 billion. That's $700 million in profit, and no one went to jail. Hooray for HSBC. By the way, HSBC had 2.6 trillion with a T in assets at the time. So this is the equivalent of a man with a net worth of $100 being fined 7 cents. When asked about this to Attorney General Eric Holder, he said this: "I'm concerned that the size of some of these institutions becomes so large that it does become difficult to prosecute them." So he set 2 very important precedents here. 1, money launder for the largest criminal organization in the world, and no one in your organization or bank will go to jail. And 2, we'll make sure that the fine is so low that you'll still make a very handsome profits for your efforts. So the Sinaloa cartel is sitting great. They have this great deal with the DEA. They're running the spy organization on all of their competition, and they're getting to money launder massive amounts of money to where it's not even dirty money anymore. They can spend it on whatever they want. But they did have one really big problem, and that was the price of marijuana. Marijuana was their big cash crop. It was grown in Central America, gets trafficked through Mexico to a lot of people in the United States that want to smoke marijuana. But the price of marijuana started falling really steadily for years, and this was largely due to the legalization of medical marijuana in a lot of states, and also more legal U.S. production. So they get less and less profit from importing marijuana. Like any good company, they turn to a secondary product to supplement their income, and that's heroin. Now, Afghanistan is supply to 90% of the world's heroin, but only 4% of the heroin that's sold and consumed in the United States is produced in Afghanistan. So most U.S. heroin is heavily cut with something called phenolin, and this adds a lot of potency to the drug, and it also makes it cheaper. But it also makes it easier to overdose because the dosage is very imprecise. Most heroin on the streets is 25% pure heroin, but there's no one regulating it. It can be anything you want, so it's easy to overdose. And the demographics of a heroin user have changed a lot over the last several decades. Today, there's a huge survey of a lot of heroin clinics, and not only heroin users, but people who are in recovery for heroin addiction. The average age of 9,000 participants today is 23, is the average age. 90% of them were white, and most of them were in the suburbs. There were at least as many people in the suburbs as there were in the cities. This is not historical for heroin. Usually heroin is a city drug, not a suburban drug, but now it's showing up in all these suburbs because the Sinaloa is so bold and they want to supplement their income by importing heroin. So this is a little bit of a price guide. These figures are imprecise, and the price of drugs can vary all around the world, and especially around the United States. Each state has a little bit different price. But as you can see, if you're a good businessman, if marijuana is $20 or less per gram, $20 a gram being something really, really high end, heroin being $60 to $120 per gram, and meth being $60 to $80 per gram, you'd much rather be in the meth business or the heroin business than the marijuana business today. So this deal with the DEA, but with the Sinaloa cartel, meant that the cartel had to provide a lot of intelligence on other cartels. So they started this huge spy ring so they could keep up their end of the bargain and keep this sweet deal with the DEA. So one of the cartels that they targeted were the Caballeros Templarios, or the Knights Templar. And this is a Facebook post from a low-level Knights Templar member. This is a car filled with marijuana. And it was uploaded to Facebook with the post, Animo plebada puro zacate para los gorritos, which I am told is very Mexican Spanish and roughly translates as, I encourage your crowd that there's plenty of grass for the white people. So this is kind of what we think of as marijuana importers. It's just this great Seth Rogen adventure, and it's just fun, and it's just like any other business. It's not really that harsh. It's not that dark. And perhaps it was a little bit more like that before 2000 and before this deal with Sinaloa. So the Sinaloa cartel starts running this huge spy ring. Knights Templars are getting crushed. They're not laundering as much money. They're not acting so bold because they can get caught by the DEA, and they're being targeted by spies. So it should come as no surprise that they got very, very desperate, and this desperation led to really extreme violence. The next two slides are, I tried not to do them too gruesome, but if you really, really don't like to see dead bodies, close your eyes. This is some of the many, many victims of the Knights Templar. So they knew that the Sinaloa had set up this intelligence gathering operation for the DEA, and they just started killing anyone they thought was a part of it. So this next slide is a little bit more blood, but I do want to show it to you because the back of this man's shirt says Grupo de Autodefensa, and this is Spanish for self-defense group. So no more gruesome slides. You can open your eyes if you were squeamish. These are these auto defense groups. So the Knights Templar became very desperate, and they would dominate whole areas. Whole towns would be taken over, and the Knights Templar would be the de facto government there, and they would run things. And the Mexican government wasn't strong enough to go in and retake the town. But these guys were. These vigilantes were. These are ordinary citizens armed with their own firearms. And in many cases, they were able to successfully go into cities and take them back from the Knights Templar who were in control of them. So at first, the police didn't know what to do with these guys. At first, they targeted the vigilantes as criminals, and then they more or less allowed them in this gray area. And then as they became more and more successful, they started deputizing them as police officers and simply required them to register their firearms. They had this big firearm registration day in Mexico. It was enormously successful. People came in to register their firearms and essentially moved from vigilante to police officer. And this is Hipólito Mora. He was one of several Auto Defensa's founders. He was arrested. He's now out on bail. He hasn't gone to trial. A lot of this stuff is still unfolding, and we don't know how it's all going to end. Now, I did stress that a lot of vigilantes were successful, even if they didn't resort to violence. So I do want to tell you about this lady, Amina Matthews. So she was the daughter of Jeff Fort, And he was the founder of a group called Al-Rukn, and that is Arabic for the foundation or the corner. And Al-Rukn was considered the world's first super gang. Mr. Jeff Fort worked with Gaddafi's Libyan government to secure weapons to commit terrorist acts and bombings inside the United States. For this, he is serving life in prison. So Miss Matthews really is kind of like a princess or a queen in the criminal underground. Her father founded this radical organization. She could have gone on to import drugs. She could have run a cartel, a gang, become a terrorist. And instead, she worked with a group called Violence Interrupters. So she uses her prestige in the criminal world to mediate disputes between street gangs. She tries to find a peaceful solution to these disputes and minimize bloodshed and minimize shooting in the streets and all these turf wars. With the Sinaloa cartel pushing more and more heroin into the United States and into the suburbs, there's a lot of disruption in street gangs in terms of where their turf used to be and where it is now. So Miss Matthews and the Violence Interrupters certainly have a lot of work cut out for them. So meanwhile, the real-life superhero movement continued to grow in size and popularity, and we gained a lot of media around the world. And in some ways, this was great because we could use this media attention to shed light on problems like poverty or homeless or violent crime. I had one guy interviewing me, he's like, well, why do you dress up as a superhero to do all this stuff? Why couldn't you just do this as a person? I was like, right next door, there's a soup kitchen. They've been up and running for 20 years, and no one is ever going to interview them. They're never going to be on CNN. But I can, an activist can spend $10 on a cape and a mask, and now they've hijacked this media obsession with weird stories, and now they are on CNN and they're talking about poverty instead of Britney Spears shaving her head. So I was very excited about the Kansas City mission, and a lot of people were, and we wanted to see what you could do if you could do Kansas City every weekend, if you could have a team operating in one city all the time. And so I was able to co-found a group called the New York Initiative. And so me and several others moved to New York, all lived in one apartment. These are all my roommates and colleagues on this team. From left to right, it's me, and the back is Lucid. The lady's name is Saf, and the guy on the far right is Zero. And we came to New York at a very interesting time. We were here only a few months before the NYPD tapes dropped from the Village Voice. So the NYPD tapes were collected by an officer named Adrian Schoolcraft. And he was an NYPD officer who wore a voice recorder on his uniform for an entire year during roll call and every private conversation he had with his superiors, and basically uncovered every kind of police corruption that we have a law for and a name for. So there was very overt racial bias. There were stop and frisk quotas that were supposed to be illegal. Worst of all, they were downgrading crimes. There was one instance of a serial rapist who raped several women, but every time it was reported, they would downgrade it to an assault, because they didn't want a rape on their district, on their precinct. So they would downgrade crimes. If it was a rape, they would downgrade it to assault. If it was an assault, they would downgrade it to harassment. People would call and say, my house was broken into, and they would tell them, if you're lying, we're going to find out, and we're going to come after you, you better not report this. So he uncovered all of this. It's all on tape, and the Village Voice ran with it. And one of the worst was, for an area of tens of thousands of people, sometimes there's only 3 to 9 parole officers on duty, and as you can saw, we were kind of 3 to 9 parole officers. So it kind of encouraged us to be a lot more active in our missions, especially in the more violent parts of Brooklyn. So we know stories about Adrian Schoolcraft, people like Chelsea Manning, people like Edward Snowden, who infiltrate an organization and then they do a leak. But sometimes you have to be very forceful. And that's the story I want to tell you next. So this is John and Bonnie Rains, and they're 2 of the 8 vigilantes that formed the Citizens Commission to investigate the FBI in 1971. So they were concerned because they thought that federal spies were infiltrating and disrupting the civil rights movement and several other anti-war demonstrations and a lot of other activist organizations in the 70s. But they had no way to prove it. So if they went to the press, no one really cared. So they decided that they were going to do something really radical and commit the second most important heist in American history. So they decided they were going to just straight up break into the FBI's office. This was the early 70s. There were no digital files to hack into. They were going to go in and steal physical copies. And they decided that they were going to do it on March 8th, 1971, because this was the night that Joe Frazier was going to fight Muhammad Ali right across the street at Madison Square Garden. So at the time, Muhammad Ali's record was 31-0. Joe Frazier's record was 26-0. This was huge. Everyone was watching this, and they thought the streets were going to go crazy, when one of them won, and the police would be busy. And so they decided this is the perfect night to go to the FBI headquarters, pick the lot, break in wearing suits, find every piece of paper they can possibly find, load it into briefcases, and get out without anyone noticing. By the way, above the FBI offices was an apartment where an FBI agent was living and sleeping at the time, and they managed to break in, get the files, and get out without him knowing. So they're unloading all these documents, and they find this gold mine of a program called COINTELPRO. And this was an FBI operation to do exactly what they thought they were doing, to spy on and disrupt activist organizations across the United States. We or at least I vaguely was aware that the FBI was wiretapping Martin Luther King, but this is how we know about this. We don't know about this because of a whistleblower or a Senate investigation. We know about it because someone committed a heist. So they took these COINTELPRO program documents and they copied them and sent it to major news outlets. They sent it to the New York Times. They received these documents. The FBI ordered them to be returned to the FBI, and the New York Times complied. They also sent them to the Los Angeles Times. They received these COINTELPRO documents. The FBI ordered them returned. Los Angeles Times complied. They also sent them to the Washington Post. They received these COINTELPRO documents. The FBI ordered them returned. Katharine Graham was editor at the time, and this was 1971. She was the only female editor of a major newspaper in the United States. She had every reason to follow her colleague's plan and simply comply with the FBI and turn over the documents. When the FBI asked her to turn over the documents, she told the FBI that they could read about COINTELPRO on page 1 of the Washington Post. This is how we know. This is how we know that the FBI was trying to disrupt. Thanks to her decision and her decision alone, we know that the FBI was trying to not only spy on but also disrupt Dr. King and the civil rights movement. There was even a plan to discredit Martin Luther King or take him out and have him replaced by a civil rights leader who would be more to their liking. And also they were domestic wiretapping on a really massive scale. This was 1971. No one was paranoid about this, and now we are. So meanwhile, in the present, the New York Initiative was really taking off, and we were followed for several months by a documentary crew. And their footage was eventually sold to HBO, and it aired in this documentary called Superheroes. It's now on Netflix if anybody wants to see it. And as soon as it aired, we began getting a flood of emails and requests to join. People that were former military, firefighters. So it was really great for recruiting. We went from an organization that looked like this to an organization that looked like this. And we could suddenly have a lot more possibilities at our disposal. So one of the guys that we recruited was this guy. His name is Shortcut. And he's absolutely amazing. And Shortcut was really helpful during Occupy Wall Street. I don't know if any of you were following Occupy Wall Street, but it originally started as this Twitter account that was called Day of Rage, which was also from the 1970s. The 1970s was a big day of rage where people did a lot of activism. So there this Twitter account called like the new Day of Rage that we're going to do this thing. And it was really mysterious what was going to happen. And what ended up happening was the first day of Occupy Wall Street. So these are some photos that Shortcut took of Occupy Wall Street. If you look, I'm the guy in the camo pants and black hoodie and shaved head to the right next to the yellow poncho guy. So this is Occupy Wall Street in Zuccotti Park. So at the time, the mayor of New York City was Michael Bloomberg. He was a billionaire, and this is a movement of the 99% versus the 1%. So he was very cautious and didn't want there to be any disruptions between police and protesters. So what he did was he had police surround the perimeter of the park to make sure they didn't bother anybody outside, but they were pretty much under strict orders not to go into the park, pretty much for any reason at all. This is an intentionally blurry photo of me and a guy named Shade, who was also on the team, under that big large metal sculpture that's outside the park. So since the NYPD wouldn't go into the park, it was essentially a no man's land. You had a lot of college kids who thought, oh, the community will watch my MacBook Pro. And that's not how New York works now, and it's not how it ever worked. And so a part of our mission there was to provide security. There really wasn't a good security force until we got there. And also part of our reason was to aid in medical emergencies. Here's the last gruesome picture. This is one of our members, Blitz. He's attending to this protester who has a medical emergency. Blitz and I ended up switching back and forth. There was a medical area of Occupy, and then there was the security patrols. If medical was understaffed, I'd go to medical. If medical was really well staffed, I would go with the security patrol. On one night of Occupy Wall Street, I'm sad to say that a woman was sexually assaulted by another protester. He held her down in her sleeping bag and rubbed himself on her. The NYPD were under strict orders to not enter the park, even to arrest a rapist. The New York Initiative worked out a deal with the police that if we could bring the alleged rapist out of the park by force, and the woman was willing to make a statement, they would arrest him. And I'm very proud to say that members of the team were able to get the guy, physically remove him. The woman did make a statement, and the man was put under arrest. So this kind of leads me to Anonymous in talking about Occupy Wall Street. And there's many, many stories of Anonymous that I could share that could take up, hours and hours of a presentation. So I'll just focus on this one. This is from KY Anonymous. He gets the KY from Kentucky. And he was putting up these YouTube videos because he was very certain that there were guys on this local high school football team that had committed rape. Turns out he was right. He got smoking gun evidence. And these two guys, Trent Mays and Malik Richmond, went to jail for 1 year and 2 year sentences, respectively, for rape. Yes, rape. So one of them got 12 months for rape. The other got 24 months for rape because he also took pictures of the victim nude and distributed them, and this was considered harassment. So he got another year. So together they have 3 years in prison for rape. But they also went after KY Anonymous and discovered that it was Derek Lowstutter. And he's currently facing 5 years in prison. More than twice, more than the two rapists combined in their sentence. So it's a story where he was very successful, but it's also a very tragic story that he's facing more jail time than a couple rapists that he exposed. So while hackers are being targeted, so too are environmental activists. 711 environmental activists were assassinated over the past 10 years. 106 were assassinated in 2013 alone. So 711 over 10 years, 106 just in 2013. Most of these assassinations occur in Brazil, Peru, the Philippines, or Colombia, and most assassins are never brought to justice. And it seems to be increasing. Like I said, in 2013, there were the largest number of environmental activists killed on record. These are some local protests that are part of a tribe in Brazil that are protesting a summit on behalf of the rainforest being destroyed. There's also been a number of anti-government uprisings, starting with the Arab Spring, but continuing around the world. This is a photo that the story kind of went viral, of these Ukrainian protesters in the uprising in that country holding up mirrors to shame the police. But the Ukrainian uprising wasn't just nonviolent, holding up mirrors. This is a scene that may look peaceful, but if you look closely at that guy in the pink blanket, what he's using as a pillow is what's called a trophy shield. This is a shield that he took from a riot cop, probably by force. So this Ukrainian uprising made their own kind of Occupy-style base in the center of a city and disrupted traffic. In the winter months, they built it out of snow and made this kind of ice fortress, and then later they made it out of tires once the ice started melting. And I want to talk to you about Żelazna Sotnia. Translated from Polish, that means the Iron Hundred. These were mostly former military members that were the most militant members of the protesters, who acted essentially as a security force to protect the protesters and their encampments from riot police. This is a far more violent protest than Occupy Wall Street was. This scene is them mourning comrades who were killed during struggle with riot police. So there are a lot of major issues, not only with various governments around the world, but also our own criminal justice system right here at home. And one of those issues, unfortunately, is its very legitimacy. This is the Juvenile Law Center, and they helped uncover something called the Kids for Cash program. Kids for Cash program went like this. These are two judges, Mark Ciavarella and Michael Conahan, and they were convicted of this Kids for Cash program. They had to deal with private prisons where there would be this juvenile offender who would come in for graffiti or talking back to his parents or any kind of minor offense, and he would give them the maximum possible sentence and send them specifically to this private prison instead of the public system. And so the private system then got money from the government because they were housing this prisoner, and then they would give a cut of that back to these judges. So these judges were making money off of sending kids to prison regardless of whether they were innocent or guilty Fortunately, the Juvenile Law Center was able to uncover it. This is one of my favorite pictures from this story. This is a mother of one of the victims of the Kids for Cash program. She's yelling at the judge that illegally sentenced her son after he was convicted of the scheme. So even if you get convicted of a crime, we don't know that you're guilty. This is some statistics from the Innocent Project. Over 300 people have been convicted of serious felonies like rape or murder that have been proven innocent beyond a shadow of a doubt because of biological evidence. So the Innocence Project works with this biological evidence and tries to clear people's names if they believe that if they truly are innocent. But the vast majority of these cases where it's rape or murder, 90 to 95% of these felonies don't have any such conclusive evidence available at any time. So they're really only working with that 5 to 10% where they actually have evidence. And they've already uncovered 300 people that were completely innocent of the crime they were convicted of. And these 300 people served together over 4,000 years in prison for a crime that they didn't commit. Across the United States, there's a lot of militia groups that are popping up. One of the oldest of them is called the Minutemen, and they patrol the Mexico-U.S. border. They're very unique. They have a very strict non-racist policy. If any of their members are expressing any kind of racist sentiment, they're kicked out of the group immediately. This is not so for all militia groups. This is a Michigan militia. Here's another one. So in 2008, not that long ago, there were 149 active militias in the United States. Even if you don't follow this closely, you may be vaguely aware that there's more now. Maybe there's twice as more, 3 times as more, 5 times as more, but there's actually 8 times as much. While in 2008 there were 149 active militias, in 2013 there were 1,096, and of these, 240, explicitly say that they are armed militias. The vast majority of these are nonviolent, but they do prep for a future where times may become chaotic and they may use violence to achieve their ends. So this is a map of stand your ground laws. We all know the stand your ground case because of the killing of Trayvon Martin, and Florida got a lot of heat for having the stand your ground law, but actually from this map you can see that a lot of states have adopted it. 25 in total have a stand your ground law, and this means that if you feel threatened, if you feel like your life is in jeopardy, you can shoot at someone. If someone breaks into your house and then they flee, you can chase after them. So you can take yourself out of a safe position, put yourself into a dangerous position, and go and be aggressive against someone that's trying to hurt you. So these are some statistics about stand your ground laws. These are all different states. The red lines are states that have a stand your ground law enacted, and this is statistics of incidences of justifiable homicide since the law has been enacted. The blue lines are states that don't have a stand your ground law, and as you can see, there's this enormous rise in justifiable homicides in states that have this stand your ground law. And so I think this is unfortunately going to continue to accelerate in these states. One thing that I'm worried about and the media goes nuts over, and I think all of us are at least a little bit concerned about, is 3D printed firearms. This started off, they were just terrible. Even 6 to 12 months ago, 3D printed firearms were just a joke. But then they came out with this one not too long ago. This is a 3D printed firearm, and it fires 9 shots total, and the materials cost only $25 to make. So what I'm concerned about is this. This is the AK-47. It's the gun of choice in conflicts around the world. So if you are part of a terrorist organization or a militia or a government or anyone that's trying to buy a black market AK-47, these can run anywhere from $500 to $2,000 depending on the region of the world you're in, and these have a global average of $532. So my question is, and I think it's a question that's going to be answered very soon, is if you have a 3D printed handgun that you can make for $25, could you conceivably make a 3D printed AK-47 for $100? And if you can, how soon, and what does that do if you're a small organization, you have a limited budget, you're going to war on a dentist retirement account, instead of spending $500 for an AK-47, if you can spend $100 on an AK-47, you get 5 times as many AK-47s. So this new technology is going to, I think, drastically change the balance of power in a lot of very unstable regions of the world. While we're talking about firearms, of course, we need to talk about drones. We've all seen this, the Drone Survival Guide. I think very soon we'll also see, right around the corner, $100 drone that could be used for surveillance or even assassination. Right now, these are tools used by the United States. There's some other governments getting into this. I think very soon they're going to get down to the point where it's going to become very, very affordable for anybody with $100 to have drone that you can rig up with nitroglycerin or have your own surveillance network of drones. And I think that's going to get very interesting and very dangerous for some already dangerous parts of the world. Now, there is a bit of precedence for vigilantes using unmanned aerial vehicles in dangerous or illegal missions. This is Park Sang-hak, and he fled North Korea, born in North Korea, fled, and now he has this program where he launches drones from South Korea into North Korea. North Korea is completely locked down, no internet, no information in and out, no major newspapers, no freedom of speech. And so he launches these drones, and this is what they look like. These are the balloons. They're set with this pre-pilot course that fly over and then drop contraband. And some of this contraband flown in and dropped into the country includes some stuff that we wouldn't think is very important, but is very, very important in North Korea. Some of the things are thumb drives that contain all of Wikipedia. Since you can't get any information, you can give them an entire encyclopedia that they connect to their computer. They also have VHS or DVDs, copies of soap operas. And this is simply to show average standard of living outside the world. Inside of North Korea, it's kind of said, like, the rest of the world is crap. Everyone lives like this. And they can show, no, in fact, just across the border to South Korea, everyone lives a very Western kind of lavish lifestyle compared to the poverty of North Korea. Excuse me. And another thing that they drop in are radios that are pre-tuned to stations that broadcast news from South Korea into North Korea so that people can get real-time information. One more vigilante that I want to talk to you about before we go, and that's Mary Bowser. She was born in 1840 as a slave to an owner, Elizabeth Van Lew, in the United States. So fortunately for Mary Bowser, Elizabeth Van Lew was an abolitionist, and Mary Bowser had an enormous amount of privilege for someone that was born into slavery. She was able to attend an education, she was able to travel abroad, she was a missionary in Liberia, and she traveled all over the North. So what may not have been known to her at the time, but was revealed to her, was that Elizabeth Van Lew was secretly running a vigilante spy ring that sent intelligence to Union generals. These weren't government employees, it was an absolute vigilante operation. So Mary Bowser was very important. Not only was she extraordinarily intelligent, but she was gifted with an eidetic memory. We kind of think of fictional characters like Lex Luthor from DC Comics or Dr. Sheldon Cooper from The Big Bang Theory. It's kind of this super photographic memory, but it really does exist. It's not a fantasy, and Mary Bowser was so gifted. If she saw something, she could remember it. And so these two women concocted this extraordinarily high-stakes plan. The plan was that Mary Bowser would sell herself back into slavery so that she could work at the Confederate White House, possibly get access to some illicit information, possibly be able to ferret that information out to these Union generals. She risked being trapped into slavery forever if the South won the war, endure extreme violence against herself, and possibly even be killed if she were exposed. Fortunately for all of us, Mary Bowser accepted this extraordinarily dangerous mission on behalf of this vigilante spy ring. She crafted this persona of being very feeble-minded, and she'd be cleaning or attending to things while these generals were having the meeting right there in the room. And then when she would clean offices, she would have access to all of these written documents, all of this correspondence. And she was able to remember all of it verbatim and then ferret out that information. So after the war, Ulysses S. Grant and many other Union generals credited Van Lew's vigilante spy ring as the best source of information during the war above any other government employee. In turn, Miss Van Lew credited Mary Bowser as the very best source of intelligence. After the war, the Union destroyed all records of this vigilante spy organization, including everything related to Mary Bowser. So we're never going to know exactly how big of an impact she made, but we could conclude that it was very substantial. It became kind of obvious in the Confederate White House that there was information ferreting out, and it kind of comes to this legend that I do not have solid verification, but I'll tell you the legend anyways. According to legend, they found out that it was Mary Bowser. Mary Bowser fled the Confederate White House, but not before setting it on fire. And so, like Stanislav Petrov, we can perhaps take a moment to thank Mary Bowser for all of us being here today and for the state of the world being what it is. So that's a very dramatic story, and I've told you a lot of dramatic stories, and I'll close on one that's a little bit less dramatic. My birthday's in January, and for my birthday I really didn't want to do anything special, and my friends wanted a party, and so I said, well, don't get me anything, just get like old clothes you're not going to wear, or socks, or canned food, and we'll go and distribute it to the homeless. And we actually really like this. We went and decided to do it just once a month, and once a month we've done this kind of social thing. Here's all my friends hanging out. We would go to this restaurant eat a bunch of food, then go to our cars, unload clothes, socks, toothpaste, shaving razors, food, blankets, to the homeless that were sleeping outside the center in Austin. I live in Austin, Texas. The center closes at a certain time, and then people sleep outside. Austin's very hot, and the temperatures can drop really suddenly, and people don't have time to get indoors, but they don't have time to get blankets, and people are frozen to death. And so we distribute stuff, and then we go party and drink. And so it's a nice social event, but it's great to make things more accessible to people that want to get involved in charity, want to get involved in making the world better, but it just seems like this insurmountable problem. This makes it kind of accessible. And I'm really grateful to all these guys for that. And I want to close with this. If you look at human history and current events, in times of chaos, it's always criminals, or at least someone with a criminal mindset, that sees the reins of power. So in future times of chaos, my hope isn't so much that this will change, but my hope is that the criminals that seize power are those that share my values. Throughout your life, you'll have the power and the possibility of helping others, whether it's a single person or perhaps like Stanislav Petrov, the entire planet, and I wish you wise judgment. We give a very special thanks to a few people. I'll read this off real quick. Special thanks to Sir Steampunk, Janice Kelly, Nex, Hard Knock, Trevor Barnhart, Shortcut, 10, Nix, Saf, Zero, Lucid, Snipe, Blitz, Angel, Carolyn Barnes, Jim Barnes, Peter Tangen, Theodore James, Michael Barnett, Jason Small, Mitch Altman, Michael Hertel, Marcin Wazinski, Malik Sullivan, and Haitham Nasser. Thank you all very much. So this is my index if any of you want to look up on all the information that I drew from to create this presentation. It's at tinyurl.com/KQ57Y8F. That's tinyurl.com/Kilo Quebec 57 Yankee 8 Foxtrot. You can contact me at zimmerbarnes@gmail.com. All right, that is my presentation, and I think at this point we can open it up to Q&A. I am not sure where a microphone is. So do you want to start queuing up people? I guess you can just, I guess we can make a line in the center, and I guess you can speak loudly until we get a microphone to you if anyone has any questions.
Well, have you considered, like, mutagens,
I think there's a presentation tomorrow on do-it-yourself biology and biohacking, and I would direct all those questions to them.
What's your progress
On the Iron Man suit. Depends on which one. There was a guy named Citizen Prime who made his own $5,000 suit of armor that's extraordinarily bulletproof. I'm working on a segmented Kevlar vest at the moment. Several other people are working with armor. There's powered suits. Problem with powered suits is battery life. They look great when you see these military suits and people can bench press a car, but it's not that great when they only run for 15 minutes at a time. So we kind of have to solve the battery problem first. Anybody else hear somebody? Yeah, well, it varies around the world, and I wanted to include that the information about the Mexican autodefenses groups because they went from vigilante to mainstream, and also people like the Fox were vigilantes where the police knew his secret identity but didn't go after him because they approved of his activities. Really comes down to the individual police officers. A lot of times we see the police as one monolithic group, but they're people just like us, and each police officer is going to have his own opinions and make his own decisions in terms of what priorities should be. Sure. Could you speak up a minute? Just a little bit.
Along the lines of the law, you brought up COINTELPRO. What should we as citizen activists do to thwart the efforts of the establishment trying to thwart our efforts?
That's a big question. What effort specifically?
So Occupy Wall Street was infiltrated by agent provocateurs, right? And this has happened repeatedly throughout the citizen activist movement. So how should we approach, validating each other? How should we approach keeping an eye out for the bad guys? What do we do?
Most people that infiltrate will seek to disrupt and splinter the group off into a lot of different groups so that they're less powerful as a force as a whole. And this is really relevant to the hacker community. His name escapes me at the moment, but the man that organizes DEF CON every year recently made a very inflammatory statement where he estimated that 1 in 4 people in the hacker community were FBI informants. So look to your left, to your right, in front of you and behind you. Either you are the FBI informant or someone very near you is. So we definitely do need to be careful. And if you wanted to keep a group, if you wanted to have a group stay powerful, you would try to resist any efforts to splinter off into different groups or focus on differences. You would want to focus on similarities or common goals, would be my advice. Light. Yes, sir.
With migrant vigilante groups, have you run into trouble with not knowing who to go after, putting innocent people, and what you know has been done about that?
There's certainly a big difference between vigilante justice and mob justice. Most of the stories I told you were individuals or small organizations, with the exception of the Gulabi Gang. The Gulabi Gang, you could certainly argue, is practicing kind of a mob mentality since they use overwhelming force. So I think there is a difference, I think, between one person acting and then a whole group kind of being swept up in this emotion and going forward. And unfortunately, things like mob justice, especially these days with social networking, can be whipped up really, really rapidly. And I don't think there's much that any single individual can do to stop this except pull the plug on the internet, which has been tried, sometimes successfully, sometimes not. Yes, sir. I can barely hear you. Could you speak up, please? The police do operate several of those. When I was active in the New York Initiative, we took a lot of crime blotter information and put it into maps so that you could see what areas were dangerous, and then we color-coded it so we would have an area for carjacking. So like, don't park your car here, or muggings, don't go out here. And then we had another map that was time-stamped, or it was color-coded by time, so you could see. It's not so much that this neighborhood is dangerous. This neighborhood is dangerous between this time frame. And then when you go later in the day or earlier in the day, it's not dangerous. So there's certainly efforts like that, and there's stuff like the NYPD Most Wanted. I was really excited. I was on the subway, and in the booth, there was a poster that the New York Initiative made of wanted criminals. The problem with the poster wasn't outside the booth, it was inside the glass, facing out. And I asked the woman where it had come from, and she said that a police detective had put it there, which is absolutely mind-boggling to me for us to kind of gain that kind of legitimacy. Anybody else? Oh, thank you. Thank you all for coming out. All right. Again, all of my research is here at this link, and my email is up if you have any more burning questions. the people that weren't there.
Yeah, and the same, like even, and this was in Australia, and they had kids for care, but they also would send them, you know, desperate people, they would send them overseas to sort of get them cured from drugs and things like that, but the stuff, they never came back. It was extremely kids.
Is there any media accounts of that? Like, have you talked with any journalists?
Yes, in Australia, but you see, I got so discredited, and that's why I'm here now, and I'm just going to write about it.
You should,
Yeah,
absolutely.
except that I'm so scared because my son's dead. So,
Yeah, absolutely.
you know, because they send them in, anyway, I'll email you.
Please do.
Because I'd love
What is your name?
Kiri.